Semiconductor, Dr. Walden C. Rines. Let me introduce him. He is the President and CEO of Emeritus and Konami Incorporation, a fabless semiconductor company focused on intelligent computing. Dr. Rines was the former CEO of Mentor Graphics for 2.5 decades and chairman of the board for 17 years. During his tenure, market value of the company has increased to 10x. Prior to Mentor Graphics, he was an executive vice president of Semiconductor Group, responsible for TI's worldwide semiconductor business. Also served as several boards in various capacities. And he was a chairman of Electronic Design Automation Consortium. For a decade, he has completed 5 two-year terms. He is a lifetime fellow of IEEE. Dr. Rines holds a bachelor degree of science in engineering from University of Michigan, Master of Science and PhD in Material Science and Engineering from Stanford University, and Master of Business Administration from Southern Methodist University, and Honorary Doctor of Technology degrees from the University of Florida, Nottingham Trent University. It is a warm welcome to you, sir, to address the delegates of this morning.
Thank you, Satish. Hey, I hope my friend Satya Gupta is in the audience here today, because I want to talk about AI as it applies to data. So let me go to my slides. Let me see, right here, yeah. A moment. And talk about how big data drives really a new era for artificial intelligence. So think about artificial intelligence back over the last 35 years. Let me take you back to High Technology Magazine. This is the cover 35 years ago. And it says, artificial intelligence, heavyweights get into the act. Now, I know it's hard to recognize me with that much hair, but that's me in the picture. And this is George Halmeyer, who was the head of DARPA, the Defense Advanced Research Projects Agency. And we were in the business of artificial intelligence. But you know, there wasn't much business. And there are a lot of reasons. There was a lack of big data to analyze. We didn't have an Internet of Things. There was limited computing power. There was a need for more advanced algorithms. And really, the biggest thing was there was a lack of killer applications to make money. One by one, these limitations have disappeared. So today, new applications are driving a lot of momentum, and it applies to the semiconductor industry as well, because the semiconductor industry is driven by applications. Every major wave of growth in the semiconductor industry comes with an application. Mainframe computers, standalone PCs, notebook PCs, mobile communications. I think the latest one could be grouped together as data. Well, people talk about a lot of other things. They don't just talk about data. They talk about the role of artificial intelligence, machine learning, IoT, 5G communications. But you know, all of these things have one common factor, and that's the fact that they're being impacted by the effects of large volumes of data. We're building machine learning models with AI. IoT is bringing computation closer to the point of data collection, and 5G is dealing with real-time communications for factory automation and autonomous drive vehicles and other things. So while artificial intelligence is not new, what is new is the fact that the quantity of data to be processed is very new. Data, as many have said, is the new oil. It contains all of our experience, our know-how, our insights into what we deal with every day, and it gives us a basis for analyzing the way the world works and predicting how things might evolve in the future. Quite a while ago, I looked at the business of aircraft manufacturers who made engines for airplanes. Pratt & Whitney, General Electric, Rolls-Royce, companies that make those engines, monitor them all the time. So it doesn't matter what airline you're flying on, the fact is they're monitoring the behavior of the engine. And it's a lot of data that they produce. In a 12-hour flight, 844 terabytes of data. All that data is collected to do predictive maintenance analysis and to determine, are there any problems? And so the manufacturer of that engine, regardless of who is using it, has a monopoly on the behavior of that engine. So aircraft engine manufacturers could give away the engines for free and just charge for the support and the maintenance because you can't afford to fly your airplane without it. Well, today I want to talk about three aspects of data and how we're making it the new oil, the store of wealth: the collection, the analysis, and the protection of that data. Let's start with the collection. We're collecting a lot more data than we can analyze. By some estimates, we only analyze about 2% of the data we collect. That's been accelerated to petabytes per day with video data, surveillance monitoring, all the video we take for all the things going on, and related information for a variety of applications, image processing and other things. But sensors everywhere are collecting a lot of data. And for the semiconductor industry, that's been a challenge, developing sensors that can collect that data. After all, you have to have a sensor. Maybe it's a different technology like MEMS or a thermal sensor. And then you have to be able to convert the analog to digital. And then you have to do some sort of memory store and possibly local analysis of that data. And then you have to transmit it through a serial link, through RF communications. That's very tough for design engineers because you're combining multiple technologies together. And to simulate a module like that is quite difficult. So you would think that the semiconductor industry was raking in lots of money developing these things. But in fact, they're not. They're at the bottom of the food chain. The people who develop the sensors and the engineered packaged solutions don't collect very much money. It's the people who collect the information, they analyze it, and they use it, and they sell the results back to you. Well, about 5 years ago, I was attending a design automation conference presentation by some engineers at Google, and they were showing how they had developed a chip to be embedded in a contact lens that would sense in the liquid of your eye the balance between glycogen and insulin, and therefore be able to control an insulin pump you would carry on your body through your iPhone or through your cellular phone or whatever. And the person next to me turned to me and said, "Oh my gosh, Google is getting in the semiconductor business." And I thought about it, said, Google's not getting in the semiconductor business. The semiconductor business is not that good a business. They're in the information business, collecting the information from you, being the interface to your doctor, being the organization that can help you use that information to provide better health for over 380 million people. Well, that's spread. Systems companies everywhere have jumped into the game of designing leading edge chips. And that's what's propelling the growth of the EDA industry from what used to be a 3 to 5% per year growth rate to now a 9 or 10% per year growth rate. It's the Googles and Facebooks and Amazons and Alibabas and others, but it's also the automotive companies, the OEMs and the tier ones. All these people are designing chips and collecting data. Tesla impressed everyone with a very impressive AI chip for machine learning, customized specifically for the operations required in operating a car. If you look at who's buying the foundry wafers today, go back 10 years, and basically it was fabless semiconductor companies for most of the business, and then integrated device manufacturers, Samsung, TI, Intel, and others for the rest. Almost no systems companies, no Apple computers, no Alibabas, Facebooks, Amazons. Look at it now. Almost 20% of those wafer purchases are from systems companies who are in fact becoming their own semiconductor suppliers, designing their own chips and using them for differentiated value. Well, let's look at the analysis. Domain-specific processors have emerged that handle large amounts of data and allow us to analyze it and gain insights. Now, traditional computers are von Neumann architectures. They have memory and they have operations, and they take something from memory and they operate on it and they put it back into memory. That's the way computers have operated for 70 years. But it's not very efficient for a lot of the operations we're talking about in artificial intelligence. Good example is pattern recognition. And the other thing is, while your brain is orders of magnitude more efficient in recognizing a pattern, or you pick up the phone and in milliseconds you can tell who's talking on the other end of the line, your brain does it very well. Digital computers don't. But what's more important is the use of power. 9 orders of magnitude between the difference of how much power your brain consumes versus what a typical chip consumes, performing the same pattern recognition. So we're attacking that. We're putting neural networks on chip, and these neural networks are growing in the number of layers. And as they grow in layers, they grow in intelligence. And we build in information through training, and we build coefficients that are then part of the intelligence base of that neural network. And that increasingly is building massive stores of intelligence information that we can use by inference to gain conclusions of the information we've stored. This has not missed the semiconductor industry. We had, in the year 2000, a peak in venture capital funding of semiconductor startups. It went to about $2.5 billion, and then it went into decline. It was no longer fashionable to invest in semiconductor fabless semiconductor startups, and so the investments dropped to below $500 million a year. And then in the year 2017, all of a sudden it took off to 1.6 billion, and then to a new record at $3.5 billion in 2018, and it stayed around $2 billion per year, because we need new architectures to analyze the data that we're generating and that we need to use artificial intelligence to analyze. Well, where are those designs being applied? Well, most of them are for artificial intelligence and machine learning. Of those total number of dollars between 2012 and 2019, most of them went into designing chips that were non-conventional architectures. And what were the applications that they were targeting? Well, I've collected them here and just added them up numerically. The largest category is pattern recognition. And that covers a lot of things. Of course, visual and facial recognition is the largest part of it, but it includes other things. For example, voice and speech recognition, and the disease diagnosis, analyzing an MRI or an X-ray, which computers can do much more reliably than humans, and a variety of other things, including autonomous drive. Good example, SenseTime, about to go public this year. It has a valuation of over $12 billion, $1.6 billion of investment in venture capital. They're doing their final round before going public. Enormous amounts of money, but then again, China has over 1 billion people where facial recognition is very important. The second largest category, the data center, high performance computing, the cloud AI, an area where really NVIDIA has dominated with the parallelism that exists in graphical processors. But there are new architectures coming along. The TensorFlow processors from Google are a good example, where they have servers in their data centers that can do specialized machine learning and provide unique computational capabilities. The TensorFlow processors, and now a host of others, including those from my own company, Konami, that can perform the analysis of data and building of machine learning models at orders of magnitude faster than traditional computers. The third category, edge computing, putting those chips out in the world, in the edge, in cars and trains and planes and other places. That's one that has yet to evolve, but will be enormous. So how do I know that'll be enormous? Well, the fact is, I know from history because intelligence flows downhill over time. Go back to the 1960s, and we had mainframe computers attached to dumb terminals. 20 years later, the mini computers stepped into that hierarchy and did the local consolidation and processing of data. Another 20 years, and the personal computer was taking care of a lot of local processing. So the intelligence had moved downhill from mainframes down to the individual. And today, large servers in the cloud, and then gateways in what might be referred to as the fog and edge nodes at the mist. The intelligence continues to migrate downward until eventually the chips that we deal with locally have enormous amounts of compute power to do the machine learning and the data analysis. Well, the third thing, and the one I find most exciting, is the protection of data, and it's becoming the big issue. So there are three approaches that have been identified for how to share the value of data. If you've got a valuable set of data, you can bring your data to the algorithm and you can trust the data center and you can put your data in the data center and let other people access it. You have to trust Intel, ARM, Dell. You have to trust anyone who has access to that data. And so it's not a very secure environment. Google popularized the concept called federated learning, where you put your machine learning model in the cloud, but then you download a portion of it to somebody's personal computer or cell phone, and the model learns from them and then is sent back to the cloud. Once again, there's a lot of trust required by you if you own the data that that downloaded model won't steal your data in a way you didn't authorize, and that the others who are exposed to your data won't take advantage of it without paying you for the benefit. There's only one way where you have to trust no one, and that's homomorphic encryption. Trusting no one, you keep the data encrypted at all times. So how's that work? Well, you as the client encrypt your data, and then you send it to the cloud, still encrypted. No one has the key. All the information is processed in the cloud, and then the encrypted data results are sent back. No one ever sees the plain text. No one can ever see your data. DARPA has characterized this as the holy grail of computer security. What is that holy grail? Well, fully homomorphic encryption provides what's called quantum secure encryption. It can't be hacked. It enables all types of arithmetic and logical computation to be performed while keeping the data encrypted. It's really critical for financial, medical, military applications and other things. So you're preserving the privacy of the training data. That is, nobody can go into your model and figure out the source of your data. The input privacy guarantees that you can take data that's encrypted and protect it while you're building your model. The output, it remains encrypted, and the model itself remains encrypted. Well, machine learning using encrypted data creates a new era. So you can build a machine learning model where you own the data and no one ever sees it. They simply pay you for the use of the data. You can make encrypted queries to encrypted models that were built using encrypted data and return the results still encrypted. That's really critical. It's going to be a very large market. Well, machine learning using encrypted data ought to be the way we do everything today. But there's a reason that we don't. And that's because it requires enormous computational power. Let me show you how much. A single bit of data coming into a logical AND gate is converted into a 500-order polynomial with double precision floating point coefficients, and then to do the calculation of the result requires 3,000 1,000-point complex floating point, 64-bit floating point fast Fourier transforms, enormous computation. If you try to do that on a standard processor with multi-core, you'll get some acceleration as you use a few more cores, but you get more than 5 cores, and the thrashing of data, the sharing of memory doesn't work on von Neumann computers. What does work is if you have a compiler that can compile things into independent threads that run on the cores of a computer and where you can get linear scaling. That's the solution. That's the way we're going to move forward. We had an example at our company where a customer came in that wanted to implement fully homomorphic encryption. They had run it on 24,000 Intel cores, 12 and a half racks of equipment. It took 4.4 days. But if you do it on a configurable multi-core parallel processor, you can do that in 10 seconds. The world is opening up to fully homomorphic encryption. The key requirements to get that million X performance: massive parallelism at the same clock rates, minimizing memory reads and writes. That's where most of the power dissipation occurs. Software compilers that can generate independent executable streams of data and control, and chip hardware that scales linearly across chips, across boards, and across servers. There are a lot of factors driving fully homomorphic encryption, but if you go and look, you'll see companies like IBM and Intel and AT&T and others highlighting their move to fully homomorphic encryption to secure the data instead of the data center. There are regulatory issues because data breaches are costing trillions of dollars. Microsoft already has a product called Election Guard that was used in the 2020 elections with partially homomorphic encryption. The Department of Defense in the US is committed to converting, and hundreds of companies already have homomorphic encryption programs, and Gartner predicts that 25% of all companies will have it by 2025. A very large market in the next few years, and a lot of companies helping companies to convert. You talk about the sword of Damocles, that is the impending doom. We have impending doom. Quantum computers can break most of the security on the internet whenever they get to 1,000 qubits or greater. And that's going to happen over the next 5 years or so. Fortunately, we have fully homomorphic encryption that can replace all the current security and can move us forward without fear. And that's why you're seeing so much publicity, so many companies talking about it. The world is going to be one of fully homomorphic encryption. It's going to be very important. So those are the three elements. Making data the new oil requires efficient collection, analysis, and protection of data. And with that, we'll move into a new era of artificial intelligence and machine learning that allows people to collect that information and market it to other people who can gain value from it, can use it, but they never see it. It remains encrypted, and so the owners can continue to profit from it, and it'll create an enormous business in the future. So thank you. And with that, let me take any questions you have.
Dr. Vines, we have a question from audience. Will there be a packet loss with such high volume of data transfer in TPU-based cloud or data centers, please?
I'm sorry, I didn't quite hear all that.
Yeah, will there be a packet loss?
Oh, a packet loss. I'm sorry. No, because the data is encrypted at the site of the client. So whatever you want to protect, you encrypt. Then it is protected in transmission, it's protected in processing, and it's protected in transmission of the results back to you. And so in terms of the efficiency with dropping packets or other things, it's all ones and zeros once you've encrypted it. So no more risky than packet loss in current transmission.
Yeah, we have one more question, how does the future looks like?
So I believe this is going to be revolutionary. I think you will see co-processors in every data center. Eventually, you may see incorporation of fully homomorphic encryption in all processors, but we cannot live with the level of data security we have today. We cannot trust the data centers. We cannot trust the operating systems. We can't trust the chips. We have to secure the data. So every organization that deals with confidential data needs to be able to encrypt that data. So I believe you will see over the next 5 years, people will move to fully homomorphic encryption so that the data is never revealed, never decrypted, and is always secure. And you can be confident that those who have your data are not going to reveal it to anyone else.
Yeah. Thank you so much. And you have given a deep insights. And it is really pleasure to have the eminent speakers like you in this panel. Thanks a lot. Thanks once again.
Thank you, Satish. A pleasure to participate.
Thank you. Thank you.
Thanks.
Yeah. Now we have a small break, and after that we have a panel discussion on industrial applications on artificial intelligence, which will start shortly. Thanks. Hi, welcome back. We have interested panel discussion on industrial applications on AI. For this, we have Malik Moturi, who is the Vice President of Product and Business Development at Scientend Corp. He has more than 25 years of semiconductor industry experience, creating innovations in technologies such as neural networks, DSPs, multimedia, networking, SOCs, and FPGAs. Mr. Malik Moturi has held technical and executive leadership roles at various Very warm welcome, Mr. Malik. So nice to have you for this panel discussion today. Now we have another panelist, Manish Kothari, serves as Vice President of Silicon Labs, India, a leading power of silicon software and solutions for a smarter, more connected world. He serves as a site lead and he is responsible for growing the wireless engineering talent, build scalable infrastructure and foster local partnerships in India. Hyderabad being the company's newest and fastest growing wireless development center. He has more than 20 years of experience in technology management, most recently serving as head of wireless systems and software product development at Qualcomm, Hyderabad, spanning cellular from 2G to 5G. He has built and managed teams of more than 1,000 wireless developers and system engineers and holds more than 100 patents. Manish graduated from the IIT Madras and received his MS and PhD from Massachusetts Institute of Technology. So nice to have you, Manish ji. And we have Shan, a holiday brings 20 years of experience to his role, leading customer success for Blaze. Shan's extensive background in marketing, strategy, business development, and technical experience underlie his successful track record delivering notable results in startup and Fortune 500 company environments. He has managed trailblazing products from idea creation, market analysis, concept approval to development, launch, volume production, and market adoption. His leadership and team management skills span multiple disciplines, multiple cultures, and geographies. Prior to Blaze, Shan was a senior director, business development at Skipco, where he held new market and new business development for an innovative broadband communication silicon startup. He was a former director, new business development and market development at Intel. Over his 16 years career at Intel, Shan has leader in identifying, developing, and launching new technology and business opportunities in the area of next generation broadband IoT customer platforms and wearable technologies, for which he received several Intel Division and Program Recognition Awards for excellence in development, product marketing, innovation, and business development. Shan holds a bachelor degree of science in industrial applications from California State University and Master of Business Administration from Golden State University, San Francisco. So Shan is the founder of Cycles for Hope, a 501c3 organization that has provided thousands of recycled bicycles and services to the people in need from California to Africa since 2008. Warm welcome, Mr. Shan. We are very blessed to have you here. And we have another young entrepreneur who started his journey with semiconductor sector at the age of 18 years, Gangadhar Gude, founder of @AI Labs. He founded @AI in 2018, an applied AI company that deals with edge devices. He holds a bachelor's in electronics engineering from Osmania University and an MS in VLSI from JNTU. Before founding @AI, he worked as methodology architect with AMD Incorporation and then co-founded Envicus, where he was honed his skills in building end-to-end products. With a career span more than a decade, Gangadhar strongly believes that passion coupled with purpose is the pathway to progress. With this motto and vision, he founded @AI, which provides applied AI solutions to supply chain, logistics, and business-oriented requirements with an aim to integrate technology for a greater enhancement of products and services. So nice to have you, Mr. Gangadhar, here. And now Gangadhar will chair this panel discussion.
Thank you, Satish. Good morning, everyone. So just to start off today, I think let me give you a brief abstract or a brief understanding on what we would like to talk about in this panel today. Artificial intelligence is making strong inroads in all frontiers of businesses, started predominantly in new age businesses, such as social media, IT infrastructure, e-commerce, ride-hailing companies, and etc. And predominantly, it's been driven towards autonomous vehicles. But if you look at most of the traditional industries, such as manufacturing or food processing, agricultural, supply chain and logistics sectors are still very nascent in very nascent stages in adopting AI. So the biggest thought process is AI adoption to these industries should add multiples of trillions of dollars to the global economy, and also give you a lot of intangible benefits, such as reducing the food shortage, reducing pollution, and improving overall the quality of life. Today in this panel, we would like to discuss the industrial applications of AI in these traditional industries, and what are the challenges in adopting, and what is the way forward for fastening these deployments. To give my view and perspective on this, there are many industries. We're talking about healthcare, we're talking about autonomous driving. Today, if you order anything, take like the Swiggy, we're talking about Uber Eats, Uber, Lyft. There's so many applications, softwares, what we're applying in industries that are popped up with this new AI, which is pretty much making the ease of living or ease of moving forward in life much better. But if you look at the traditional industries like agriculture or supply chain, today supply chain stands like, you name it healthcare, you name it food, you name anything. How do we move objects from one place to another? It's still like 20 to 30 decades behind in technology standpoint of view. In the last few months, since COVID has hit, these industries are now trying to figure out how can we improve the yield, how can we improve the efficiency, how can you improve the time. For example, if you take crop or food, perishable food, today in a global economy, the amount of food produced, almost 60% gets wasted because it does not reach in time to the end consumer. And that's a huge, huge volume for us. These perishable goods, pretty much, if you don't bring in the expiry time, they're all gone to waste. 60% is heavy. And take, for example, if you go on this agricultural, take certain product is supposed to be made in a certain time of year for certain weather conditions. And if by any chance something goes wrong, the whole yield goes to waste. So how does AI come into this picture? How are we as an industry adapting AI or these new devices or these new analysis to increase the productivity and use this technology to go forward? And the other question is the technology mature enough to support these type of industries? What are the sensors available? What is the network or the compute available? Is there enough? And is there any push coming forward from the industries? The last but not least thought process from my side, which I would like to talk about, is how much is the government supporting to improve or accelerate this adoption in overall these industries? Because from an India standpoint of view, this is very much needed for us to grow, because we are predominantly a country backed by these traditional industries. Sean?
Yeah, thank you, Genda. So I share many of the things that you just mentioned. And one of the really cool things I get to do here at Blaze is engage with customers around the globe. And I've personally seen the application of AI in real world applications in different markets and different verticals and different segments, as you've mentioned. And I too believe AI is going to change how we do business around the globe, not only in terms of economics and in making our businesses more efficient, reducing OpEx, but improving the human experience. As you mentioned, food production is a huge challenge around the globe. How do we keep from wasting food? How do we increase our yields? in such a way that we can get food to where it needs to be at the right time and place in logistics. AI for education, for example, we've seen this during COVID. It's changing the way people learn, how we're going to learn what we need to learn about. So it's going to impact that. Climate change. I mean, one of the hottest topics that are across all of our nations and around the globe of how are we going to handle this? And AI is going to play a huge part of that in analyzing what's going on and how we can respond to it, how we can adapt our businesses, how we can adapt what we do personally to impact that. So I'm really excited to be part of this because, like you said as well, AI is just at its infancy, and us as technologists, everyone who's participating in this summit, we are the group of people who are going to help make AI usable by people around the globe, whether it be in agriculture or in the farms, in the schools, or in traditional industries, as you mentioned. It's going to be up to us to help them adopt this technology, put it to use, and address some of these big challenges and problems. So I'm excited to be part of it. I'm excited to talk about it here with the fellow panelists, and hopefully we can come up with some good solutions and recommendations that'll make sense for everybody. Thank you.
Thank you, Sean. Malik.
Yeah, hi. Thanks, and I really appreciate the opportunity here to speak at the Iesa. Thank you for setting it up. It was great. So I wanted to I was listening earlier to Wally Ryan speaking about, the very eminent speaker, and really I want to riff a little bit on what he said. I mean, 3 points I think which I kind of caught, and I thought it's also relevant to what we are talking about here. One is he mentioned was the Internet of Things, right? He said IoT, but said other one was really the security of the content, how do you keep it secure? The third one was data being the new oil, and how a lot of data is. So let me kind of riff on that, right? So if at least we've been talking about it internally at Sentient, and we are a AI chip company, but we look at it as the IoT. I call it the new IoT, or the intelligence of things. Right. So industrial IoT, or industrial devices, or IIoT is one of the terms that is thrown around, right? So we are seeing a lot of renaissance in technologies entering into all kinds of devices around us, right? Devices, machines, how to use automobiles, you mentioned. These things that we use in our daily life, home, office, factories, and outside, smart cities, what we are seeing. These are all becoming much more intelligent. It's simplifying and enriching our user experience. You see it every day on your smartphone, all the things that it can do. That's just just one example of our day-to-day, how intelligent devices are becoming intuitive, perceptive, even take reasonable autonomous actions, right, based on situational awareness. Now, these things are enabled by technologies like some of the things that we are building and our other semiconductor companies are building, that allow these things to happen at very low power and ability to make it ubiquitous AI, right? So that's the revolution this revolution is happening in that industrial, that IoT, or Intelligent of Things space. But the other thing is it also solves certain problems, right? Which are effectively those in the earlier days, today users of devices, or these IoT devices use, those problems, you come across a supply chain issue, right? You let somebody solve it, right? You put a bunch of people on the problem, and then they go figure it out and solve it. Or they use some conventional algorithms to say, supply chain management. But if you apply AI to those industries, to understand the problems, being able to predict based on the data that they are getting from everywhere, that is where I think this trend is accelerating now. This is where I want to talk about data. There's vast amounts of data being generated, but stored, goes into the cloud, goes somewhere. And there's no ability to kind of mine the data, and there's, we're trying to do that, right? But those efficient algorithms need to be there to mine this data. There's a flywheel of this vast amounts of data coming in. Specialized silicon is coming together, as you know, like if otherwise you'll have to build these large data centers and we are doing that today with consuming vast amounts of energy to do certain amount of processing of analysis in the cloud. So I think on-device AI, edge AI, combined with all the sensors we were talking about earlier, right, enables this privacy of data or protection of the data, reliability. That means it doesn't, there's no connectivity or whatever. The data is still analyzed and available right there. And responsiveness. If you want all of these machines or devices out there, and energy efficiency is very important in this new intelligence of things across all industries. Now, industries, I mean, it's a global economic output, right? From all this, what is it, like $5 trillion of manufacturing, the overall industrial output from manufacturing to transport or, you name it, right? Utilities or other those kind of big industries. Billions of dollars are generated. I'll talk about semiconductor industry as a whole. We generate $500 billion in revenue as a semiconductor industry today. AI contributes probably today 5 to 6 billion in the EBITDA, meaning the earnings of that industry for that industry. The potential, according to McKinsey report I was reading recently, was that it could be potentially 80 to 90 billion dollars. That is in the long term being 4+ years. In the midterm, in the next couple of years, that EBIT earnings before taxes, it could be more like something like 30 to 40 billion dollars in growth. So those are huge numbers, but that's the scope of where we are seeing all of this happening. I mean, I don't want to get into. We'll talk more details later, but there's a lot of different industries I want to talk about. Like you mentioned automotive, then manufacturing. There's a lot of things we can do in manufacturing we are seeing today with AI. So I'm looking forward to continuing this talk and exploring all the various industrial applications as well.
That sounds great. Thank you, Malik.
Thanks.
Nish.
Thanks.
Yes, hi. First of all, I'm really honored and humbled to be part of this conference, and thanks for having me here. And with this eminent panelist and the host that we have here, I think the journey of industrial applications, for AI, I think is just kind of on the trend line of how automation started. Right, you went from manual kind of factories to automation, and AI is just another step in that direction. And I think when you look at what the place where Silicon Labs comes in is we are kind of the leading leaders in IoT, and you can call it intelligence of things and Internet of Things, and we live in the what I call as end nodes, which are sensors. For example, think of your factories today, any industrial application, there are sensors galore, right? That's been part of your automation journey, whether it's for predictive maintenance, whether it's for security, whether it's for monitoring, whether it's for your efficiency and productivity and all of those things. So now the question really, which is why I feel we are really at the beginning of this journey, is really kind of now trying to figure out what is the right architecture and what kinds of problems can be solved at what I would call the end nodes, which if I may call as the micro node, micro edge, because I'm trying to make a distinction between edge and cloud. Micro edge is like sitting on the end node, right? And there are a variety of different things. If you take for example, to look at the requirements, if you're an end node like an autonomous robot or a car, you do have a requirement of a lot of the inference and the stuff to happen right at that node because of latency requirements, right? So there's nothing that can go to the cloud. You have to have good amount of stuff here. So we're in this domain where you have a micro edge and you have a thin edge, which is all your networking equipment. Then you have your, your thick edge, if I may call it, which is your data centers at your cell phone base stations or in-premise clouds, data centers, and then the actual cloud. So there is a whole layer of possibilities and solutions. And I think it's very interesting time, because not every problem, there's a clear-cut solution to say, look, this needs to be done, at the end node. I think the analysis has to be done. Now, what goes into that? And I think we'll talk a little bit more about applications, but typically the things that, industrial applications, or if I were a Bosch, for example, I worry about is privacy of my data, right? Because that's my core competency. I mean, the number one thing, just like for a human, data is the oil, it's same thing for industries, right? So it's very, very, for them, what goes to the cloud, they're super nervous about, right? So in the home world, where you have the Google and the Apple ecosystem, it's very hard to think about that on the industrial side. So that does slow down a pace of innovation a little bit, because they want to keep a lot of that. So that drives a different architecture and solutions. There is a power constraint, right? You want all these sensors and devices to be placed anywhere. Not everywhere you can rely on wired power. There's also bandwidth and latency and the cost associated with it. So there's a variety of different things that one has to worry about in a factory floor or in industrial applications, to kind of look at what is the AI's methodology and the system architecture that I need to think about as I look at doing stuff for my application. So I think that's kind of the journey, and I think we're very early in these days, and I'm looking forward to having more specific discussions and examples and applications as we go forward.
No, thank you, Manish. So I think after listening to all of you, I have a question. I think I'll put it more in a general standpoint of view. I see all of you have a lot of experience with IoT. Sean, Manish, and Malik. Now, how far is this conversion of IoT to AI happening? Like, is IoT AI, or is it changing from IoT to AI? What is the difference? And how are these industries adapting to this?
Can I take that for a second? Ganadhar. So I think first step was, when I mentioned IoT and I said intelligence of things, what I was trying to talk about was, traditionally and today also we see these devices which are, even in the industry and factory floor and other where we see microcontrollers, their DS signal processors I'm talking about the semiconductor, at least the chips, right, side of things, where they're very small, they're low power, but still the capacity of the von Neumann architecture or Harvard architectures that they have, processor based or DSP based, they are still access memory and data, and they're very resource constrained today. So that is the challenge with that. What has happened is they're trying to kind of cross the chasm here and trying to figure out how to make it add intelligence to those devices, sort of adding AI, neural networks, deep neural networks into those devices, tiny devices. The challenge there is that it's going trying to retrofit it, with the new requirements. So we know how it works in the cloud. We know the massive amounts of data coming in. We know how to take all that and train it, and then, but this inference devices that we're putting in spreading it, because they have to be. I mean, I think Manish mentioned this. One of them is energy efficiency is very important, right? So you have to be very low power. You got to be be able to sit in the factory floor or whatever and run for months together. There's no probably a plug point or something that you can plug it into there, right? So those are, energy efficiency is important, and I think mention of data protection. So all of these things are, things that means that you have to be able to analyze the data at the node, at the edge, at the local, at the point where the data is generated, and that is really where intelligence is entering into the IoT.
Yeah, so I think if I could go next, and I think just to add to what Malik said, right? So when you look at IoT, traditionally it's been about sense, control, compute, secure, communicate, right? It's just in that's really the essential of what IoT has been doing, whether it's in your home, as a light bulb. Now, what happens is, as you have that, the question now becomes for an end node is like, what can you infer, right? And And so the inference part of it, whether it's an event detection. So think about, I'll go into an application to give you an example. Like if you have a key part of a lot of factories and machine tools and others is about vibration being a very good source of kind of figuring out when the endpoint failure or a predictive maintenance schedule, right? You can infer that with a Cortex-M processor, with tens of kilobytes of RAM, right? So there is a whole range of applications on the sensors which are sub, not even one tops. They're like well below. You're running on a Cortex-M sub-gigahertz processor, and Malik is, right. There are certain applications, which you just cannot fit in that, right? Now there is a whole host of stuff that's happening in the industry, right? There's TinyML that's running on the processor. You have to figure out the energy efficiency of it. As Malik said, sometimes you may consume more power in computing than what you may save in communicating, right? So there is that whole system analysis of what's the right solution, but there is a bunch of applications where these sensor nodes, which I would call as the old IoT, if I may say that. The new IoTs, these sensor nodes are becoming intelligent. And the level of intelligence depends on the level of capability, and I would say a period in time. I think Wally clearly described, and I'm a firm believer that these intelligence nodes, the end nodes, would get powerful over time. Because if you just look at the process nodes they're working on today, they're in 110 nanometer, right? Moore's law hasn't caught up with them, right? So there's a whole journey that they're going to traverse where a lot of computing power and a lot of architectures and special purpose hardware, and that's already we're seeing now. So when you look at in time, if you just look at, it does make sense. I'm not saying for all of them. It does make sense for a good number of applications where it's important to have intelligence at the end node. And what level of intelligence you do depends on a variety of things. And I think, which we talked about, cost, security, right? It's a lot easier. Why do industries like inference at the node? Because what you transmit is purely a, let's say, a function, a convolution function of data, right? You're not sending the raw data out. So that's a huge, paradigm shift for them. They really like that. They really like the fact that what you transmit is some convoluted, kind of data, which is not your raw data. So there is a lot of that. It's also a function of time. Today, there's only a certain amount of things you could do, on your end node. As I mentioned, depending on your process node, the cost you can afford. But 5 years from now, I think if you want to project out, I do believe that intelligence will move down. That doesn't mean that cloud will go away or edge will go away. They will do different and better things, right? We'll be running at 100 tops, right? We'll be trying to kind of capture brains. So, there's going to be an application. But what I think about today in the next 3 to 5 years, my crystal ball is we're living in this whole world where sub one top kind of applications, which is running on a gigahertz or low processor with tens of or hundreds of kilobytes of memory, not megabytes, are prime for innovation to address the kinds of problems we're talking about, which is cost, power, latency, right? Security. So these things, are going to happen and are happening, and we are seeing already products shipping out with our customers. And I talked about, predictive maintenance as one of the examples.
Yeah. I'll add to that, guys. And I think the really cool thing here is that the IoT has laid the infrastructure out for AI to be successful in these spaces. I've been around long enough, and I have the lack of hair to show it these days. Of before it was called IoT, it was machine to machine, or just the days of programmable ladder logic machines when we just ran information between. So, but the infrastructure is in place, right? And now we're seeing whether AI is going to be pushed all the way to the sensor, which I know we'll touch on that topic later, or it's being done in the cloud. We have an infrastructure. Bring in 5G and communications today. It even opens it up more. So we're hitting that perfect intersection of available infrastructure, the right size compute. You talked about tiny ML and small processing nodes running really tiny programs, but still doing inferencing. To the big heavy lifting that's going to happen in the cloud and everything in between. And the way Blaze looks at this from a company is there's very distinct points and areas where the exact same workloads can be done, or the type of workloads or applications maybe at different levels of processing, all the way from the sensor at the edge, or as was said earlier, maybe in the mist or the fog or the cloud. But my key point here is, and what makes me really excited is that the infrastructure is laid out. IoT has laid the road, the infrastructure for us. Now it's up to our industry to come in and provide the right technology, the right software environment, the right applications, and so forth, especially as we're talking about industrial. These are right. Getting AI onto the agricultural equipment, which we're seeing move forward really quickly today. Getting AI out into the cities to help with logistics. The infrastructure is there. Cameras are on intersections. Let's start pushing AI out there. So it's ripe to move forward, and I think the next 4 to 5 years is going to be super exciting, and you'll see a hyper growth in the application of AI in traditional IoT areas.
I think, yeah, just to, my takeaway from all of you guys is something we learned, the 3 Ps: price, performance, and power. These 3 is what dictates what level of AI is going to be embedded and what level of IoT is going to be used, if I'm not mistaken. Just trying to sum up for this question. The other question, we've been getting some questions from the crowd already. Before we move on to the crowd questions, audience questions, I just wanted to ask one more. It's a sum of things. I mean, a lot of questions nowadays in India. What are the biggest challenges that are happening in industrial usage of AI? And they sum it up with, will AI replace human beings? Because that's the biggest question a lot of people are having, especially when it comes to these industries. And that's the reason there's been a lot of pushback. What is your take on this?
Yeah, I'll start off with that. First of all, I'll say no. I do not believe AI is going to replace humans. I think we've already seen, coming from the early days of the first industrial revolution to where we are today with factory automation, we've seen probably the vast majority of where maybe human labor has been replaced with automation, robotics, and so forth, right? And what has happened over the years? People who haven't lost jobs, they've transitioned their education, they've transitioned the type of work they do to utilize that machinery to augment, to complement their work. And I think we'll see the same thing with AI. AI is going to come in like in the agricultural space. Instead of workers having to go out to physically look at or take samples of the soil and the plants, that capability will be built into the agricultural equipment. We're talking to customers today that are adding AI into cameras that are taking high resolution pictures of leaves or the plants that are growing and determining, does it need insecticide or does it need fertilizer? What is the best thing to apply at the right ratios to get the best growth rate? That's not necessarily replacing humans. Humans may now be coming around to look at the data science behind that needs to be built into it. So it's augmenting the work that's going to be done. It's going to change the way we work. It's changing our education levels. And so it's funny. I just did a quick Google search of this before because I knew it was going to be a hot topic, and there's opinions all over the place. But overall, my personal opinion is the answer is no. AI is going to be hand in hand with humans working. Again, whether it's for agriculture industries, whether it's for really big problems like climate change and others, or pandemics like what we're doing with today. Let me give you a great example of AI working hand in hand. Early in the pandemics, you saw a lot of, if you went on GitHub, you saw a lot of companies working on, how do we assist doctors? How do we give them technologies to quicker analyze and tell if somebody has COVID or not? And then what are the impacts of COVID? Obviously analyzing, doing blood tests, PCR tests were a big part of it, but they take a long time. So people started looking at how do we do visual imaging? Visual processing is a huge part of AI today. So our company, our data scientists put their heads together, worked with some industry colleagues, and very quickly came up with a way to analyze X-rays and train models off of public data sets. And then we even learned that X-rays in different geographies, people's anatomies are different, to train those to determine, does someone in the Philippines have COVID because it looks like different than somebody who has COVID in India. We were able to do that very quickly and put a tool in place with colleagues to have a go, no go in a matter of seconds by looking at an x-ray. Did that replace the doctor? No. But it allowed the doctor to diagnose, 10x, 20x, 30x more patients quickly to get them the care they need or take appropriate decisions within their municipalities and local authorities. So it's a great example of how AI will augment what humans are doing today and not necessarily replace. So I'll hand it over to my colleagues to comment.
Yes, I mean, I think I could, look, it's a very, very, a tough question. And I would say there's a lot of more eminent personalities and thinkers greater than, at least for me, like Elon Musk and others who have a lot of opinion on it. But I think I'm kind of with, with what Sean outlined, right? Like what I see is, if you just back up at like 10,000 foot, AI replacing humans requires you to develop some level of general intelligence, right? Which is kind of what our brain does. We're very, very, that's like very far out, right? We only understand like 1% of how brain works today. So there is that element of it. The more important thing I think that is more relevant is kind of what Sean talked about, is there will be people who will be impacted, just like when automation occurred, labor was impacted, but reskilling, retooling, rethinking about education also becomes very important. I think going to what Sean talked about is how machine learning is really changing medicine, science, medicines. I wonder if you go to a medical school in 10 years from now, would you need to know machine learning? Because a lot of the diagnostics and the stuff that's being done could be automated. That doesn't mean the doctors are not required, but they will be doing different things. What are those? And I think those are the things that I think are more relevant for all of us as a society to think, is AI would require us to retool, reskill, rethink how education, every aspect of things are done. So I think that's where I think it's very fascinating. But my fundamental belief is, it's just the human brain is. I think just if you look at where we are in terms of understanding of general intelligence and kind of just having a machine that just thinks as computers and machines taking over humans, as really kind of replacing humans. I think that I'm not qualified to talk about it, but just being an optimist, I think we are far away from that, and that's unlikely. But more realistically, there will be an impact to people, and I think we as a society have to really do our job to reskill and retool people, and really look at how we are training people and how we are skilling. And I think whether it's engineer or a doctor, what you learn 10 years from now, it's very important that what you learn, because certain things may not be required or may be done better by a machine, right? But that doesn't mean a human is not required, right? You just you have to upskill and you have to do something different, because it frees you to do other things, right? Bigger and better things. So I think that's my humble view, if I may.
I want to give you a couple of examples. Thanks, Manish. I think I think the point I think you had mentioned was that you have to relearn a few things, but just give us a couple of examples so we kind of go to the point of where things are changing. Just basic thing like we've been working with companies in the retail industry to do speech recognition. Right, so we are one of the Sentience core technologies in speech and voice and audio. And speech recognition would allow you to go to a fast food or any one of those retail location point of sale and ask for whatever you want, and it can be delivered to you without having to go to having a human to do that order taking, for example. Right? That's one example where it's changing already. We're seeing that. One of my colleagues, friends, works at he heads the AI division of McDonald's, and they are setting up these speech recognition, complete ASR stations where you can just go place your order without having a human to take the order for you. That's an example. The other one, I was just coming to the semiconductor industry. Physical design has been traditionally done by humans, right? I mean, you put a lot of resources spend on months and months of doing physical design. More and more, we are seeing that actually being done by AI engines built into the EDA tools that they can do. It's come to a point. It's really very, very hard for a human. You still use tools. You still use tools in the past, but they are now going right from design to GDS without having to have a human to do the physical layout anymore. So those examples of right from order taking to physical design are really a hard, like silicon design, changing, industries changing, where humans are not needed anymore.
I think, thank you, Malik. I think just to sum it up, in the standpoint of view, yesterday there was a speaker also that Mr. Jayesh Ranjan, who is our IT secretary of our state, was telling us there's a university in Telangana that is enforcing AI as one of the courses that every student has to take. So it's not just engineering, or it has to be architecture, arts, you name it. Everyone has to do one coursework of AI, because how do we apply this for our application to improve ourselves? And that was a key goal. I mean, that's the new changes that are coming about, even in education, like you stated, Manish. I think that's one of the steps that are being taken. I think we have time for one audience question. I just wanted to. So, how do we see AI in embedded systems, or is it still only at research stage?
It's not. It's far from research. We are shipping 10 million products. We already shipped 10 millions of chips going out. Deeply embedded AI chips in the market today. We have many different products that we are shipping into, and these are full neural network, sentient core are all neural processors.
Yeah, and I think if I were to add to what Malik said, right, like my former eminent employer Qualcomm, Snapdragons have smartphones today have it's an embedded system, and it's got tremendous amount of neural network and machine learning capability, and famous use case being face detection, right, image recognition. So I think we are quite far in that journey of intelligence in embedded systems.
Sean, you're on mute.
Sorry, yeah, everybody. No, I sure hope we are. Otherwise, I'm in the wrong business. Embedded's been around for a while, and tying back into IoT. AI, and especially the type of processing, and the previous speaker before our panel had mentioned the change in compute that's going to happening. So one thing I'll say is, yes, AI is out in traditional embedded devices today. We are seeing it in mobile devices. The fact that I can't go to a McDonald's and verbally order my French fries today is a true testament to that, right? We're seeing it in the retail centers. When you go to a shopping mall today and you walk in, cameras, and everything is running on AI. These are all truly embedded systems running on traditional real-time operating environments and so forth. So I see that it's fully there, but I think there's a lot of room to grow, and that room to grow is in the type of processing, the type of programmability that's going to be required. AI is very much in its infancy in terms of being applied in the industry. We're still learning. Models are changing daily. The types of models, the size of models, data sets, technologies for labeling data is changing on a daily basis. So what I expect is that we're going to see a change in the type of compute required as AI grows, and that's going to be a transition. So we have a strong embedded base today, whether it be fixed function devices and sensors that are sitting out there, on an oil tanker or in an agricultural environment, to other devices that may be autonomous vehicles and so forth. But that's the AI of today. And there's going to be a lot of transition here over the next 5 to 10 years in the type of compute, utilization of memory, driving power down, and so forth. It's dramatically going to change as part of that. As I mentioned earlier, and you commented on, education. One thing I can say is, as one of the startups here, we're a fast growing company, and going out into the field and try to bring good people on, programmers, engineers, developers, we're going to, we see a growth and a need in education as well. So it's encouraging to hear that this is being built into universities, for example. And I'll add just one funny story here, just to show how AI is not just for the technical people that are at this conference and for us to know. In the example I gave on X-ray, in our interviewing and engaging with various different medical professionals in different geographies, we had one medical doctor, actually an X-ray doctor, started asking us how many layers were in our network. Were we doing floating point 32, 16? Were we down at 8? How fast were we inferencing? And it just totally blew me away, because it's this medical doctor, highly trained in how to visually look at X-rays, had started spending the time to truly understand how AI is going to change his industry and field, right? And that ties back into, yes, AI is out there in embedded devices. It's going to transition, it's going to change, it needs to. And I'm super excited about it, because it's a fast growing industry for sure. So
I think just to sum up, even throughout the discussions, now we're talking, I think the biggest question used to be, was it cloud versus edge? Now we're talking about edge versus mini edge, micro edge. We're talking, before it used to be ML, now it's tiny ML. So to what extent are we trying to bring down, again, it goes back to the 3 P's, price versus power versus performance, and where each of these applications are required. And that's the key thing, I think, if industries are being pushed to adapt to this, what levels of communication is happening, and how are we taking this up is a crucial role. I think that sums it up, but I wanted to thank each and every one of you for participating. I hope even to the audience, this was enlightening from our speakers, how it, we were able to answer some of the questions. And before we sign off, I actually just wanted to congratulate both Sean and Malik for making the top 100 AI companies by CV Insights for AI processors.
Thanks.
great, thank you.
Thank you very much. Thanks for your time, guys.
Thank you. I'll
Appreciate it. Thank you.
Thank you, guys. Thank you very much.
Bye-bye.
Bye-bye.
Thanks, Gangadhar, for the deep insights on engineering AI in future, of any applications. Thanks a lot. Now we'll move on to the next session.
Industrial and healthcare IoT Edge starts where the real world turns into digital information. Camera imagers, medical imaging and diagnostic sensors, high voltage electrical converters, and servo position monitors translate the analog data surrounding all of us and send it to network embedded electronics. Why does it turn into a game of digital?
Hi, welcome back. We have another interesting keynote and exciting keynote on the new systems thinking to drive high performance computing and machine learning. We have Mr. Jay Ahmed, Corporate Vice President, Systems Design Engineering at AMD, who will be addressing this keynote. He leads the software group. His team is responsible for AMD's advanced toolchain development and productization, including compilers, libraries, profilers, and machine learning inference solutions, and also business critical debug tools, system management tools, and platform software solutions. Mr. J did his bachelor's in electronics and communication engineering from Karnataka's PDA College of Engineering. Then he spent about 3 years as an R&D engineer at Bharat Electronics before he was heading to Tennessee Technology University in US to pursue his master's degree in electrical engineering. He worked as research assistant and did his graduate thesis in field of neural networks 20 years before machine learning and artificial intelligence would come to dominate the tech sector's vocabulary. He then spent the next 12 years in Silicon Valley with microprocessor maker NextGen, which was subsequently acquired by AMD. The highlights of his 25 plus years of journey at the company is closely linked to AMD's growth. He began his journey in California and moved to Bangalore in 2005 to help in setting up the design center in India. He had continuously demonstrated the ability to successfully lead and execute his multiple concurrent complex programs. AMD's potential in things such as machine learning, high performance computing power offered by AMD's IPs both on the CPU and GPU side fueled a phenomenal growth in the company. Being a part of many such critical game-changing product contributions, including the stellar success of Ryzen and EPYC, today is what he defines as the most exciting part of his career. So nice to have you, Mr. J.
Thank you, Satish. I'm audible, Satish?
Yeah, you're audible.
Thank you. Let me share the screen to get started. So Satish, again, thank you for the kind introduction. Truly appreciate it. And also, before I get started, I want to take this opportunity to thank IESA team for extending this invitation to me and offering this platform to share my thoughts on HPC and machine learning, AI, machine learning, and very relevant topic, if you ask me, in the day and age that we are in today. It was not so, as Satish was alluding to, when I graduated a quarter of a century ago, more than that actually. It was not so. It was a little ahead of its time. The things that we studied, they're coming to becoming more relevant now, have become relevant, and if anything, my thesis was a little ahead of its time, I guess, right? So, but I'm very glad to hear, and I'm very glad to be living in this era of supercomputing, machine learning, high performance computing, any which way. Some of these things are used interchangeably, but very, very exciting days, if you will. Now, the reason I say it's a very relevant topic is, if I have to use one word, then that word would be data. In fact, 3 words actually: explosion of data. Because if I throw some data points there, for example, we are surrounded by connected devices all around us, right? So about 10 years ago, a little more than that maybe, IoT was the in thing. There's the latest buzzword, and all of us in the tech industry, and maybe even beyond tech industry, wanted to get involved in everything IoT. Check that box now, because we all are involved in one way or the other. We are involved to the point that today, as we speak, give or take, there are about 8 billion connected devices worldwide. It doesn't stop there. It is expected to grow 10x almost to 75 billion by the year 2025. Now, when these many devices are interconnected, the data being generated, because every which direction you look at, there is data being generated. It could be as simple a transaction as a point of sale transaction in a grocery store. There is data generated. Or the data center, of course, obviously will churn a lot of data. And even as simple function as facilities management will be generating data. And so this data generated by itself may not mean much. So that's why there is traffic that data needs to move from one place to the other. It needs to be analyzed. And so that's where the traffic comes in. And according to Ericsson, there was a projection made that between the year 2018 and 2024, this traffic is expected to increase 5x, and we're in the midst of that period. And much of it is fueled by the 5G infrastructure. And there's one other thing that most of us do, I would say without exception. in this virtual room, even outside the virtual room, which is searches. So 6 billion searches a day and growing at 10 to 15% per year. And if you annualize it, roughly about 24 trillion with a T searches a year. Right? Everything here that I'm referring to is generating the data. And so people are acting on it. For example, Microsoft, they released the deep learning optimized library for distributed training, because it facilitates easy, efficient, and effective training of distributed systems to the tune of 100 billion models that can be trained. So people are working on it, and the deep speed library that I'm referring to is the open source library that is being used, and it's being put to use already. The Turing natural language generation has leveraged the deep speed library, for example. So the point is, there is data all around us. And that is why high performance compute and machine learning and AI are very, very relevant topics. That's, what I'm going to talk about is a system view of how to deal with this. Just look at the workloads, right? In the future, what are these workloads asking us? What are they asking for? So whether it's a cloud or a supercomputing setup, or on the other end, client solutions, gaming, AI systems, each and every one of these, and not to forget the communication infrastructure that we talked about earlier, right? So we are looking at churning this data, analyzing data, simulating them to make decisions based off of this data. Right, so this translates to power, compute power, and all around us, there has been technological and continue to be technological advances, but in spite of that, there is an insatiable hunger for more compute power. And as there's not too long ago that, we used to talk about the client server model, where the client, for the most part, would be a dumb terminal, could be a dumb terminal. It still is there in in many use cases there, but more and more, even the client or the devices that are working on the edge are expected to have compute power, edge compute, edge inference, right? So the point is, there is an ask of increased amount of compute power. That's what the workloads are demanding of us. And what are the trends that are driving this, the workloads? If you ask me, when you look at it, there are three things that jump out at us. One is heterogeneous compute, and then the coming together or the confluence of data science and big compute. And the third one, and this is close to my heart, is software enablement. So we'll double click on each of these. So heterogeneous compute or heterogeneity is basically, if I had to simply say it, it's integrating many traditional incompatible technologies. At the simplest level, we are talking about the chip level heterogeneity. There's a CPU, there's a GPU. I've been at AMD for most part of my professional career, so I can easily talk about what heterogeneity it means in the context of AMD, which is relevant to CPUs and GPUs, right? So the simplest example that I can think of. So that's what heterogeneity is. So why is heterogeneity important? Because if you want to design and manufacture huge chips, that will serve a particular purpose, then you need to worry about the cost associated with manufacturing those too. So that's where we can leverage heterogeneity, and which basically is offering us two advantages. product agility and targeted optimization, because each chip in this heterogeneous system is specialized. You can almost look at it as a custom chip for multiple use cases. That's what you can slice it and dice it based on your use case, and that's what the heterogeneity gives us the advantage in. Now, another look at heterogeneity, because where we are today, I mentioned, right? So CPU and GPU at chip level, we have the heterogeneity today. So the CPU here and the GPUs constitute the simplest one. They're interconnected using I'll talk about this a little later, the interconnect technology that we have, right? So this is simplest one that I can refer to today. But where do we see this going? Right? So see it at system level. Much of it is there even today. The heterogeneity permeates to a system level heterogeneous system, and even at the memory level, where you have the DDR memory, various different kinds of memory, working together in a heterogeneous system, DDR, NVDIMM, and fabric attached memory. That's the memory level heterogeneity that I'm talking about. So that was the first trend, heterogeneity. The second one is the confluence of data science and big compute. Very simply put, all the advances, right? Whether it's data, compute, or the advanced research that's going on in the algorithm area, it's changing the landscape. And if I had to simply put, there is a saying that is attributed to I think, basically it means the whole is better than the sum of the parts. That's what it comes down to. The combined compute and advances in the classical compute coupled with the advances in statistical learning leading to data sciences will enable us to cater to far more use cases than these two individually can. Right, so that's the that's the power of the confluence of the coming together of data science and big compute. Yes. So we talk about AI, machine learning, right? So where it is today and where it is heading. So today, we talk about training and inference. For the most part, training is GPU based, and inference is CPU based. It is not to say that you cannot use one for the other. Can CPUs be used for training? Yeah, potentially. I mean, it's technically possible, but does it make sense? No, because the architectures of each of these processors lend themselves to to what I mentioned. GPU, enormous amount of training data can be handled much easier by the GPU. So that's what is there today. GPU based training and CPU-based inference, where majority, more than 70, 75, 80% of the inference market today is CPU-based. That's today. Future, we see this machine learning or ML expanding its reach. Then we talk about self-optimization, model distillation, approximate computing, right? Where accuracy may not be the most desired thing. We can make do with some approximate decisions. So those are the areas where machine learning is reaching out to. And of course, inference for low power environment, these we can always can even now relate to those things, right? So the point is, machine learning is evolving as we speak. Now, the third part, which I said is close to my heart, and many of you in the semiconductor industry can relate to this when I said, well, I'm a software guy in a hardware company. Some people may say, well, that's complex enough already. Well, it was, but there is more and more growing realization that software is perhaps the most critical part because all the compute power without effective software might not mean much, if anything, right? So it's gotten better. But in all seriousness, the challenges in front of software are huge. Because as I mentioned, heterogeneity is increasing. We saw this moving from chip level to system level to memory, right? So the software needs to harness all these together to basically cater to the use cases that we have in mind. So that is something that the software has to deal with, the complexity involved or brought about by the increased heterogeneity. And then the programming domains, they also increasing. Memory, storage, the NIC based or the network or interconnect based programming domains, they present new challenges too. All these complexities need to be addressed while keeping an eye on the cost associated with the movement of data. Right. So that is what the challenge is in front of software. Now, there are things that can be done in software itself. I mean, this is basically a philosophical thing, right? So whether we can help ourselves, make it a win-win by collaborating is what it depends on. And we at AMD are big believers and supporters of open standards and hence open ecosystem, because it's a win-win. You collaborate. Yes, you compete with each other, but at the same time collaborate for the greater good. That's what open source and the open ecosystem brings to the table, right? So open source is a big part of our strategy, right? Open source software in this case, I'll talk a little bit more about this. It basically helps accelerate the innovation, and as I said, for a better world. So what do we do on the open source? I have some examples here, right? So on the machine learning side, you have MLPerf, or the ubiquitous framework PyTorch, TensorFlow, or the Linux, GCC, and then Fortran, C++, OpenMP. All these we are active in, and our graphics stack we call it ROCm, right? So it's open sourced. And I didn't mention LLVM because I wanted to talk a little bit more about this. We have optimized compiler, right? So optimized compiler for CPUs and GPUs, and those are LLVM based. So if you get into the LLVM repo, there's a good chance that you will see commits from AMD engineers in the recent past, because we are very active. We try to stay top of the trunk, and we try to commit back our changes back to the LLVM community. Of course, there is the associated acceptance cycle that goes through, but the point is we embraced open source, and we continue to support open source and also open industry standards. Now, while on the topic of open source, I just want to take a moment here to talk about our inference offering. I talked about inference, right? So which is primarily CPU based today. We recently introduced ZenDNN. It's a CPU inference library. We released the version 3. I think it happened late last week or early this week. It's basically an optimized library, and it optimizes the APIs required for the usual use cases, right? So natural language processing models such as BERT or and transformers, or on the image classification side, ResNet 50, for example. And then it also is optimized for recommender systems such as DLRM, wide and deep, right? So it's available for download. I have the link here. The point is, it's not open source yet, but we are working on it, right? It will be open source later, not far in the distant in the immediate future. So that's what is going on. So it's basically optimized for AMD CPUs. That's and it's an inference solution that we delivered, which will be open source source shortly. The binaries are available for free downloads on our developer.amd.com website. Now, that is where those three trends that we talked about: heterogeneity, the coming together of big compute and data science, and then the software enablement. Now, future requires innovation in all dimensions, and I think it goes without saying, and I'm stating the obvious here, but the four that we talk about are, the three we already talked about: silicon, systems, software, and security too. And increasingly, security has become important. We need to have scalable solutions on the security side, starting from IoT and to the cloud and everything in between. Right? It has to be secure transactions. If you don't secure transactions and its end-to-end security is not provided, then you are open for breaches, right? So we know all that. We have been enough examples on this. So that's the security part. But others, silicon, we talked about this, right? So yeah, theoretically, you can keep on increasing the compute power, but you also need to keep an eye on the power consumption. And so it has to be efficient compute, and power optimized designs is what we need from the silicon side. And systems, right? So you could have the best in class, very high power, high compute power components, but if there are bottlenecks in connecting the two, then it's no good, because as we all know, the slowest one determines the throughput or the efficiency of a heterogeneous system. So interconnects, memory, and topologies balanced to address the performance bottlenecks is what we need from a system perspective. Software, we talked about this, right? So self-optimizing software, basically bringing everything together. And software is the one that facilitates accelerated computing. And so open source software and more innovations on that side is what is being asked on the HPC side or machine learning side in the future. Excuse me. So that is what the trends talk about. Now, what are we doing within AMD, right? So how do we meet this demand? And for us, the journey started, this is 21, so about 15, 16, 17 years ago, the HPC and the, not so much, it was not a machine learning journey then, but it started off as HPC, right? High performance compute. But the point is, and again, this is a no-brainer, being in the technology industry, everybody can relate to this, relentless focus on technology innovations, right? CPU and GPU innovations, then you design them. That's what is the CPU and GPU design community brings to the table. And then by manufacturing them with leading edge process and packaging technology, and then interconnect the best-in-class interconnect technology, all brought together and facilitated by software, basically facilitating accelerated computing is how we look at it. We'll talk a little bit more about this, right? So very quickly, what we have on the CPU roadmap. So we are currently shipping, the Zen-based architecture. It started in 2017. Zen is the architecture family name. Zen 1 was shipped in 2017 based off of 14 nanometers, and then Zen 2, the second generation Zen architecture, based as chips. The family was called Rome. That was in 2019. And as recently as last month, we shipped the servers based off of Zen 3, the third generation architecture based off of 7 nanometer process technology. Zen 4 is scheduled for next year, and that will be on 5 nanometers. So very similar story on GPU. Of course, on the GPU side, we had two. One is on the gaming side, we call it RDNA, the gaming architecture. And on the CDNA, the GPU compute side is called CDNA. Very similar story. 2019, we had RDNA on the 7 nanometers, currently shipping RDNA 2, on 7 nanometer, and then RDNA 3 is in design. And similar story on the GPU compute side. very analogous to what's happening on the gaming side. So this is the GPU side of the course. Now, packaging, this may or may not be so apparent, right? Because from an AMD perspective, we have been leading the industry in terms of the packaging technology too. Back in 2015, the high bandwidth memory HBM based GPU was we started shipping that, and since then we have shipped many other GPUs based on HBM technology. In 2017, again going back to the Zen CPU, we innovated with the multi-chip module, and the second generation of Zen in 2019 was the chiplet technology.
We have time is running short. How long it will take to complete this, please?
Sorry, what was that?
No, this time is overshooting. How long it will take?
Another 3 minutes.
Yeah, thanks.
Yeah, so this is what is happening on the packaging side. So now in the future, we have, we are working on the X3D packaging, 2.5 and 3D based technology, which will result in bandwidth and density of greater than 10x. So that's what's happening on the packaging side. So this is the one that I was talking about. You need to avoid bottlenecks, and by facilitating the data flow between various heterogeneous components, right? So first generation, we call it Infinity Fabric. First generation was in 2017, basically on the CPU connectivity between CPUs. This is the first generation Infinity Fabric, and the GPUs, CPU to GPU connections was based off of PCI 3.0. Second generation is basically GPU. You saw the Infinity, second generation Infinity architecture provided CPUs was first generation, GPU second generation, and third generation is going to be delivered later this year in our supercomputer delivery, which will happen by the end of the year. So that is basically CPU and GPU, completely coherent connectivity. That's what will be offered on the Infinity architecture. So again, all this, if you look at this very quickly, CPUs and GPUs in their own way right now, CPU data locally to CPUs, GPU to GPUs, leading to the CDNA2 architecture, unified data, offering ease of programming and improved performance, and basically a CPU and GPU coherency with the third generation Infinity architecture that I was referring to earlier, right? So that's what it is. Now, supercomputing makes is a relevant topic. It's, if you look at this, basically, from 2005 to now, we have been in the supercomputing industry by winning the deployments and delivering AMD technology-based solutions. And we also had the exact scale program funding that started in 2012, going through right now. So later this year, I was referring to the supercomputer that we'll be delivering to Oak Ridge National Labs called Frontier, delivering 1.5 exaflops of supercompute power. Basically, AMD CPU and GPU delivered through AMD software. And then there is the follow-on to Lawrence Livermore called El Capitan in 2023. Now, HPC funding, so just a quick word on this, because we announced last year, through the epidemic, when it hit us badly, we announced a $15 million funding in terms of AMD technology to help aid the research associated with the pandemic, so that it will facilitate the research activities on that. So many universities across the world have leveraged this. 1 petaflop of compute power is being donated to these research institutes, and this is across the world. But in India too, we are working closely with CSIR, the government wing, for Paradigm. So that is being deployed as we speak. So that's where I wanted to pause.
Yeah, thank you so much, Jay. We have a few questions, but we'll take, in the interest of time, we'll take offline.
Yep.
Yeah. Thanks a lot for your time.
Hey, thank you, Satish.
Yeah, thank you.
Thank you all.
We're not able to hear you, Mr. Satish. You're in mute.
Mr. Sanjit Pandit, who is a global head of a smart cities practice at Qualcomm Incorporation, USA, and who is responsible for career and ecosystem relationship in this domain. His expertise in the telecom industry spans over 20 plus years. He specializes in the area of smart city design, creation of smart vehicles, smart verticals, digital transformation, and go-to-market strategies, creating an experience that would benefit public and private domains and citizen engagements. Mr. Pandit has successfully launched the Qualcomm Smart Cities Accelerator Program that brings all smart cities B2B providers under one roof and enables matchmaking in this domain. His efforts have enabled smart verticals and smart spaces, industrial concepts, globally that have resulted into quicker adoption into various industries and industrial verticals. He has developed various smart city revenue models in association with ecosystem partners, resulting in win-to-win situation for all parties. Sanjit has worked and created relationship with the smart city ecosystem partners, resulting in multiple smart cities projects globally. He held various senior positions at Qualcomm, and he was responsible for APAC and India business development prior to leading this smart city vertical. Sanjit is going to chair this panel discussion and introduce other panelists. Over to you, Sanjit.
Thank you. Thank you very much. Very good evening to the panelists from the US. A very good morning to all the viewers and also the organizers. And it's an honor and pleasure today to be chairing this session on behalf of the Iesa organization. With me today, I have T.R. Ramchandran from Septon. I have Kishore sir from GMR Airport. And of course, we have Raghavan from MTK, my esteemed colleague here. All of them, you guys can smile a little bit, as it's allowed, I guess. And would request you to unmute yourselves if you're on mute. And take maybe not more than 30 seconds to give yourselves, which area within, say, Septon, MTK, and Kishore sir, I guess everyone knows you. So you might want to also give a quick update regarding how you're doing in GMR. Quick introduction from each one of you, and we'll jump right in. I think TR, maybe you could kick off. Thanks.
Sure. Thanks, Sanjit. Thanks, everyone. Appreciate being part of this panel. I'm TR Ramachandran. I'm the Chief Marketing Officer at Septon. Septon is one of the top LiDAR companies in the world. We focus a lot on the automotive side of the business, but also in areas like smart cities and smart spaces. And we provide LiDAR solutions as well as full perception solutions. So we work with a lot of customers and partners that are in the areas like, traffic intersections, railways, commercial and public spaces, safety and security in many of these markets.
Thank you. Thank you. Raghavan, quick rundown from your side.
Sure, Sanjit. Thanks a lot. Thanks a lot to IESA and the organizing committee. My name is Raghavan Sampath, and it's my honor and pleasure to be on this panel. I currently work at MediaTek. MediaTek is currently providing system and solutions for smart cities, such as the communication infrastructure network for 2G, 3G, 4G, and 5G global deployments, and India coming soon. We also provide Wi-Fi solutions, narrowband IoT, and wired infrastructures like PON and Ethernet-based solutions. So typically, MediaTek is offering the backbone for smart city deployments, AI and smart city deployments. Thank you, Sanjit.
Thank you, Raghavan. Kishore, sir, please.
Thank you, Sanjit. This is Kishore. I'm the Executive Director and the Chief Innovation Officer of the GMR Group. And I was also an IAS officer, so I'm an ex-bureaucrat. Coming to the GMR Group, as you all know, it's one of the leading global infrastructure players, especially into the airports. We design, develop, and operate the airports today in India, Delhi and Hyderabad, two airports, major airports, which almost cater to 40% of the traffic, civil aviation traffic, what we have, we handle them. And we are also in the technology forefront as to how we can adopt various emerging technologies into the aviation industry and hence enhancing the passenger experience and increasing the efficiencies. So it is a privilege to be a part of this panel. I think I'm the odd man out because I'm not a technology man, in the sense that I'm not producing any products for artificial intelligence or any of these things. But I think I can give you what is the sort of opportunities the industry has for this industry, how in the next few years, in the coming decade, how this will entirely revolutionize the whole way each player, each stakeholder in the ecosystem operate. Thank you, Sanjit.
Thank you so much, sir.
I was going to say, Mr. Kishore, you're the reason why some of us have jobs. So
I would second that. Thank you. See, it has been said that the global market for smart cities in general is going to grow to about $500 billion by 2027 with a CAGR of about 25%, and that is huge. And smart cities and smart connected spaces, as we terminalize this, categorize this, or containerize this offering, can be looked at in various ways when it comes to every particular market or city. In some countries, a smart city could be just basic sanitization and roads and just water. In some cities, like Singapore, Taiwan, Korea, it could be a completely different paradigm when it comes to smart cities and smart connected spaces. But one thing we cannot deny is the growth of AI in this domain. And Raghavan, I will start with you. Where exactly you feel today, how much of as a silicon vendor, how much of a importance are you giving in terms of design, adaptation, embedding some of the engines in your offerings when it comes to AI? And how is that getting translated by some of your end customers?
Sure. Thanks, Sanjay. As you rightly mentioned, the smart city definition varies from city to city based on the needs. And for example, I'll be specific to some of the India requirements, right? Sure. So look at Delhi. Delhi has huge air pollution, right? So Delhi needs some of the sensors where you can get the data of air quality index in real time. And you need to ensure that you have air purifiers, go solar, electric vehicles, adopt renewable energy and reduce carbon emissions. So typically, smart city and the governments are looking at making the life of a common man, the ease of living, typically the ease of living, comfort, convenience, right? So in order to address these requirements, you require a lot of gadgets and connectivity, right? For example, the air quality sensor connected to internet, feeding the real-time data of the air quality itself, right? So what we do is at MediaTek, we provide the necessary chipset with the artificial intelligence coprocessor. So what does these artificial intelligence coprocessors do typically? So they run the algorithms which are fed by the OEM or the original equipment manufacturer in terms of various data crunching. So you have several algorithms which run on the coprocessors, does the data crunching, feedbacks to the cloud, and the OEM or the government agency can take the necessary action. So they can predict probably 15 days later or 1 month later, how is the quality of the air. So I'm just giving one example of quality air, and it could span to surveillance, security, right? And smart mobility, traffic management. And it could also go into the utility management like smart meters for the electricity, gas, and water, smart parking. So the applications are numerous. So what we do is, so we provide the necessary backbone for the OEMs to implement these gadgets or these equipments in smart cities.
Great, great. And TR, knowing Septon and the fact that you guys getting into a lot of sensor fusion and creating some unique requirements around traffic congestion, etc. On LiDAR, where do you see the fine line between cameras and LiDARs, and how do you differentiate, or do you guys even differentiate on the AI that you're running on this? What portion are you doing on the edge? What is on the cloud?
Sure. If I may, I'd like to just maybe start with one sort of general concept, the way I think of a smart city, building on what Mr. Raghavan said, which is I like to think of a smart city as a construct where there's a combination of technology, data, and analytics to meaningfully improve the sustainability and quality of life of the residents of the city. So it could be health, security, safety, cost of living, or efficiency, right? Now, when we think of how LiDAR gets applied, and in the context of your question about cameras, for the benefit of some of the audience, LiDAR, light detection and ranging, it's essentially a sensor that provides a 3D, highly accurate 3D view of the environment, right? That's where it's the value of LiDAR comes in. And one of the key value points of LiDAR also is that it is anonymous. You can't identify people. So we see a lot of interest, especially in this age where people are getting worried about privacy with cameras. There's an interest of having LiDAR. But in terms of how we see the separation, it's pretty simple. It is any solutions where you need accurate 3D information, and any solutions where that accurate information needs to be available 24/7, regardless of rain or sun, regardless of darkness or light, we see a very strong demand for LiDAR coming in. And it cuts across these different applications.
In case of a camera situation, the accuracy is anywhere in the 90s to maybe 99, depending upon light, shadow, images. How do you compare that accuracy in terms of AI with LiDAR?
Yeah, with LiDAR, I mean, at least the feedback from our customers is that for many of these applications, they need accuracies in the 99.99 or 99.96 type percent. And that's why they're very pleased with LiDAR. Obviously, LiDAR costs a little bit more today, but those prices are coming down very rapidly, and we are one of the companies making that price drop happen. So we very much see the adoption of LiDAR growing quite rapidly in many of these applications.
Perfect. So, Kishore sir, given the situation that companies like us, like Qualcomm and MTK and Septon are making all this stuff, finally at the end of the day, it has to be deployed somewhere. I cannot come to you with a chip and say, Mr. Kishore, here's my chip. You're going to say, what am I going to do with your chip? I need a full end-to-end solution. So give me maybe one or two exciting use cases that GMR airports, you handle more than 40% of India's traffic between Bangalore and Hyderabad, in Delhi, I mean, we cannot miss you when we come to India. So we have to come via your, via your channel. So what have you adopted so far, and where do you think this is going to take GMR to the next level, AI?
Yeah, Sanjit, before I talk about what GMR has done, some use cases, interesting use cases, technology, since the theme of today's panel discussion is artificial intelligence for smart cities. So I want to give you what is the immense opportunity which the industry has. If you see, smart city is an outcome. Artificial intelligence is the platform. So how do we use this platform to create smart cities? Like, there are umpteen definitions of what a smart city means, but ultimately the bottom line is the quality of life in that particular city for the citizens should be of the topmost standard. So the importance of artificial intelligence in creating this outcome is very, very important. And if you see, artificial intelligence now percolates into all layers of digital technologies. It is not an entity by itself. It is all prevalent, omnipresent. That is how it is now transforming into. And currently, the artificial intelligence market is around $2.5 billion. And in 2023, it is supposed to go 10 times, around $30 million. So the $30 billion sort of opportunity we have. And most of the governments now have realized that they have to invest hugely into artificial intelligence. Not only the businesses, but the governments are also visualizing to enhance efficiencies, to create growth, and also create a best quality to their citizens. Investment into artificial intelligence is very, very important. And today, the artificial intelligence have implications in social sector, economic sector, political sector, manufacturing sector. So it is all prevalent 360-degree sort of impact artificial intelligence will create. And today, if you see, one of the estimates says that by 2035, if governments adopt artificial intelligence as a platform, enabling platform, and creating an open environment, by 2035, this could double the growth rates of the countries, the economic rates. So that is the sort of impact what artificial intelligence can really create. And like any progressive country, Indian government also has understood and appreciated the importance of artificial intelligence. And they have created a committee, an artificial intelligence standardization committee under the Department of Telecommunication, wherein how do we create an architecture for artificial intelligence so that it is not just closed-end, but it is an open-ended artificial general intelligence, so that different entities can talk to each other. So that is what they are coming out with, a standard Indian stack for artificial intelligence. This is what government is working, and businesses are also working on how do we enhance mainly the objective of adopting artificial intelligence is to see that service quality increases, process efficiencies increases, and your outreach increases. When I say outreach, for example, in healthcare, today India is a huge country and we have scarcity of experts, medical experts. Artificial intelligence can really ensure that the expertise which is there in the metropolitan areas and the urban areas go to the remotest rural area. So that is why outreach, the delivery of services can be made much more efficient. And if you see,
so you're saying primarily the artificial intelligence cutting across multiple verticals within not just the cities, and that's where I'm saying you have to differentiate smart cities and smart connected space. An airport is a smart connected space. A campus is a smart connected space. A smart city may have some things which don't belong in, like the city may not have control over an airport. It's not in the jurisdiction of an airport. So you're saying similarly, verticals, right, like healthcare and maybe governance, or even security, surveillance, national security, these things could be pretty much interlayered.
You take any sector, be it agriculture. Today, what is the problem in agriculture? The farmers really do not know what is the demand for a particular produce. So artificial intelligence tools can tell you what is the sort of crop selection. They will help in crop selection. They will also advance warnings for pest attacks, improved logistics, improved warehousing. So there is immense potential. And that is why the importance of AI, why I'm talking about the artificial intelligence stack is, that is where every layer, it's a horizontal stack with 6 layers. And in every layer, industry is an opportunity. If you take the infrastructure layer, it is all cloud, distributed cloud. So all the cloud industries in the cloud systems will have a lot of opportunities, be it cloud or edge computing. You'll have a lot of this thing. There's a huge storage layer, warm data and hot data and cold data. Then there's a compute layer where data analytics, tracking technologies, your computer vision, these sort of things come. And then there is the application layer and the ultimate customer interface layer. So if you take all these 5 to 6 horizontal layers, which the government of India is coming as the India stack for AI, every segment, there is an opportunity for the industry. So what I'm suggesting is industry should be cognizant that coming few years, this is the 4th industrial revolution, what AI is going to do. And right from sensors till computing abilities, processing, storage, analytics, natural language processing. Huge opportunities will be there, and the industry should be geared up to seize this opportunity. That is what I wanted to do.
Great. So, sir, how does that translate into what GMR has done, maybe in 1 or 2 use cases at the airport? What have you taken? How are you helping the crowd management? What are the things that you guys have proactively worked on in AI?
Sanjay, thanks for that question, because if you talk about an airport, it's no longer just a transportation hub. It's a mini city. If
Absolutely.
You typically go to a new generation airport, which GMR was a pioneer as far as Indian airports are concerned, you have travel retail, you have security agencies, you have customs immigration, you have ground handlers, you have baggage handling, you have cargo. So each of these things, today what GMR has been doing is, how do we bring in new technologies so that the passenger ultimate bottom line is the user experience?
Absolutely.
Because today airports are gateways to countries, and every citizen feels proud when someone lands in a particular airport. It delivers the message what the country is about. If you have
Absolutely.
a shabby, dull airport, you will not get good vibes about that particular region or that particular country. So it's a matter of pride as well. It's a matter of
It's
brand.
the first it is the first impression. It is the first impression.
Absolutely. So what we have done is, we started doing advocacy to the government agencies as well, saying that the new emerging technologies, be it AI, ML, data analytics, IoT, your blockchain, computer vision, these will enhance the security controls, not diminish them. So today, if you see a few years back, if someone comes to India, you have baggage tags which will be manually, physically inspected and printed and stamped by the security agencies. You have boarding cards which are being stamped. Now today what we have done is, we have removed all of them. GMR as an airport operator, we have advocated with the government security agencies, and we said we will use computer vision technologies. Not only processing that particular incident or event, but it will also give you the entire history. That is where again artificial intelligence will come into picture. So now almost most of the airports, we were the front pioneers in that. Now you don't have any stamping of boarding cards and any stamping of baggage tags. The other thing what now we are doing is, how can we remove, especially after COVID, the new norm of travel, how can you dispense away with any paper documents? How can you make your face as your boarding card? So currently we are working with Government of India with a new initiative called Digi Yatra, wherein individuals can register themselves along with their security credentials. And once they register, it is self-registration. We're not storing this data somewhere in the cloud. It is self-registration, and as and when you travel, you can transmit your data to the airport, and the airport systems will talk to the airlines, departure control systems, and we see that using the face, the entire passenger journey will be seamless. So that is what we are, biometric processing, passenger processing is what we are looking into. So this is one example where we are giving a better experience to the user. I'll give you one more example before I close, is how do we increase the process efficiencies and enhance the safety of the travel. Like today in typical airport, entire airside, daily there will be physical inspections of the runway, wherein to see whether any foreign objects are there, whether the surface is clear for the aircraft to land, etc. So it's a very, very mandatory and a very, very important activity. Now what we are doing is, we are trying to bring in drones or LiDAR technology, like what TR was mentioning, LiDAR technology, so that the entire inspection will be much more faster, much more comprehensive, and you also get a history of the surface, the pavement, what the hard and the flexible pavements which you have on the air side. You get an entire history, how the pavement is deteriorating, when is the requirement for intervention. So this is one example use case where the traveler may not know, but it is happening in the backend. The other thing is, GMR has a maintenance repair facility for aircrafts. We were the first ones to put such a comprehensive facility for the maintenance and servicing of aircraft. Otherwise, all the Indian carriers, aircraft used to go abroad. So this particular facility, what happens is, when an aircraft gets inducted, physical inspection of the entire airframe of the aircraft will be done by an experienced person. So an experienced person with his lot of knowledge, he will find out where the problems of the airframe is there. But now if you use drone and LiDAR technology is there, the individual experience will not count. it will be much more comprehensive. So the errors which will creep in an inspection of an aircraft, at the surface of the aircraft, will be much more comprehensive if you use AI technologies. So this is where what I'm trying to say is AI will become an essence of day-to-day activity. Today you are using Siri, you are using Amazon Echo. All these things are natural language processing. They know what are your preferences. Today, if you go to an Amazon portal, it will take the artificial intelligence of your browsing patterns and will pop out. So in
Absolutely.
travel retail industries, without we realizing, artificial intelligence is creeping into our day-to-day activities, and it's only a matter of time that artificial intelligence will be the common layer for any activity we do. And that is where governments and businesses and the industry, because the demand is there, but the industry doesn't cope up to cater to the demand, to bring in new innovations. That is where I think there's a huge opportunity. And just recently, we have started our innovation platform called GMR Innovex, which I am heading, wherein we want to create an ecosystem where industry players, startups, and other corporates, it's an open innovation platform. We can collaborate together to come out with new ideas, new products, new applications, which will help in improving the quality of the life what we are enjoying currently today, betterment of that, and enhance the process efficiencies.
Perfect. So, I'll take this opportunity to reach out to all the audience and all the people who are watching, to reach out to Mr. Kishore via the organizers, if they have anything that they can offer, and be a part of this platform. Now, talking about platform, Raghavan, are you seeing, is your company moving towards a reference design, any kind of out-of-the-box solutions that maybe some smaller startup companies in India or anywhere in the world could take and have a faster time to market? What kind of activities have you guys put together? And is there some kind of a innovation lab or anything that you guys are working on?
Sure, Sanjit. Thanks a lot. As Mr. Kishore said, you would need solutions to install to enable smart airports or smart cities, right? So what we are doing is, in India, we are working with an ODM, the design partner, who has done a smart surveillance camera with complete analytics of face recognition, pattern recognition, behavior recognition of the individual. And everything is running on the edge. It's not on the cloud. So most of the time, going back to the cloud and retrieving the data and processing the information would be time critical. For example, boarding, right? In airports, as Mr. Kishore rightly said, you can't go always to the cloud and fetch the data. You have to do the edge processing. So with an Indian ODM, we have a complete reference design, and he has given to an OEM who is doing smart surveillance camera in India. He's selling the smart surveillance camera. So this is one example. We are working with, again, as Mr. Kishore already said, voice recognition and native language support. So just not recognizing English language. India has probably 30, 35 native language. You need to recognize the accent. You need to recognize what the individual is seeking information for, right? So for instance, Samsung launched a washing machine yesterday with the voice recognition in India, right? So in India, he has to support the 35 languages. So again, we have worked with a Bangalore-based company who is one of the AWS certified and Google certified lab who has the complete acoustics. So in order to certify the smart speaker, you need the acoustics lab and also ensure that you have the mic array and the DSP and the algorithms, the native language support algorithms. So what we are trying to do is promote such design partners, promote such ODMs who can enable the OEMs to make an end product so that Mr. Kishore and other government agencies and the smart city deployment, the system integrators, typically could use the solution and go to market quickly. I'm pretty sure Qualcomm is also doing with various ODMs, not just India and globally. So that's the bread and butter for us. So we enable the ODMs and the design houses to provide you the complete solution.
Thank you. Thank you. Now, TR, in the areas that Cepton is working with the AI and everything, you guys have a completely different target audience. You're working with maybe Department of Transportation. You're working with lots of rules and regulations, automotive kind of customers. Where do you see your challenges in adoption of AI? There's a lot of R&D that goes into that. How easy for it to proliferate down to where the rubber hits the road, literally, with no pun intended, in terms of automotive. But where do you see that? And are you seeing a lot of resistance? Can you just throw some light on the automotive side of the AI portion?
Sure, sure. And if I may, I'd like to also maybe set a little bit of context on how we think about AI.
Okay.
And there's an interesting article written by Professor Michael Jordan from UC Berkeley about a couple of years ago. And he talked about, AI, and he set the context saying AI, as we talk about it generally, he broke it into three categories. Sort of the human imitative AI, right, where the AI is trying to replace the human. Then there's intelligence augmentation, or IA, where it's actually trying to help human activities, not replace them. And then there's intelligent infrastructure, or II, right, where it's trying to take data but convert it into something a lot more useful to make our lives better, right? So when we think about AI, it sort of it could fall into any of these categories. For instance, some of our applications, I'll use an airport example to start with, given Mr. Kishore's comments. So we recently worked with one of our partners, the Indoor Lab. They've been in the airport space in the US for a long time, crowd management, queue management, a lot of these things. And they deployed a solution with our LiDAR as well as our perception software at Orlando International Airport, covering an entire terminal, where for the first time, state-of-the-art, continuous statistics on literally everything happening inside that terminal. Number of people, where they are, where they're moving to, how they're moving, how's the space being used. So that's a level of rich detail. A lot of it obtained just, at the edge, right? They use our edge computing or edge perception. So that's an example of one type of solution. In that case, it's a static application, right? The LiDAR is fixed, it's not moving. So the level of sophistication of the application, it could be potentially at the level of II or maybe IA, right? Now, if you go to the other end, which is transportation, where you might either be on a vehicle or sometimes on an intersection, but at a very complex intersection with a lot of pedestrian and traffic activity, you may need sort of true machine learning to augment the algorithms in your solution. And in that case, some of the challenges that you have to deal with are simply that, life is complex. You can't solve your way through just by data labeling and so on. You have to build a lot more intelligence for the system to quickly learn and deal with all kinds of situations. What happens if one vehicle is blocked by a bus and you see a portion of it? How is your perception system going to interpret that, right? Or what happens if someone is walking across the intersection with a shopping cart, which is, how are they going to look to the system? So then you start to bring in the need for more sophistication. So we adapt our solutions depending on the end application.
And how do you, where are you guys in terms of automotive deployments?
Yeah, automotive deployment, we
sorry. Automotive deployment with respect to AI.
Oh, yeah, sure. So with respect to AI, the way we approach it is our primary focus market is actually the ADAS market, right? This is the advanced driver assistance system. So this is not the full self-driving vehicles. In the ADAS market, the level of software required really depends on the automotive customer you work with. Because some of the leading customers we work with, they have their internal teams, in-house teams. And for them, the AI stack, the fusion, et cetera, is actually part of what they monetize. So they may actually say, just give me the hardware, and a basic level of software, and we'll take care of the complex AI, right? But if a customer needs the full solution, then we'll provide a full AI stack to
end-to-end,
right?
and the end-to-end offering, correct?
Correct. But in that case, what happens is you will need to qualify it for their use case, right? For example, when you talk automotive, what is the ADAS use case? Is it a automated electronic braking? Is it a traffic jam pilot? Or is it a highway pilot? Depending on the application, the level of features, the level of validation, all of that varies. And then you have to do that case by case.
Thank you. Thank you. So, Mr. Kishore, jumping into what TR said, they have a fantastic LiDAR system and, people are getting information on the edge, how does GMR, if tomorrow I come in and say, Mr. Kishore, I'm going to put in with my technology and maybe Raghavan's, startup, and also with the LiDAR that Cepton is going to give you, predictive, prescriptive, and preventive analytics and intent-based analytics that I can give you. If I tell you, if a flight is coming from London, Shiva's Regal is bought more than Johnny Walker. If a flight is coming from maybe Dubai, people are buying chocolates more than alcohol. If someone comes and tells you that I'm getting more and more traffic for perfumes from the flight that comes from the Southeast of Asia, how would GMR use that data and go to the retail people and say, you know what, if you're getting a flight coming from Southeast Asia, this is what needs to be on the shelf. Are you doing that? Would you be interested in doing that? And how would you monetize that?
So Sanjay, is a very pertinent question, because whether we are doing that, yes, we are doing that. Whether we can improve it further, yes, there is a huge opportunity to improve it further. Like today, forget about the technologies.
Okay.
The data, what we are capturing today, one is to understand the importance of the data. Airports are huge repositories of data. Till recently, we were never appreciating the importance of the data which we have. When we started doing it, even without using technology, like suppose, as you rightly mentioned, a aircraft which is going to a particular destination has a demand for a particular type of product. What we are doing now is we are allocating an aero bridge which is closer to that particular store or a retail outlet. So the preferences of the travelers, be it in terms of retail, food, and also the type of experience what they would like to have. That is one thing. Second thing is, because of the huge computational advancements what we have, they need not physically see the store. So what we are trying to see is, can we give them a virtual store, especially after COVID, where they can always book what they want, block what they want, and that is delivered to their homes. So this is the ultimate objective. Now you need not carry physically the product.
Okay? I'll tell you, you have done something smart. If you book an alcohol bottle when you're departing and you pick it up on arrival, it's cheaper.
That is what we have been doing. In fact, we are giving an incentive. If you book on departure,
yep,
you get an additional 10% discount. So that's what we're doing. So
exactly
what I'm trying to say is, airport is a mini universe, and today we are open. Like what I mentioned, we have just launched an open innovation platform where any industry, any OEM, any startup can approach us and say that, one, they can say that we see this opportunity, or second, if they know that if they impress us saying that they have the wherewithal and the talent to develop a particular solution, we will give them the opportunities. Now, one of the main objectives what we are now doing, Sanjit, is basically how do we have a smart airside. The airside is where lots of personal and vehicular movement happens.
Mm-hmm.
Now, that is a threat to safety and security, because more human beings, more prone to human errors, intentional or unintentional. So how do we, the ultimate objective now what we are working is, how do we have smart airside wherein the entire vehicles will be tracked, the vehicular movement will be decided based on the requirement, that is the turnaround of the aircraft, and the ultimate thing is, can we remove away the manually driven vehicles, autonomous vehicles, because it is a set route which a vehicle has to go. So this is a good living lab sort of an opportunity where all those people, because now today autonomous vehicles, smart mobility is one of the major areas where number of startups and number of industries are working. It's still technology under progress, development. So airports could be a good opportunity where you can demonstrate so if you talk about smart mobility, it has all ingredients of artificial intelligence, decision making, pattern recognition, natural language processing, remote control, computer vision. So all the technologies could be demonstrated in an autonomous smart mobility sort of an opportunity. That is one aspect. So we are open. So we are saying that our airports will be like living labs. Not only on the air side, on the land side also we are developing airport cities. If you know, in Delhi and in Hyderabad, there is a huge landside ecosystem which is getting developed. Especially in Hyderabad, we're developing around 2,000 acres worth of greenfield smart airport city we are developing, which has travel retail, which has hospitality, which has SEZs, free zones, logistics warehousing, and all this entire city, waste management, utilities. So all these things, any new technology, new product, if any startup wants to work with us, of course there will be some filters because I cannot take anyone. We are developing a mechanism where we will select the startups, we will select the OEMs, we will select the industry players when we give them an opportunity to demonstrate their technologies, their products before large scale deployment. So
I understand.
a living lab sort of a concept is what we are working upon. And just before it goes, I want to also say that AI will go a long way in creating sustainability also, environmental sustainability. Today, we as airports, I'm a governing board member of the World Airports Council International. What we have taken is carbon neutrality in scope 1 and scope 2 emissions of the aviation industry is what we have to work upon. 2050 is what we are targeting. And there, these sort of autonomous electric and computer driven vehicular systems which will bring down the carbon emissions and which will ensure that the carbon neutrality or carbon negative thing happens. Like today, Hyderabad airport has 10 megawatts of solar power plant which supplies to the grid. So that means my terminal doesn't depend on the conventional grid, it depends on the green power. What we have done, the entire 5,500 acres, I'm just slightly deviating from the technology.
No, please do, because this is critical.
Find applications in all of these things. Now, what we have done is the entire landscape irrigation. I don't know if someone who would have visited the Hyderabad airport, you have a beautiful landscape the moment you enter the airport premises. The entire thing, landscaping, to reduce the water consumption, we have gone for a microprocessor controlled drip irrigation. So again, the AI will come into picture. During which season, what sort of water should be there, what sort of water, so that my consumption of water has come down significantly. Now, what we have done is using satellite imagery, we have identified spots where we can impound the rainwater. Today, I have created a reservoir which impounds rainwater, which can cater up to 3 months of my requirement.
I see.
This is again, what I'm trying to say is this has improved the groundwater levels of the neighboring area. Second, my dependence on the public grid, water grid, has come down to that extent. So it is becoming self-reliant, self-sustainable. We have an entire waste management process where the entire tons of waste, human waste, which the passengers and other ecosystem providers generate, we are biodegrading that, and the entire compost which is required for the entire landscaping is being generated through organic manuring. So this is where huge opportunities are there, and AI becomes an essential ingredient of any activity which you will do in future. So that is where we are open. We will give a platform to the most reliable and most promising startups and industries, and we believe in collaborations and partnerships. GMR is for that. So we're open, and I am sure India will be one of the leading nations where AI will be deployed on a large scale.
Sir, now that you're talking about partnerships, we were talking about partnerships with respect to private enterprises and coming in. I want to ask a very simple question. Whenever I come in to India, the only thing I want is I need my bags quickly. I want to get out. Whenever I'm leaving India, I want to make sure the immigration is done quickly and I quickly get to the plane. How do you partner with the baggage handling, which is handled by you? How do you give that information? How do you give information to the immigration authorities saying, this is how the crowd management is going to be, this is the peak time? Do they get data from you right now, or would you be willing to share that data with them? How is your collaboration with these entities?
The airport operator is the integrating point of all the stakeholders: airlines, ground handling agencies, customs, immigration, aviation security officials, etc. So what we have done is, as you rightly mentioned, sharing of data is happening now. Especially what we have done is the stress levels of a passenger. If you are a passenger, why do you feel stressed when you enter into an airport? That is one, because you may not be conversant with the entire airport layout, where to go, how to go. So one is, how do we give dynamic information once the passenger leaves from his home for the first time traveler? There could be a frequent traveler who knows about the whole airport layout and configuration, but still there is stress because one, whether he'll miss his flight, whether his registered baggage is on board or not. So what we are now doing is, we have done a pilot use case with SpiceJet, wherein we are ensuring that every passenger will get a alert on his mobile if he has registered bag. Before he boards the aircraft, he will get an alert saying that your one registered bag is already on board. So this is what we have tried with SpiceJet. Of course, it was with someone who has to log in onto the SpiceJet application. But now, with the success of that use case, now we want to do on the GMR Hyderabad Airport portal, how you get alerts both for the departing passengers and also for the arriving passengers. So that we are working, because there are too many systems with which we should communicate. And this is, I believe, blockchain as a technology, which will be very, very useful, because when you have too many players who can produce different segments of data and still you want to share, and the trust is required that the data which you have generated should not be tampered by the other stakeholder. I think blockchain will be a very appropriate technology. So what we have done is, now we are working with one startup from Hyderabad. Especially, if you know, Hyderabad is a major vaccine production city. Almost 40 to 50% of the global vaccines are being produced in Hyderabad, and 70% of the vaccines are produced in India. So what we have done now is, especially with the COVID, because of huge logistics issues of transporting the COVID vaccines all over India and also globally, and cold chain, the temperature control is very, very important in the pharma products, especially vaccines. So by using blockchain technology, how do we keep tracking the movement of each consignment of the vaccines and also the temperature? This we are working with one of the startups, so that the exporter knows real time where his consignment, where his box is, and at what temperature. And similarly, the importer, who is the end user, also will get the real-time data. So I'm just giving this example to see that tracking technologies will ensure that the quality of the products will be of the highest quality. And similarly, baggage tracking. I have given the example of cargo, but similarly, applications could be there in baggage tracking, where passenger clearly knows where his bag is. So some of the airlines have come out with a RFID tag, so that you keep knowing, especially in transit globally, when you're traveling international and transit airports, you're really worried whether your bag will get into the connecting flight or not. So these sort of things are happening. And once we have the AI stack and we have a mechanism of acquiring the data and storing it and edge processing, if you get, I think all these applications, it's only the application layer. What we're talking is the application layer. But what is the top side sort of architecture which entities have to develop, especially entities like airports, which are multi-stakeholder ecosystems. It is very important you acquire data, ensure that the data reliability and data correctness is there, and then store data in an appropriate way so that the computation will be fast, the hot and cold data and the data lakes, and then the analytics layer. That is where, in that analytics layer is where the artificial intelligence, sort of predictive things, the trend analysis, all those things will come into picture. So what we are working now is, while engaging with the application developers, we are also trying to see whether our architecture has to be changed, so that it will be a seamless sort of, anyone can come and plug his application onto the platform, and it will create the impact which is intended, which is supposed to give. So this is where we are working, and we are open to work with any of the partners.
Thank you. I'm going to leave 5 minutes for the questions, but before we go, I need a 10-second answer for each one of the panelists. TR, where do you think AI is going to be in 5 years, 10 years from now?
I think my answer is a bit more practical, which is AI is going to be where there is a material benefit to people, right? Whether it's safety, security, health, etc. You have to demonstrate a material benefit. If there is, and it's an efficient way to solve the problem, cheaper, faster, etc., it's going to, like Mr. Kishore said, it's going to be really embed itself in that space.
Thank you. Raghavan, quickly, where do you see your AI in 5 to 10 years?
Finally, AI or smart cities or IoT is for the benefit of the end user, right? So if AI could make individuals' life healthier, safer, comfortable, and convenient in all terms and all aspects, then AI would be a runaway success. So I see AI delivering these needs of the individuals.
Kishore, sir?
I think in 5 years down the line, 5 to 10 years down the line, I think AI would have crept into every aspect of our life without we realizing it. And I'm sure most of the IESA members would be big powerhouses supplying components and processing capabilities and gadgets for the industry. So I wish all the members of IESA all the best. It is a very opportune topic which you have selected. And I should also thank the organizers for thinking that I can contribute in these technical discussions. So I wish all the best for the IESA members.
Absolutely, sir. Don't say that you could contribute. Even if a cup is full with milk, you can always add a lot of sugar. So, as far as my opinion is concerned in AI, I think AI, what today AI is what internet was in 1997, 98, when we were just sending email and just getting on Rediff mail or just basic stuff. You never imagined that you will be able to order something online and get it delivered the next day. You could never imagine you could be able to see your banking account and transfer money the same day. That's where AI is today. I don't know what's going to happen in 5 to 10 years, but I can tell you we're at a very nascent stage of AI. And if you think this is changing your life, wait for another 5 years. You know, I think we'll all look younger with it. I think we'll all look younger with AI, with algorithms. We better take the snapshot and see ourselves in 5 years and run an AI that we could look 5 years older or younger. All right, so I'll quickly switch to the questions if there are any. I see a few hands up raised. Hariom, any questions? Or if not, we could end on this note. I'll let some of the organizers here, Satish.
Maybe we have questions here. What are the privacy and ethical concerns of using AI in smart cities and how they are being addressed?
Good. I'll let maybe TR, do you want to take a stab at that? That's because you guys, you have it on the Orlando airport. How are you looking after that?
Yeah, absolutely. So I think the privacy element is something we hear a lot increasingly in the last 2 years, right? So in fact, there are many of our partners who have traditionally deployed camera-based solutions are now coming to us saying, no, it needs to be LiDAR because there's just, GDPR, this, that, there are a lot of privacy implications. Also on the roads, okay, you can't record license plates when you're recording what's happening in traffic without permission. So the way I see that evolving is that LiDAR-based solutions, especially as they get cheaper, which they are, will become more and more mainstream. And there are cases where you need identifying information. Let's say there's an incident. Someone's running too fast or a car's going too fast, going in the wrong direction. The LiDAR system is smart enough to send an alert to maybe a camera system to say, okay, record that. Because there I do need identifying information, and legally we have a right to collect identifiable information in that case. So I really do see that these technologies can work together very well in the coming years to balance the need for identifiable information where it's critical, where it's safety or security, for example, and then preserve privacy where you can.
Thank you. Thank you. There's a question from the panelists to the panelists saying, which city across the world would be called the smart city, on which parameters? You know, I'm a big fan of Singapore. I would say that is a living smart lab. Easy to control, very structured approach. Everything works perfectly. And they've done a lot of effort in terms of citizen enablement and governance. And right from the time you enter the airport till the time you leave, the experience is fantastic. If you're living there, yes, you may feel it's a little bit of a smaller place, but it depends on where you come from. And at the end of the day, I think the enablement across multiple sectors, may it be utilities, power, mobility, transportation, everything seems to be very well orchestrated. Other examples are Korea, Taiwan. Obviously, some portions of India are also coming up, in the own way possible. But, what it was 10 years ago, things are much better today. And thanks to the government for helping with that. I think we'll have one more question before we end on time.
Yeah, we have one more question, Sanjit.
Sure.
What is the wastewater management for water? Finding new water resources is good, but the managing wastewater is one never heard in any form.
Yes, so I think we heard Mr. Kishore talk about how they are using, and biodegrading waste. As far as water is concerned, there's a lot of harvesting of water. There's a lot of wastewater purification plants happening across. Israel is one of the leading countries into that. US also is taking a lot of wastewater and also harvesting water in various forms. So yes, there are applications being deployed across the world, and those water is a very important resource, as everyone knows. Various companies like Euros out of Finland, UROS, they are experts in water management, and we work very closely with them in terms of offering them sensors for connectivity and other Eurosense and Eurosflow that we use. All right, Satish, I think we are pretty much on time. I was told to end on time as we got a little bit delayed. Again, I would like to take this note. Thank you very much, Kishore, Ramchandra, Raghavan, and Satish. Thanks a lot for hosting this and getting it done. I think, as I said, take a snapshot of this 5 years from now when we are at AI Summit. We can run the AI to make us look the same 5 years ago. On that note, have a great night and a great day, guys. Thank you so much.
Thanks a lot.
Thanks, everybody. Thanks a lot.
Yeah. Thank you. Now we have another keynote on advancements in semicon for AI and ML applications. For this, we have Mr. Sundara Ramalingam, who is working as Global Director, AI Consulting Partners at NVIDIA. Mr. Sundara Ramalingam has a very strong technical background, and his areas of interest include deep learning, big data analytics, IoT, and automotive solutions. He has more than 20 years of experience in solutions involving visual computing, AI, and high-end performance computing, high-performance computing. He has also exposure to work cultures of multiple countries in the Asia Pacific region. Over to you, sir.
Thank you, Satish. Good afternoon, everyone. Just a quick sound check. Am I audible? Well, Satish, if you could please confirm.
Yes, you are audible, Mr. Ramalingam.
Excellent. Thank you so much. All right. Good afternoon. And thanks to IESA for inviting me over and asking me to deliver this talk. So this is the fourth IESA Summit that I'm delivering a talk, and it always is a pleasure to deliver talks at IESA Summit, because this is where you meet people from the same industry. Most of the people are from the same industry, so that's always exciting, and very happy to be here. All right. So the area of accelerated computing, or the area of high performance computing, has seen a lot of developments in the past several years. I would say about 7 to 8 years time. That's very commonplace knowledge. And particularly talking about data, the way data is getting handled also has changed drastically. Starting from the heuristic methodologies of working, which is nothing but your basic computer programming approach. In other words, if then else way of working. If this is the condition, this is the result, else this is the result. That has been there for long. It continues to be there, and it will continue to be there for long. And then comes machine learning, the traditional machine learning techniques. And then comes deep learning. So data analytics has changed a lot. Advanced data analytics has changed a lot thanks to the advent of the advancements in machine learning, and more importantly, the unprecedented advancements that have happened in the deep learning area. And one very important trend that is happening in the world today is that the demarcation between AI and high performance computing is slowly vanishing. If you imagine AI to be as one circle and high performance computing, a traditional high performance computing as the second circle, and there is an overlapping area between both the circles, the overlapping area keeps on growing a lot, and the distance between the centers of the circle is narrowing down. So that's a very, very important development that has happened in the past several years. And we are having this summit, and we are having this conversation here thanks to the big advancements that have happened in AI, machine learning, and deep learning. And overall, I would bucketize these developments under three major heads, which is data analytics, advanced data analytics, artificial intelligence, and simulation. Right? These are the big umbrella terms which I would use to explain this development. So there are two complexities involved here when managing these developments. The first complexity is the amount of data that gets handled. There is huge, unprecedented amounts of data. I really don't want to bore you by giving numbers. I think it's commonplace now. The knowledge is commonplace now. Data is getting spewed from anything and everything. And you need very, very powerful systems. You need the right semiconductor who can handle this enormity of data. The second one is the complexity of the models. The complexity of the models that have been handling data, that have been handling analytics, that has been handling AI, machine learning, etc., is growing in a big way, in an unprecedented way. Gone are the days when people are happy with the traditional CNNs and RNNs and LSTMs. Those days are gone. Now people are looking at more complex models, much deeper models, in order to get not only faster results, but also to get, more importantly, better results in terms of the accuracy. So all this needs a much reorganized, re-architected semicon to handle that, because the traditional way of computing is not going to work. That serial way of computing is not going to work. There's a limit to the Moore's law. So that is where GPUs kick in. And a very important introduction, which we did recently, like almost a year ago, is what we call as the NVIDIA Ampere architecture. This being an IESA summit, I decided to spend about 5 minutes on the hardware part of it, but let me caution you, I'm not going to spend too much time on the hardware. I'm going to very quickly move on to the software aspect, which is going to be very interesting. But I thought, I mean, it's the right forum to talk about the advancements in the semicon in the hardware also. And so I'm going to take about 5 minutes to introduce you to the new architecture called Ampere, which is an architecture which has totally been designed, totally been architected specifically for running AI applications, data analytics in a very, very optimized way. There are like many features. Obviously, I don't have time to cover all of them, but I'm going to touch upon the top 3 or 4 of them. Obviously, the world's largest 7nm chipset with 54 billion transistors in that, and supports HBM2 memory. And it also supports something called as a third generation tensor cores. I'm going to talk about it a little later, and support for sparsity at the hardware level, and an exciting feature called multi-instance GPUs, in addition to the big improvements in the way communication happens between GPUs to GPUs, what we call as a third generation NVLink. This is not the PCI Express based communication, because PCI Express is going to really shrink down the bandwidth of communication between GPUs, and that is not going to help when you want to scale your models across multiple GPUs, intra-node, which is inside one node, or inter-node between multiple nodes. So the way connectivity happens between GPUs has also improved tremendously. Intra-node, what we call as NVLink and NVSwitch, which gives unprecedented speeds all the way up to 600 Gbps. Just as a comparison, PCI Express gives you 18 to 20 Gbps. 600 Gbps bandwidth, and internode happens through the Mellanox interconnect. As you know, Mellanox is now an NVIDIA company, and that also has helped these models to scale across GPUs, intranode and internode. Now let's dive a little deeper into each of these features a bit. The first very exciting improvement in the Ampere architecture is what we call as the multi-instance GPU, which is MIG. So basically what you do is you take one GPU, which is a very, very powerful parallel processing engine. That's the key here. It's a parallel processing engine. The big difference, the topmost difference between the CPU and GPU is that a CPU computes serially, whereas the GPU computes in a parallel fashion. So those problems which are amenable for parallelization, which can be broken down into a very large number of small threads, and each of these threads can be run in parallel. Tens of thousands of such threads can be run in parallel, and at the end of the run, you can collate the results and look at it as a single result. That is what we call as parallelization. And these are very, very powerful, extraordinarily powerful computing engines. But then, have they been fully utilized? Maybe not, because depending upon the size of the problem that you're solving, depending upon whether you're doing training or inferencing, there could be headroom, a lot of headroom that is left behind the GPU, that being a very powerful engine. That is where this MIG comes into play, where one GPU can be partitioned into up to 7 instances. I mean, we call it as small instances. I mean, for practical purposes, you can imagine as a single, as mini GPUs. So one GPU can go up to 7 mini GPUs, and each of these instances can run independent software ecosystems. For example, the first one runs TensorRT, the second one runs TensorFlow, third one runs TensorFlow, fourth one runs Jupyter, the last one runs Amber, and so on and so forth. So in one processor, you can have 7 independent software ecosystems running simultaneously, and you can have 8 such processors in one machine, which means 8 times 7. 56 independent software environments, and hence 56 independent users can simultaneously work in one system. These are all big improvements that have happened in the recent past. And another important development that happened is what we call as TF32, thanks to the tensor cores that I briefly mentioned about earlier. So TF expands to TensorFloat, which is a new data format that we have introduced. And basically what it does is it combines the range of FP32, floating point 32, which is full precision, and the precision of FP16, which is half precision. So the best of both the worlds, the range of FP32 and the precision of FP16 are combined together to give you unprecedented improvements when it comes to training performance. And then very important feature that is introduced, this really took the semicon world by storm, is that sparsity acceleration is now a hardware feature. As we know, when you're working in deep learning, machine learning, etc., you deal with very large matrices, and most of these matrices tend to be sparse, being large matrices, and hence pulls down the solution cycle times. How do I solve this problem is what is addressed in the Ampere architecture, where sparsity as a feature is introduced at the hardware level, and just by switching on the sparsity flag, you'll be able to double the performance of solving problems. To summarize, whether you're working with computer vision or speech recognition or text-to-speech or recommendation systems or very large NLP problems, natural language processing problems, all the features that I talked about is going to help you to get up to 6x improvement in performance when compared not to the CPU ecosystem, but when compared to just the previous generation GPU ecosystem itself, which was what called as the Volta generation GPUs. And so where do we house these systems? So these processors, the GPUs, these processors obviously go into all the industry standard servers, like the ones which are provided with HP, Dell, Cisco, etc. Additionally, there are also AI supercomputing systems that house these processors. One such is what we call as the DGX A100. And this is a workhorse. This is a workhorse. And I'm not going to go deeper into any of the hardware aspects, but just the performance numbers. Let me pick up this 5 petaflops of AA performance, or 10 petaflops of int8 performance, which is typically used in inferencing workloads. So in order to get 5 petaflops of AA performance using traditional servers, traditional dual CPU servers, you need hundreds of them to be stacked, and clustered to get 5 petaflops of AA performance, peta floating point operations per second. That is now shrunk and provided to you on one system. Okay? That is what we call as accelerated computing. And when I say accelerated computing, I mean, let me try to quantify that a little bit. This is a practical example, one to which I myself got exposed. The defining data frames by one of the leading banks in India. What used to take, I think, about 7.5 days earlier, came down to about 2 hours, thanks to the application of these type of systems, and of course the software, which I'm going to talk about in a short while from now. So when I say accelerated computing, I don't mean how do I bring down 8 days to 4 days, or 8 days to 2 days, or 8 days to 1 day. That's not what I mean by accelerated computing. How do you bring down 8 days to a few hours? How do you bring down, let's say, 7 hours to a few minutes? That is what I mean by accelerated computing. And this is a need of the day. It is no longer a luxury, because as I mentioned earlier, AI is spreading so fast, and data, the amounts of data that we need to handle, and the complexity of the models that we need to handle, need such systems in order to practically deploy them in worldwide application and not restrict them to labs or academic institutions. And so the software ecosystem gets served to you in a GPU optimized format. We call it as NGC, NVIDIA GPU Cloud, ngc.nvidia.com, and a big list of software gets served to you, or which can run these on these systems in a very optimized way. Obviously, being very, very powerful systems, they need the support of very powerful software to run behind that, and that is what made available to you in the form of containerized environments from ngc.nvidia.com. Now, so much so on the hardware, I'm going to quickly switch over to a more interesting feature, more interesting chapter in my talk, which is the software. So all this is great. I mean, we know that deep learning is getting used everywhere, from internet and cloud to speech recognition, to language translation, medicine, biology, genomics, proteomics, media and entertainment, security and defense, safe cities, smart cities, and last but not the least, autonomous machines, self-driving cars, and robots, etc., etc. It is there everywhere. Fine. But then this is a very, very complex problem to solve. It is not an easy problem to solve, right? So there has to be a very robust and very refined software ecosystem that goes along with these GPUs, the parallel computing engines, to make it run the way it is supposed to run. And I hope it doesn't come as a surprise to many of you, but then I'm sure at least a few of you will be surprised to know that NVIDIA has more software engineers than hardware engineers, because what we provide is a very complex but a very advanced and refined software ecosystem that makes these processors run the way it is supposed to run and deliver applications which can easily be, number one, trained, and number two, deployed for these type of applications to run. So how does the data center platform look like from a software perspective, right? Let me start from the bottom of the chart. At the bottom of the chart, obviously you have the hardware. We talked a little bit about it, which are the GPUs, which are parallel computing engines. On top of that lies our parallel computing software framework, which is called as CUDA, C-U-D-A, which is Compute Unified Device Architecture. So CUDA is our software framework for parallelization, right? And everything we do, the software parallelization is built on top of CUDA. So on top of that, we have what we call as the CUDA X libraries. X can be machine learning, it could be for deep learning, it could be for high performance computing, it could be for virtualization, it could be for accelerating data sciences, right? So these are all libraries which are built on top of CUDA, very specialized libraries, and they have their own specialized areas of application which will get used by the application developers, by the data scientists, data engineers, and others. On top of that lies the blue color layer, which is the applications in the framework layer. These are all like very commonplace names today, the TensorFlows and PyTorch and MXNet and Onyx and CNTK of the world, which are very powerful frameworks, application frameworks that are built on top of the libraries that are provided by NVIDIA, right? And these frameworks are optimized to run on GPUs, optimized to run on CUDA, and all the features that I mentioned about earlier, like support for mixed precision training, TF32, make the multi-instance GPU, etc. They are all supported by these modern frameworks. On top of that lies the application area, which is where most of the work happens. I would say a big majority of the work happens in this area, the topmost layer, which is developing applications on top of the framework, which runs on top of CUDA-X libraries, which runs on top of the GPUs, which are parallel computing engines. And these software frameworks are so well defined and so refined and elegant today that application development is becoming easier and easier. So much so that our single focus is to ensure that the highly paid data engineers and data scientists don't spend their time on mundane tasks like building software environments, but they spend more time on defining their software applications which can be deployed for actual customer applications. And then comes a totally different ecosystem, which we call as the edge AI. After you have trained great models, could be deep learning, machine learning models in the data center, it doesn't have any sense until it is deployed, until it is deployed for inferencing in practical applications. And areas like security and surveillance, safety, smart cities, safe cities, retail applications, industrial AI, smart factories, healthcare, etc., etc. These all places where what we call as edge AI happens, where AI gets deployed at the edge on site. And once again, these need a lot of software ecosystem to go with that, right? And particularly with the advent of 5G plus AI plus cloud, right? 5G plus AI plus cloud. This is a killer combination. And this is going to change the way things are working in the near future, right? And so what are the areas where these software ecosystems thrive? So whatever you are seeing on the screen now, these are all specialized AI frameworks that are provided by NVIDIA, right? And these are end-to-end pipelines that address industry verticals, right? And these are all so elegantly built that any data scientist or a data engineer who works on top of these SDKs and libraries are served with customized vertical specific libraries and SDKs, so that it's quite easy, I would say, for them to deploy applications and frameworks that are specifically meant for their own applications. I'm going to call out some certain names here. And if any of you are working in any of these areas, please do go and try it out. The first is what we call as conversational AI. Conversational AI is a very, very difficult thing to achieve. When you say conversational AI, what I mean is it's contextualized conversational AI. It is not simply asking simple questions like, hey, what is the weather outside? What is the time now? Or what is the distance to the airport? No, that's not what is conversational AI. Conversational AI is contextualized, multimodal conversations where things could be like, hey, I could point my finger towards one particular object in a store and ask, what is the price of that item? So this involves computer vision, because the camera has to understand which object my finger is pointing towards, so that it can give me the price of that item. And then NLP, because the content of my question has to be understood, and of course speech has to be understood. So NLP plus speech plus computer vision. This is what is called as multimodal conversational AI. And this is a very complex thing to achieve. So we have a framework called Jarvis, which helps you to do that. And then comes recommendation systems, okay? The e-commerce websites that we all go to uses huge amounts of AI, huge amounts of deep learning in particular. And Merlin is a framework for recommendation systems. And then we have something called as Maxine for video conferencing, dealing with streaming data at smaller bandwidths, at very low fidelity images. How do I still give an experience which is as good as meeting people in person, which caters to multiple industries like healthcare, smart cities, autonomous vehicles. We have manufacturing, telco, 5G, etc., etc. And once again, industry vertical specific solutions are there. Clara, which is for healthcare. Metropolis is our software framework for smart city and retail. And NVIDIA Drive, which are autonomous vehicles framework. NVIDIA ISAC for manufacturing and smart factories. And NVIDIA Aerial for telco and 5G, right? So So the software ecosystem has grown in an unprecedented way. And there are industry vertical specific software SDKs and libraries and end-to-end pipelines that accelerate things like recommendation systems and conversational AI, etc. They are all available. And all these are provided as a collection on NGC. Once again, NGC, which is very, very important, NVIDIA GPU Cloud, which is ngc.nvidia.com. I would invite all of you to go to ngc.nvidia.com and enjoy the very powerful software frameworks that are provided there. You have pre-trained models, you have public data sets that are available, you have demo scripts that are available. All these will help to make your life easier when it comes to developing applications based on machine learning, deep learning, and data sciences. Last but not the least, we also have a collection of libraries called Rapids, which basically accelerates your end-to-end data sciences pipeline. Right? Defining data from ETL to defining data frames to running your machine learning or deep learning models to visualizing the results. It is all accelerated through Rapids. So the key here is that it is just not deep learning that gets accelerated through GPUs. It is the end-to-end data sciences pipeline from ETL to data frame definition to ML to DL to visualization. Everything is accelerated through the framework called Rapids. And now Spark, Apache Spark, I'm sure many of you are familiar with that and many of you might be working on that, is now GPU accelerated. So your Spark data frames are now GPU accelerated. And this is a very, very important development. So if you're using Spark 3.0 or have plans to migrate to Spark 3.0, please do go and check it out on ngc.nvidia.com and enjoy the benefits of accelerating on GPUs. Right? So to summarize, we talked about a lot of developments on the semicon industry. We started off with talking about the developments on the hardware front, and then quickly moved on to the software developments. We talked about how there are industry-specific applications and applications and frameworks that accelerate end-to-end pipelines like conversational AI, recommendation systems, video conferencing, etc. What it actually means to the end user, that's important, right? I mean, technology gets its meaning only when it means something to the end user. The meaning is this: the cost of computation has gone down drastically, right? I repeat, the cost of computation has gone down drastically. What used to take, let's say, 350 dual CPU servers, right? Solving problems, 350 dual CPU servers, right? Which costed $23 million, which occupied 22 racks and 300 kilowatts of power, can now be achieved at 1/7 of the cost. What used to be cost 23 million, the same performance is now available for 3.5 million. And obviously, less rack space and like 1/3 the power it consumes, right? So, thanks to the huge advancements in the semicon area, both in terms of the hardware and the wrapping software around it, and the software that envelops around these new parallel computing engines, the cost of computation has gone down drastically. And that is fueling the development of AI, machine learning, deep learning, because computation is becoming more and more affordable today in today's world. So more and more people are able to enjoy the benefits of this very advanced hardware, parallel computing hardware, and the software that goes with it. And more development happens, and more advancement, both in terms of research and practical deployment, happens in the exciting area of AI, machine learning, deep learning, and data sciences. That is the brief summary I wanted to give you, given the 25 minutes that I was given, and I'll be very happy to take questions if any.
Yeah, thanks, Mr. Ramlingam. We have, a question from the audience. Is there any opportunity for the IC programming houses or secure programming in the microcontroller and memory devices, as there is a need for a data security?
See, data security, the answer is yes. The firm answer is yes. Whatever we talk about, once again, these are all very powerful ones. They can handle everything so well. They can accelerate. They can give you better accuracies. All that is fine, provided it goes without saying whatever you're doing is secure. If the data is not secure, if your models are not secure, nobody is going to use that. So the firm answer to your question is yes. The underlying fabric that connects everything is security, and security, if you're working on security, you have enough and more need for whatever I talked about.
Thanks a lot for the nice insights from your end. And thank you for your valuable time, spent to address this keynote to the audience. Thanks a lot, Mr. Sundaramalingam.
Thank you, everyone. Have a good rest of the summit. Yeah.
Thank you. With this, we had since morning we had good, keynotes and nice panel discussions. We had. With this, we'll have a break and we'll come back with the product demos at 3 p.m. today. Thanks a lot.
Good afternoon. Welcome back to Iesa AI Summit. I'm Sridevi. I head a technology business incubator in Warangal, which is under the aegis of Department of Science and Technology, Government of India. We have 3 amazing startups lined up for you under Startup Showcase category today. The first one being AddAI. AddAI is an applied AI company pioneering in digital transformation for supply chain and logistic industries. AddAI delivers true problem-solving applied AI solutions from end-to-end, coupled with innovations in AI algorithms, sensors, and other cutting-edge technologies. We have amongst us Mr. Venkat Suresh Babu, who is VP Business Development at AddAI. Thank you, Mr. Suresh, for joining us today. Suresh, please take over.
Okay, thank you. Thank you, Sridhar. Good afternoon, everyone who is actually on this session today. As Sridhar introduced, actually, AddAI Labs is in a 2-year-old startup providing end-to-end solutions based on artificial intelligence with differentiated business models to enable the faster adoption of these technology, which everybody is talking about. In achieving this goal, we found several problems, and one of them is the cost-effective compute, as most of the offerings are pushing data to the cloud to perform the compute. As everyone understands, the cloud-based platforms brings latency and higher network costs, which are not suitable for industries where real-time decision-making is important. One other alternative most of the proponents give is where computing sensors, but which is limited due to the power constraints and form factors, etc., which are not suitable for broader future-proof solutions. And that's where I think, as everybody talking about the edge processing today, which is to meet these critical problems. And in this process, AddAI Labs actually come up with this edge computing platform called AddEdge, and with an elaborate software support to fasten the deployment. And this provides all these critical benefits that, such as the expandable compute, where we can add the compute as needed, and low latency in decision making, and lower network costs, and as well as the operational cost. So the following, I will be playing in a video now, which will going to give you the details about the complete AddEdge platform.
AddEdge is an AddEdge is an innovative edge computing platform built to realize the potential of real-time business solutions using AI. AddAI is an applied AI company providing real-time business solutions by integrating technology, platform, and digitalization. We took a data center scale-out architecture and squeezed it into mobile GPUs, modified open source for cluster AI processing, and turned it into a lightweight AI supercomputer. AddAI's blueprint enables customers to train models within their firewalls and deploy securely at the edge. Appliance eliminates the expense and logistic constraints for transporting voluminous data files to the cloud. Data producers are in the form of images, videos, and audio. Benefits of parallel inference include power consumption of less than 100 watts, speed, 75 times faster multi-stage networks, accuracy, high volumes of large images trimmed into smaller clips, pipeline, fine-grained small subnets are easier to train and update than giant clumsy models. AtEdge 1.0 comprises of an Intel i3 CPU with 6 NVIDIA GPUs. It also has PCIe and Ethernet connectivity with a high-performance orchestration software that has a power consumption of 170 watts. AtEdge 2.0 consists of 6 NVIDIA GPUs coupled with PCIe and Ethernet connectivity that consumes power of 100 watts. Our Cube device has 4 NVIDIA GPUs with a wireless mesh connectivity operating at 45 watts of power. AtEdge's 1.0 architecture is built with a combination of a motherboard and a carrier board. 6x TX2 carrier board for AtEdge includes TX2 module slots, IDT PCIe switch, micro USB, and an Ethernet switch that are combinedly used to connect and access each Tegra TX2. AtEdge's 2.0's architecture is slightly modified to replace the motherboard with a host. AtEdge comes along with an open software architecture supporting all the popular software frameworks at application level to deploy any deep learning or OpenCV workload with a single click. A web-based interface for easy configuration and monitoring of the AI workloads continuously from anywhere. This interface gives flexibility to view the assets in physical view, that is, based on location of sensors, computing, etc. Logical view provides the binding of the sensors and compute and helps user to understand the load on each AtEdge. Entire chain of sensors to the compute can be traced and view the entire chain from data flow perspective. Deploying and scheduling of the AI applications can be performed. Performance monitoring, uptimes, memory utilization, CPU utilization at edge level, and to the finest level granularity like each GPU instance can be monitored. Workload can be balanced automatically through the orchestration layer or manually based on the choice. A proprietary orchestration layer at cluster is built on top of AtEdge's hardware platform that brings all the standard operating system tools to execute efficiently on the hardware. AtEdge's unique value proposition moves interface to the location to deal with high volume and velocity of unstructured data, brings parallel architecture to the edge for high performance compute, brings a low power and low footprint hardware which enables easy deployment, eliminating need for specialized power, space, or cooling, scalable from small to large production deployments.
I think as you have seen the video where we have completely described the edge platform, which is an edge computing platform which is built ground up by the Iesa Ai Labs. And this actually brings the compute and a software architecture amenable for end-to-end AI pipeline deployment. And this is the core building block of our Iesa Ai solution offering today. And one of the focus vertical for providing the solutions for Iesa Ai is the supply chain and logistics industry. And this industry is very cost sensitive, and decision making needs to happen in the real time. And for an end-to-end optimization, a multi-site information is required. So we at a solution, has brought up a solution called ETCO for the supply chain and logistics industry to bring digitalization, enhancement of operational efficiency through AI, and continuous visibility to all the stakeholders. And Edge powered the solution along with IoT sensors to bring critical benefits required for this industry and solving some of the key pain points. So we can demonstrate this ETCO solution in this video.
Ports are a key participant in keeping the supply chain ecosystem flowing, and ATCO has developed an AI-powered system to keep the operational wheel running. During gate-in, our system meticulously captures vehicle license plate, hazard category, container number and ISO code, seal detection and count, and overall container health survey. Our ATEDGE system infers all the container data captured by vision sensors to provide real-time insight for decision making. Our system ensures seamless integration of gate system with other TOS for complete command and control center for gate operations. Upon entry into the yard, ATCO uses available container data to calculate an optimized yard location for each container. The CHEs are assigned in real time in order to place the containers in the allocated positions. The goal is to use space efficiently, keep retrieval distances short so that containers are easily available for further transport, reduce the number of rehandlers, and reduce fuel consumption considerably. Special requirements for hazardous cargo and reefers are automatically taken into account. Immediate alert notifications are generated in case of any discrepancies. ATCO's edge and location sensors help ATEDGE to process the data to determine the exact location and the container-related information that provides real-time visibility of container motion, thus reducing the average number of unproductive moves by 40%. Our yard management system enables real-time optimization, resulting in efficient utilization of terminal space even at peak periods. This also results in reduced energy consumption and carbon footprint in the order of 8 metric tons for a medium-sized container terminal each day. Rake is a common ingress and egress method for containers. Our inferencing system ensures seamless loading and unloading of containers from the rake by assigning jobs dynamically to the container handling equipment on duty. ATCO's system captures wagon number, container numbers of all the containers on wagon, wagon number to container number mapping, and trailer ID. ATEDGE infers all the container and wagon data captured by our sensors to provide real-time insights and analytics for instant decision making. Each equipment receives an optimized sequence of job orders for smooth functioning. This reduces travel distances and improves on-schedule performance. ATCO's survey app assists in recording seal count, seal intactness, and seal number. Our system enables warehouses have high volumes of goods coming in and going out round the clock. Efficient utilization and management of warehouse space is crucial for operational continuity. Our system effortlessly captures cargo loading and unloading count and monitors damaged cargo, ensuring seamless mapping to container for export and import. ATCO's system calculates and captures the time at which any package was stored in the warehouse. Additionally, it provides real-time data of cargo actual positions, volumes, and efficient space utilization for better inventory and possible bottlenecks identification. Our warehousing solution for a rack-mounted warehouse provides efficient management of stock, leakage detection, dwell-time curtailment for smooth flow of stock. Our computer vision-based AI technology ensures end-to-end operational efficiency and greater accuracy across the value chain the AI way. ATCO, powered by ATEDGE through real-time AI, enhances supply chain and logistics industry.
Hello. So these are the two products that we would like to demonstrate as of today. The ATEDGE, which is the edge compute platform, and another solution, the ATCO, which is powered by ATEDGE for some of the supply chain and logistics industries.
Thank you, Suresh Garu. This was really nice. Thank you so much. This was really nice. And thank you for your time.
Thank you, Sridhari.
Have a lovely day. So the next company today is Manjeera Digital Systems. Manjeera is a DSP R&D house designing next generation computing architectures for high performance computing. They address the bottlenecks of existing processor, co-processor, accelerator architectures. We have amongst us the founder himself, Mr. Venu Kadandai. Venu, thank you for joining us today.
Thank you.
Are you there?
Yeah, can you see me?
Yes, now I can see you. Thank you for joining us today. Now the stage is all yours.
Thank you. I would like to share a presentation that I have. I will briefly introduce our products. Then we'll follow that up with a demo, which one of my colleagues will run the demo. So I would like to share my screen. By the way, Aditya, are you there? Are you able to log in? So will you also join the thing? Yes.
I'm not able to see any Mr. Aditya here.
Aditya Romala. Just give me a minute, I'll check with him. He's not here, we are working from home.
Yeah, now I can see. Welcome, Mr. Aditya.
Thank you.
Oh, okay, you're there, right, thank you. So let me, I'm sharing my screen. Can you see a presentation?
Yes, yes.
Okay, right. First of all, thanks to IESA for giving me an opportunity to present our products here. We are Manjira Digital Systems, high performance compute IP company. I'll briefly tell you about the IP that we have. This is what is called a universal multifunction accelerator based on a new computing methodology and architecture. This is a patented technology. And using this, we can accelerate algorithms or a range of applications, like starting from signal processing to artificial intelligence, computer vision, multimedia, you name it, any of these algorithms can be accelerated with this. So we already validated this both in silicon and on FPGA, and this technology is also customer validated. So we have some customers using this technology for a variety of applications. We have fabricated a chip at a 28 nanometer node. This is the baseband processor using EMA, and we are building NAVIC receivers, that is GNSS, Indian GNSS receivers using this baseband chip. And this baseband chip is a generic baseband chip, and it can be used for other communication applications as well. Our focus these days is mostly on AI. We have built an AI inference engine to start with on FPGAs. We partner with Intel in building accelerators for data centers using their FPGAs. This accelerator provides very high performance, market-leading performance, beating the top GPUs by an order of magnitude. And most importantly, these are programmable in the sense just by changing the software, you can use it applications in either image analytics or natural language processing, or even time series analysis that you often encounter in the BFSI sector. What we offer is an IP for either ASIC or FPGA. We also offer solutions on FPGA, and moving forward, we plan to do silicon on this. This is briefly about our technology. And as far as the AI accelerator that we do, that we provide concerned, these are the details here. Your accelerator, the EMI-based accelerator, is in the hardware. It could be FPGA or ASIC. And on top of it, we have built all the relevant software to make it easy for the customers to use this accelerator. Most importantly, the customer can use a pre-trained model in any of these platforms like TensorFlow or PyTorch, Keras, ONNX, any of those platforms. And then the input data could be images, speech, or any time series data. Now, user can build applications using high-level languages such as Python, Go, or C++, and we provide APIs for each of the languages that the user is interested in, which will allow user to convert the model trained in any of these platforms to a model that runs on our accelerator. We call it EMA model. So we provide a model converter API, and we provide inference API and so on. On the hardware, in addition to our accelerator, you have software layers like a library of EMA primitives, which essentially use EMA instructions, and there are basic functions that you encounter in all these AI algorithms we are talking about, and also a model execution layer which understands the converted EMA model and hence and appropriately uses the primitives to run the accelerator. So that way, this is a completely software convertible, software programmable model. You don't need to change the accelerator, whether it is in FPGA or in ASIC. You can accelerate almost any AI topology using this. And the user need not know anything about the hardware, EMA instructions, or how to program EMA and so on, because we provide software, high-level language callable APIs. And we are going to show a demo. The demo arrangement that Aditya is going to show now consists of a Dell rack server on which you have some Intel software, and then TensorFlow. Right now we are using TensorFlow platform, and Python, in which the application is built. In addition, we also have our model converter code, and then other APIs and an example application. In this, through the PCI slot, we connect Intel FPGA, Stratix 10 GX 2800, which is a programmable accelerator card. And on this FPGA, we have built the bit file of our AI accelerator, and we dump that bit file on the FPGA, and then the EMA primitives library and EMA model execution layer. These are all downloaded onto the FPGA card. And then the typical application flow looks like this. You first load the bit file onto the FPGA. If it is ASIC, of course, there is no such step. And then convert the selected model using model converter API, whatever AI model or AI topology that you want to accelerate. And then load the converted model onto the accelerator using model load API, and then use the inference API to start running the inference using by loading the data and performing the inference on the accelerator. And you get the very high performance in terms of extreme low latencies and very high throughputs this way. And if you have more data, you go back and call the, for example, in the case of the streaming application, as the data is coming, you can keep calling the inference API as the data is coming again and again. And of course, if you want to load a new model, all you need to do is go back, check the pre-trained model and use model converter API to convert into EMA model and dump it on the accelerator. So this is as simple. You don't need to change the hardware, and you can accelerate a range of AI algorithms using this accelerator without having to do anything to the hardware, and getting extreme high performance for all the algorithms you want to accelerate. So we will show a few demos. One of them is a speech transcription demo. This is a Mozilla DSpeech. It's a very huge model. It has 6 layers, including a bi-LSTM layer. The model size is about 235 MB. And Aditya, can you take over and run the demo?
Yes.
You need to share your screen.
Yeah.
So Aditya is running this demo. on a server, which is in our office here. And of course, Aditya is not in Hyderabad. He is in Vizag, but from there he is logging and running this. So we have a nice GUI for this model for running the speech transcription demo. He is trying to launch the GUI. Okay. So the GUI has features wherein you can provide, at this moment, we provide the stored speech file. And then he will also play audio to parallelly.
If I had never dropped out, I would have never dropped in on that calligraphy class, and personal computers might not have the wonderful typography that they do. Of course, it was impossible to connect the dots looking forward when I was in college, but it was very, very clear looking backwards 10 years later. Again, you can't connect the dots looking forward. You can only connect them looking backwards. So you have to trust that the dots will somehow connect in your future. You have to trust in something, your gut, destiny, life, karma, whatever. Because believing that the dots will connect down the road will give you the confidence to follow your heart, even when it leads you off the well-worn path. And that will make all the difference.
The speech is run asynchronously, so you may not see much of a synchronization there. Just for your understanding how the file is, the speech is run, the audio is run. But what you see here is in the table, you have the algorithm automatically segments the speech into convenient parts and gives it to the accelerator. This inference API keeps taking these chunks and keeps giving it to the accelerator. So you take different lengths of the speech depending on where the gap is in the speech, and something like 1549 milliseconds length speech is transcribed in 256 milliseconds. So this is real-time performance. And if you compare with some of the top GPUs in the market, you see that it is up to 5x faster than this in this particular algorithm. You can see that 1 second stream somewhere down 952 milliseconds stream is transcribed in approximately 161 milliseconds. So this is real-time transcription of the speech. So Aditya, can we run other algorithms?
Yes.
So what Aditya will do now is put the GUI, and on the same hardware, the bit file of our AI accelerator is already on the arbitrary FPGA. Now he is going to run multiple algorithms. We have seen Mozilla Deep Speech running. Now to tell you how exactly you can use these APIs, how simple it is, we'll show that we are running several other algorithms having different types of layers in it. So Aditya, can you run any one of them? Something which has something like LSTM layer? Yeah. Okay, so the model converter, you can see here that identified that it has 2 LSTM layers and a fully connected layer, and it has only one time step in this. Then the model conversion is what he has done now. Then can you run the inference? He provides some data which is already stored. You see that it took 141 microseconds for this model to transcribe. That means in a streaming mode, it can do more than 7,000 such streams per second. Then you can even increase, run different batch sizes. Can you make batch size something like, yeah, whatever you choose? Okay, a batch size of 6. Now 6 at a time are running in parallel. So your throughput has gone to 20,000 streams per second. This is extreme high performance, and this sort of models are used for time series analysis for applications such as fraud detection and so on. Can you run one more model which has some time steps as well?
Yes.
I think model 0 or something like that. Okay, so the model conversion is done. This has 24 layers, 2 GRU layers, and remaining, sorry, it has 14 layers, 2 GRU layers, and 12 FC layers, and 25 time steps. Now, can you run inference in this on this? You just call the inference API, provide that where the input data is, and then this is accelerated. You can see that it took for all the 25 time steps and 14 layers and 25 time steps, it took 3.5 seconds to run this. Sorry, 3.5 milliseconds, and hence you have 279 streams per second is what you can do. Of course, you can run this in batch mode as well. So this way you can run any model. You just pick it and do the model conversion and run it on the accelerator. It is as simple as this, and building any type of an application is very straightforward and easy. So that's what we have today to demo in the given time slot. Thank you, everyone. Thanks, Aditya.
Yes.
So I can answer if there are any questions.
Thank you, sir. Thank you so much. We don't have any questions and answers in this session. So, but we'll get back to you if we receive any questions. Thank you so much.
Thanks to Iesa once again for giving me this opportunity.
Thank you. The next startup today in the startup showcase is Alpha IC. Alpha IC is a fabless semiconductor company which designs and develops the best-in-class artificial intelligence co-processors for delivering high-performance AI compute on edge devices. Alpha IC's edge solutions include Inference Alpha IC's profile. We have amongst us the Chief Scientist, Senior Director of AI, Mr. Suraj. Thank you, Mr. Suraj, for taking out time to be with us today. So the session is all yours. The floor is all yours.
Thank you, Surya, for all your kind words and appreciation. This is Suraj. I have my MD India, Sanjay Balsamudram, and colleague Prithvi also with us. So the plan is to have, we have started off with our technology demonstration, and we can take up the questions later. I would like to share the presentation. Are you able to hear me?
Yes, we are able to hear you. Welcome, Mr. Sanjay.
Thank you. It's my pleasure.
Okay, so the agenda here is we'll actually go through the product roadmap, software stack, performance numbers, what market verticals, what we are looking in, and we also follow up with demo for edge inference. Some of them are from deep learning, some of them are from reinforcement learning. We'll also demonstrate how learning can be performed on our edge device, and which is something which we feel it is quite unique. We would like to take up the questions after that. So with respect to the roadmap, Alpha IC is actually looking into edge market. We are designing top-end AI accelerator for especially for edge market with respect to the vision as well as sometimes the text as well. So we are operating into the 5 to 30 watts segment. Currently we are planning for 8 TOPS tera operations compute capability, which can be extended till 64 teraops. We have the capability for inference and learning on the edge, which is useful for to tackle some of the privacy concerns which our earlier speakers were talking about. We have already taped out an 8 TOPS inference accelerator, which is called Gluon. We also have an inference and learning processor in the pipeline for 2022. And we also would like to add up a bit more compute capability in 2023 with additional 32 more TOPS. So we feel that within this compute capability, we could able to tackle most of those computer vision problems and the classical AI applications, and we can accelerate using our edge device. With respect to the proposition, what we have an in-house Gluon chip, except the PCA and the LPDDR, everything is in-house. You name it, from starting from the application, followed by the software stack, the hardware IP, everything is in-house. And we are looking at the 16 nanometer FinFET TSMC processor node, 8 TOPS performance numbers we are expecting. On-chip memory is 22 MB, and we have a ResNet 50 performance estimated is 315 images per second, a power consumption 4 watt, and already been taped out. With respect to the software stack, currently we support TensorFlow, and also we have option to convert other framework model to TensorFlow and take it as an input. We have a one-click solution in place to convert most of the deep reinforcement learning problem or even deep learning problem back to the model whatever we want. We go for a graph-based optimization using graph compiler done in-house. We also have a high-performance API library suited for most of those matrix operations and tensor operations. We also have a good runtime engine which converts, which translates the binary generated to the board and seamlessly communicated to the binary back and forth from the host so that we can effortlessly execute most of those models in the vision side. So with respect to the stack, we have gone with a modular approach where we go with a conventional neural network acceleration with the help of a graph-based compiler. With respect to the performance, we have the numbers estimated. For ResNet, we feel that the numbers what we are seeing is close to 79 frames per second per watt is actually very, very competitive compared to the numbers which we can see in the public domain from our competitors. And also for YOLO V2, we have the numbers close to 13 frames per second per watt. 4 images which are 416 by 416 by 3, which is the standard input image size for the benchmark, YOLO V2 benchmark. By the way, we can see that FPS is a good number. FPS per part is another parameter. Naturally, we could able to get these numbers with accuracy close to the float numbers. So in that sense, this is a good alternative for any of those top-end edge accelerator. We can always extend this to another network or any other similar network. We have the numbers as well. We will be publishing that in our website soon. We are also looking to extend it to some other adjoint market, but definitely the prime focus is on the surveillance, vision-based surveillance systems where I can have a image-based object detection, classification, or segmentation as a primary problem. And also we can have some kind of a resolution conversion problem where we can extend the resolution of certain images. We also have solutions in the automotive space, especially for object detection. And We also extended it to some kind of a driver monitoring system application, and also the in-house internal an infotainment system where I can use the speech as an input and probably convert it into text and further downstream processing. So the particular hardware and its power range along with the TOPS is well suited for IoT based applications and smart homes, etc. And with additional learning capability which we have built in, I believe some of the privacy constraints as well as data bandwidth related issues also been sorted out by extending some of the learning capabilities onto the chip. Now, we would like to demonstrate the performance of the system. We have shown it in multiple platforms, and one thing what we have done is put the solution on the FPGA and also some of the boards, and we would like to showcase some of those classic networks running on our FPGA board. What we have selected is the classic classification network called ResNet 50. We have put it on the FPGA board. And we also have put a face identification, which is an embedding platform, followed by a classification as a proof of concept early, and we have extended it to other network as well. We also did initial benchmarking for YOLO V2, FuseDead, Pili. These are the object detection network, and Pili is close to 170 layers. We have implemented a low precision compute inference on this chip and showcased that we could able to do a low precision inference on our platform using pure in-tape compute. And of course, it is supported by the instruction set, which is catering the heavy compute based on tensors. And with the additional stack on top, we could able to showcase fairly good amount of acceleration. And we will be showcasing it in the video. On top of it, we have done something called the deep reinforcement learning network, which I think can be extended to any of the control applications where discrete action is required. And this can be directly mapped to any of the robotic arm movement, some of the gaming. We have demonstrated for gaming though, but I can directly stretch it to any of the robotic arm control, and I will demonstrate that as well. So I would like to cover the demo first. So what you are seeing here is a ResNet demo working on the RAP, which what we call is the FPGA running at 100 megahertz, and also which is translated to 0.2 teraops. As you can see, the ResNet is taking close to 22 milliseconds on the FPGA, just running at 100 megahertz, close to 45 frames per second by just running on the FPGA. We can expect it to be accelerated close to 8 to 9 times when the actual ASIC comes. So this is the snapshot of ResNet running on our FPGA. And I will directly go to the YOLO version.
Suraj, we couldn't see the demo. The video is not showing.
Okay, sure. Sanjay, can you see my screen now?
Yes, we can see now.
Sorry for the mistake. Yeah, so as you can see, the ResNet V1, which is running on our FPGA board, running at 100 megahertz, taking close to 25 milliseconds on the FPGA, which is just 100 megahertz, 0.2 TOPS machine. So we expect it to be accelerated 8 to 9 times when the ASIC comes. And also the performance is in line with what we are getting in float model. We have not done any kind of model optimization. This is the number as it is without changing, without any of the network structure, neither we prune the network. So this clearly showcases that we are able to get bit exact implementation with respect to our reference 8-bit model on the FPGA board, using the IP what we have, using the stack, completely accelerating the neural network. So another example which I mentioned is YOLO V2, which is close to 35 tera operations in compute. You can see the bounding box appearing, pure integrated version. We didn't go for any further fine tuning. We didn't change the structure of the network. That is an additional capability we have, but we would like to showcase as it is. As you can see, it takes close to 62 millisecond, which is close to 16 frames per second. That itself is okay for a single stream real-time operations. We are able to get it even in a using FPGA. Yeah. So going back to the next demo, we thought we can showcase another very, very deep network, which is called Pili, which is suited to, actually it is coming from a customer requirement. And we could able to showcase Pili, which is 170 layer network, purely on Intake, but in a different mode. And we are showcasing a different approach here where we can actually broadcast the binary to the board and get the results. So if in case you have a network which is quite deep and the code takes is high, the code size is high, I have an option to support that as well. Yeah. So performance, we have not tuned any performance to suit our architecture, which is definitely an approach we will be doing in the next stage to suit the customer requirement. This is the bare network without compression, without pruning, without any kind of model optimization. So this showcase that we can do the intake computation without capability of the software stack and the instruction set. Another one which would like to demonstrate is the phase mask detection. The problem here is to detect phase with and without mask. We demonstrated in our FPGA platform running at again 100 megahertz. We can see close to 50 frames per second even in FPGA. And I would say this is itself can be used for any low infrastructure space where we probably extend our FPGA to see whether a person is wearing a mask or not. You can clearly see that it can detect multiple phases, and we are using pure intake solution, and also using a one-click solution to convert the model to the binary what we have to be deployed. So I would also like to showcase another very important application. This is the phase identification. We are using the phase net as the base network, and that's classified at the end. A clear case where we can detect it correctly using intake, and I think it's also fairly important for any kind of surveillance application where we would like to showcase or restrict the entry to the person which authorized by the company or the security staff. So these are the networks what we have done so far, and we have fairly other amount network also done. But I would like to showcase another network which is purely reinforcement learning network. I think this is something I don't see anybody else has done it. We have done pure intake inference of RL network. So this is an Atari environment where the system is playing Atari game. As you can see, the agent moves left and right to make sure that the ball doesn't go down, and at the same time has to score as many points as possible. So the action here is to move left and right. This is very much useful for any of the classical control application or a robotic arm application where the robot has to move by avoiding the obstacle, etc. So we have definitely made use of our expertise in the RL space to have a quantized implementation of the RL. You can see that the score goes up, and we could almost able to break it out. So this clearly shows that our processor can do RL inference as well, which is a must for some of those automotive, even not just automotive, but also for control and robotic applications. So I have another demo which which shows that we can also extend it to this to another network, which is called SkewsDet. We wanted to showcase this because this is something which we have done years earlier. I would say this is one of the early entrants to INT8 for object detection. You may see it a bit delayed there. This is called SkewsDet, INT8 implementation running on 100 megahertz FPGA board for Kitty dataset. So, Sanjay, were you able to see that?
Yes.
Okay. So basically, we could able to showcase a particular network which is for RL, for as well as for classification, as well as for detection, using the same stack for the full in-house technology, using the same ISA. We can cater it to RL, classification, detection for deep learning, or anything which requires a matrix compute. So also we would like to showcase another technology which I believe is a differentiator for us, and we call it as learning with limited data on I would say edge learning. As you are aware that privacy is a major concern for most of those, I would say most of the Western market, and there is a need for us to preserve the privacy. Instead of that, we came up with an alternative solution that can we extend the learning capability of privacy to a situation where probably a speech recognition system designed for a particular US accent, and I wanted to actually optimize for my accent or my Indian accent. Can we do it without actually sending my private information in terms of voice or image back to the server? Yes, we can do. We can extend it. And we have demonstrated learning capability on the edge by definitely making use of additional instruction set and stack additional precision, etc. And we have demonstrated to one of our top-end defense research organization so that we can extend classification and detection of certain unseen images and unseen objects on the board. What I meant is that we can deploy a solution in any of the premises, and over a time I can update it, which is something which was unheard earlier and which is definitely a niche area, and we are leveraging that at the moment because the hardware support is allowing us to update the network parameters and the network itself on the fly, which is a mix of learning as well as inference, and that solves some of those problems I think raised by our early speakers. Is cloud is merging with edge, or edge is going to cloud, and this is one of the solutions we would like to showcase. And as this is an output which you could see from our FPGA board, I would show the demo as well. This we deployed for detection solution. As you can see, a cat and a cycle.
1 more minute to go.
Sure, a cat and cycle was not trained. We could able to showcase impact on the board after deploying. And we would like to showcase the demo as well.
Suraj, we have only 1 minute to go.
Yeah, so I'm done with that. Probably I would like to take the question.
You can show your next demo.
Okay, sure. Yeah, so this is edge learning demo. What we can see is the classification network trying to classify something which I've never seen after deploying. So you see it, the green color indicates that it could able to actually classify. So the technology is allowing a combination of inference and learning on the chip, which is definitely required for, say, image-based authentication system, where I wanted to add a attendance to a new person after deploying it, and we don't want to send the image of that person to the cloud. You see, the cat was detected after deploying, and there is no idea, even for bus, there's no idea about this, whether the bus was even trained. So we could able to showcase the demo of object detection after deploying that particular solution on the edge. So this is definitely useful for any privacy concern or any system which there is a privacy concern or a bandwidth limitation. So we could able to demonstrate our technology for inference and learning, and we would like to take up some of those problems in this area, and we'll be happy to help you out in accelerating such problems in our platform. Thank you.
Thank you, Suraj. Thank you, Mr. Sanjay. It was a wonderful demo.
Thank you very much for giving us the opportunity. So,
So it was a wonderful demo. Wish you a very good day and best wishes.
Thank you very much. Bye-bye.
That's all for Startup Showcase. Now I would request the next session host, Mr. Gangadhar Gude, to take over. Thank you.
Hello. Good afternoon, everyone. I would like to invite our next speaker, Mr. Rajesh Wasa, Professor Rajesh Wasa. Professor Rajesh Wasa is an innovator and an entrepreneur with over 2 decades of experience spanning both industry and academia with a specialization in AI and complex software systems design. He leads the transitional research at the Applied AI Institute of Deakin University. His recent current work spans multiple areas: building intelligent homes, assessing clinical risk from medical data streams, improving patient care in hospitals, analysis of data from complex simulations, conversational agents to work in educational settings, and analyzing data streams to improve productivity in various settings. His core research is in constructing robust AI. He's going to be talking to us about how to leverage AI and the opportunities and the challenges. Welcome, Professor Rajesh Wasa.
Thank you. So I'll start right off. Hopefully you all can see the screen and it's all clear. So I've titled this as a conversation in AI. I didn't know the background of the audience, so I'm going to take it from the assumption that we have to just set some stage. So this, just looking at the talk so far, I think this part is very clear. Everyone knows that this whole space is exploding. A lot of people are saying we do AI, but interestingly, this is the current story of the day, in that we know that AI is good when you have good data, and the domain doesn't change too much. Some quick examples. So that woman's face is completely generated. We've got medical applications saying that they can do amazing things. The interesting thing is most of the best AI is completely hidden. So Google uses quite a lot of AI, and it's not quite clear to people that this is the most stable form of AI per se. So map search and Google search itself uses a lot of context-aware information retrieval related work behind the scenes. The most common question I get asked is, will AI take my job? So I set this in there just primarily to just set the stage, saying that AI will not take the job. And this is just a screenshot of, this is a picture of what the people in a ship do and what they used to do a few hundred years ago. And what's happened is that the person who's looking out has changed. They just use more sophisticated tooling, but as such, AI is unlikely to take a specific job, but it will certainly transform jobs. There's a number of different definitions of AI. I'll go through this fairly quickly just to set the stage more than anything else. So there is a school of thought that says AI is about an appearance of intelligence. There's another school of thought that says that AI is something that only till recently humans could do and machines couldn't do. This definition also means that once a machine can do something, we'll no longer call it AI, of course. And of course, this is the textbook definition of AI, which says that it's got something to do with reasoning, learning, and problem solving. Ironically, machines cannot do reasoning very well. They certainly can't do any sophisticated problem solving. Then they can barely learn. And that's the focus that I'll take for my talk, is to show how difficult it is with machines when they do learn and where some of the research challenges are. So this is a quick example of the key things that AI can do. One is it can predict, it can classify, it can learn behavior, sort of. We can do certainly searching, we can optimize, and we can act using some rules. Almost all of these things, all 5 of these abilities are in a self-driving car. So a vision system will classify some objects. There's a learn prediction system. There's a behavior learning module. There's some form of optimization happening behind the scenes. There's searching, and then there's rule-based systems that say you can drive at a certain speed. Because the rules obviously are made by humans, and it's sometimes easier to just set the rule rather than get the machine to learn it. So this is just to purely set the stage. So what is the big deal with AI, and where is the big mess? So if you took the classical description of what machine learning is, what AI is, there's this big diagram here where I've just got the learning component, and once some learning has happened, I can use the input, model, and output. This part is how I would normally use it. Now, almost all of the research that people are hearing about, it focuses on the machine learning algorithm, and they say, oh, look, we've improved this algorithm by 5%, 10%, 12%, 2%, and so on and so forth. Ironically, that's not where the difficulties are right now. So where we are focused on these days is, what did the machine actually learn? Because we're never sure 100% of the time what it learned. What data did it use to learn? Again, not quite sure about that either. We don't know if the prediction is useful. We don't know if we made the right assumptions. So these are the 4 big challenges. Broadly speaking, we would call it the misspecification problem, but without going into the academic lingo of why these things are challenging, in effect, everything but the machine learning algorithm is where all the problems are, on whether we can actually take advantage of AI effectively in practice or not. So what I'll do is I'll shift to give you some examples. Say if I showed you the data stream like this is the dam level, water level in Melbourne Dam, where we get the fresh water. Melbourne is where I'm based currently. And if I said, okay, just tell me whether this month I'll have enough water based on this, can a machine learn something? The machine certainly can learn. The thing is, if all it has is historical data, the range in which it'll make the prediction is going to be very broad, because the minimum was around 30–40% in August, and the maximum was about 80%. So the entire range is what it'll learn from. I can't get hundreds of years of data because this data only existed for about 20 years. And the sensors that were collecting this data were recalibrated 5–6 years ago. So they're certainly measuring differently. They've added more dams, therefore the percentages changed. Almost all of that knowledge doesn't exist inside any AI model. The other thing is, the ML doesn't know what it's looking at. It doesn't even know this is called the thing that this fluctuates based on rainfall data. All it knows is this moves up and down across some seasonality. But the reason why this moves up or down is not something that the machine will know about. And that's something we have to provide. And the number of things we have to provide like that is quite large. So if I asked a simple question right now to any weather forecasting algorithm, will it rain in the next 3 hours? It can say one of those 3, but it doesn't know why I asked that question. Why does that matter? Because I might want to paint a fence. And if I'm painting a fence, I don't want any rain. But if I'm taking the dog out for a walk, or I just want to go for a walk, or I want to water the garden, those answers might change how I decide to do something. And this is the kind of matrix internally that it will give you, which is quite sophisticated. And so it's not a single value that it makes a decision from. It's actually a more sophisticated distribution. What currently is happening in most AI systems is they're flattening it, averaging it, and picking a single point value, rather than entire distribution and entire decision frame that we need to do anything really sophisticated. So when humans make decisions, they need the entire decision frame and appropriate training to understand what it means. So from now on, I'll effectively switch the talk to talk about that particular aspect of it and why this is a specific challenge and where we need to start looking at it. So AI systems are designed to serve humans. And the first question is, let's say I made a machine and I say it can do something, but the human cannot do it. We don't know whether it actually works. For us to know something works, we have to be at least be able to do it. We may be able to do it slowly, and the machine can do it fast. But even if it does do it, the way we define it works depends on political, economic, as well as the engineering and technological limits, not purely an engineering problem, in other words. Right now, we don't have a clear definition of it works. So which means if you can't define it's working within a certain boundary, we don't know when to fix it. We don't know what the quality attributes of it is working are, because we really quite don't know how the machine is learning and what it is learning with any level of precision that matters. And the way we evaluate, mostly it's happening in development or in research, but in production, the metrics are different. And there is an entirely political dimension and there's a business dimension that immediately enters there. And we don't know any of those things. So it's a lot of the work that we see right now, I would say, is very advanced research, early translation, but some of the more pertinent aspects of AI, which is how do we know it's actually working in a way that is acceptable, is yet to be figured out. So as an example of what an AI system would show you, this was from a few years ago, but it's still more or less relevant because what's happened in the last 2 years is those percentages increased a little bit. Now in this diagram, there's an elephant, which is classified as a chair, top left-hand corner. And the reason why that happens, it still happens, is because the machine has never seen in all of its data an elephant in a room. Therefore, it never expects one. And it's a context problem because machines are learning in context. The other thing that also happens is if I had to make a decision about books, at what percentage is a book a book? 50% a book, 20% a book, 30% a book? And those percentages are very dependent on the data that was used to train it. So if I had to do something related to books in this photograph, I would have a lot of difficulty in being confident because the confidence value also depends on the underlying data stream. And most AI developers don't specifically know what data was used to train their data sets. And I'll get to that next. The other thing is, say if I showed you a piece of text like this that a machine wrote, and if I said, is this good to put in an article? Strictly speaking, the grammar is correct. Vocabulary is correct. There are no spelling mistakes. But both those paragraphs are utter nonsense, though, strictly speaking, semantically accurate, but meaningless. So each sentence is grammatically correct. It just doesn't have any meaning. If the intention is to do some comedy, this would be perfect. But that's generally not the intent. We want to write articles with it. And this is from last year. This year, it's slightly better, but not that much better that I can definitely say that this is ready to go. It works, it's perfect. So there's a lot of sophisticated work still yet to happen. And the reason why that happens is this is the kind of training data set that is currently used to train data. These are not things I'm making up. These are labels that are actually being labeled, often in low-cost countries. So India, Vietnam, South Africa, somebody sent all these photos and they'll say, classify against these criteria. Now, some person decided loser, failure, non-starter is a label worth having. Again, we don't know who decided it. It just happened to be there. It's always been there. And then they're asked to classify it. And then somebody makes a choice that this is what it is. This is the definition of loser, second-rated, and mediocrity. Again, who decides it? Some random person is asked to do this, and they're paid a pittance to do it. So this is the ImageNet data set. And almost all the data sets are similar in their ability. This is not unusual, by the way. And this is how the ImageNet image classifiers are working. So things like face detection, fine. But if you're doing anything beyond that, it's interesting. So there is even a sannyasi, beggarman, all kinds of wonderful things in there. The other thing is there's a lot of assumptions being made around emotions. Most emotions are trained on these 6 faces, fixed faces, photographs, not videos. So some researcher a number of years ago decided that there's only 6 emotions, which can mysteriously be captured by a Japanese actor, 6 of them, or 7 of them, I think. And they're a perfect proxy for every human. Look, they're okay if you're trying to do kid-based level, but anything beyond that, this is very sophisticated because the underlying assumption is the facial expression captures a lot of depth. And this kind of assumptions are encoded into every tiny nuance of almost all machine learning models right now. The reason I say that this is a mess is because data alone isn't enough. You can throw the data and the machine will learn a pattern, but the data has no meaning. And the meaning comes from humans. We have to give it the context. And if I don't give it the context and I don't give it the meaning, it's just a pattern detector, which is completely meaningless because a pattern detector alone isn't enough to make any sophisticated decisions. It will detect a pattern. We then collapse it without a distribution on it, and it gets into a lot of difficulties afterwards. So give you an example of this. If I said, look, here is a self-driving car, it will brake at a red light, but once every 1,000 times, it won't. Is that adequate? Roughly translates to once a year, it may not stop at a light. Some of you might say, oh, it's not too bad. Many of you might say, no, not acceptable. And then I could say, is it once every 10 years? Is it okay? At some point in time, you might say it's okay. But right now, we don't even know what that number is. The other thing is the data that we use is highly targeted. So I can only use speech data to make a speech recognizer a bit better. Wind turbine data to make wind turbines better. But speech data doesn't help me with wind turbines. This means that I have to select lots and lots of data for specific adaptations, set all the data, set all the context, and so on and so forth. So this whole work is yet to happen. And remember, we still don't know what the machines are learning and how they're learning, which tends to be an issue still. Machines fail, and when they fail, we have to build for the cost of failure. So if a machine makes a mistake, there is a consequence of that mistake. And that can't be something we can avoid. I can choose to ignore it. I can choose to let the user know. But if I'm letting the user know the machine's failed, it means that I have a definition of failure. And the machines don't have a definition of failure. They just have a probability of a guess. Somewhere along the line, I have to say this guess at this probability is not good enough. But that probability is not a fixed probability. So there's more dimensionality to it without getting into the detail. But these are the kind of problems that most of us researchers are looking at and looking to solve. The other thing is this is more of a pragmatic choice. Is it a feature or a function? It's not clear for a lot of people. By and large, most of the AI right now is not functional. It's purely a feature. A feature is something like a cup holder in a car or a radio in a car. It's not the primary purpose of a car. Yeah, the primary purpose of a car is not to play songs. The primary purpose of a car is to move people from A to B safely. As long as they do it, people are happy with it. Is AI a primary function of where it's being used? And if so, if I took the AI out, will the product not be that product anymore? And given the state of AI, we are still in very early days when we are introducing this technology, along with all the risk. The other interesting thing with AI is I don't know if it's useful till I try it. So if I want to know if a face recognition is accurate enough and sufficient enough, I literally have to put it into production. And we've done some in India like that. And it's an 18-month process to figure it out, if it's good enough, if it actually adds value, if it's a bottom line and the profit is acceptable. There's no other way. You can't do this in the lab because the data you need doesn't come in the lab. The other interesting thing with this is that we need a new methodology for building AI systems. Almost everything we know about how to build traditional software doesn't work. And almost everything we know about how to build traditional technology doesn't work. Because the prototyping can be done in a few months. This is what most people are seeing is the prototyping phase. And they're getting very excited by it. But the hard part is the evaluation can take many months to know if it's working in practice. And putting it into production use can take a year, up to a year, because almost everything has to be redone. We rediscover some of the requirements, the edge cases we missed. We may have to go and fix many things. We may have to fix the data. And then again, you have to go through the whole process multiple times. This process is not overall that quick. So there's a lot of research on how to speed this up, of course, that we're currently looking at. This part's clear, and it has always been clear that we need a different methodology, but we don't have good answers as yet. And there's this group of people looking at how to speed this up so we can take the power of AI into many domains. Beyond a few small niche areas, it's not quite effective yet. The other thing is the economic cost of AI is very high. The cost of computing is low, but the issue is when they make a mistake, we don't know the consequences of those mistakes in all domains. And we don't know yet. So that ends up meaning that I'm taking an option or an insurance cost that I don't know about. The risks are unknown. And we don't know when that it works and it's good enough point is, except when we start doing it. So we have to run experiments in production, wait for it, and slowly get all that in place. Again, these are all focuses of serious R&D right now. And this is where the reason why this whole talks may seem negative is purely because some of the limitations is what I focused on. All the other speakers, I'm sure, would have said it's amazing and it's ready to go. So the common question is, when will it be ready? A probabilistic system, a good example is radar. It started in the 40s. It took till the 60s before it started to be effective and useful. People were using it in the 40s because it was better than nothing. And AI may be like that. In some areas, it may be better than nothing. It will require new support, new operational skills, new techniques, new methodologies. And when it went into military, we had to develop strategy, tactics, and integrate that more effectively through the process of warfare. Similar things will happen in AI, with AI and business. A lot of businesses don't know yet how to use this technology. They're just seeing early versions of it and they're getting excited by it. But we have a long way to go. So this decade would be the decade where we learn how to use this more effectively. It's much like e-commerce. When it first came out, very early days, we didn't know how to scale it. We never got Amazon and Amazon Prime in the 90s, early 90s, or even 2000s. It took nearly 15 to 18 years before we knew how to do the logistics to power e-commerce properly. So some of the key focus of where the AI is, how to scale it, figuring out what the value is, realizing that data is not enough. We need the right subject matter experts integrated into the AI workflow. We need a different methodology to build this. Things fail, we now need to know how to deal with it. The utility can only be figured out in the real world, which means the business case has to be constructed differently and the funding has to be done according to that. People don't know whether it's a feature or a function. It might start as a function, it might start as a feature and become a function, but it'll take time. We quite still trying to figure out how to evaluate this technology, and we can't cost it as yet. A lot of this, if it sounds like early stages technology, very R&D, exciting, let's go do it, that's essentially where it's getting used. Any large, serious business will take their time, and rightfully so. I mean, if you used AI to decide whether you get paid or not paid, or it's a probability of how much you're going to get paid, I'm sure most people wouldn't be very happy. In case all of this sounded extremely negative, I want to close on an anecdote as to why it is like that. Is sometimes it's good to know. what to do and what not to do. And that's my talk.
Thank you, Professor Rogers. There's one question from the audience. How will AI help in the medical field?
Right now, AI has very minimal use cases in the medical field because the clinicians don't trust it. So it's R&D, and a lot of R&D is currently happening. But in the next decade, more likely use case in the medical field would be in discovery of better medications, because it's more an optimization problem. But anytime you have to make a prediction that a clinician has to accept, the quality of the predictions are not robust enough yet. So it's unlikely to be widely accepted. IBM bet the farm with Watson on medical AI prediction, and they've gone bankrupt practically. Their entire division is shut down. It's not doing it anymore. So it's hyped up, it's overhyped up, but there are no clinical use cases that I have seen where it works.
There's another question. What risk do you foresee in the way data is collected now?
Any data you collect is toxic. So if you treat data as a toxic material like radioactive waste, it's a better form mentally to consider it. So don't collect any data you don't need. And if you collect data collection is cheap. Labeling it is expensive. And labeling it in context is even more expensive. And in corporate or any world data sets, it's extremely messy because we can make numbers up. We might say number 3 means something, right? Number 3 means high risk, and number 2 means low risk, and number 0 means something. 4 days later, we might change the meaning of number 3, and so on and so forth. The machines don't know the way we change and interpret data. We change, so we interpret it differently, but the machines don't change like we do. So we have to then retrain everything. So that's where a lot of the issues are. Now, the reason why people get excited when they see face recognition or it recognizes a car, and it's uniquely there because the shape of a car has not changed. It's more or less a car as a car as a car. And if it doesn't detect the car, it's not the end of the world. But if you had to bet your house on it, you wouldn't do it. You would not use this technology. So it's early days, worth doing it, but also good to be clear about it.
All right. I think that's it. Thank you very much, Professor Rajesh Wasa, for spending your time and giving your valuable insights on how we can leverage AI.
Thank you for the opportunity.
Thank you. I'd like to introduce our next speaker, Dr. Gopichan Katragada. Dr. Gopichan Katragada is the founder and CEO of Mylan Foundry, an AI company with a vision to transform human experiences and outcomes in wellness, media, and entertainment. He is an independent director of Bosch India Limited. He's also the vice president of IET, Board of Trustees UK, and a member of NASSCOM Governing Council for the Center of Excellence for Data Science and AI. Till January 2019, Gopi was the group CTO and innovation head of Tata Sons. He helped grow GE's largest R&D center, the John F. Welch Technology Center, to be amongst the world's leaders in intellectual property generation. Gopi is the past chairman of CII, National Technology Committee, and the CII Western Regional Innovation Task Force. Gopi helped establish the Advanced Materials COE at IIT Madras and Advanced Manufacturing COE at IIT Kharagpur. He has framed the CII Tata Communications Digital Transformation COE. Gopi was also set up and managed ongoing Tata research collaborations with Harvard and Yale. Gopi holds a BE degree in electrical engineering from Bangalore University and an MS PhD degrees in electrical engineering from Iowa State University. Dr. Gopi Chan Katragata. You're on mute.
Thanks, Gangadhar. I hope I'm loud and clear. Can you confirm that?
Yes.
Fantastic. Thanks for that introduction. And today I'll be talking about using AI to transform products and services. And I am happy that I was there for the talk by Rajesh Vasa. And there are areas where you'll see that we think similarly, and there are areas where we might be thinking differently. And that is exactly the nature of a conference, to bring together different thoughts and different experiences. So hopefully this will be interesting. Transforming products and services using AI. So one of the messages I would like to leave with the folks listening in is that AI by itself is not as powerful, or it shouldn't be looked at as an isolated technology. It's a tool in a tool set, and it should be used as such. And again, AI is a broad connotation for various techniques. So we'll talk about them. But really, where it matters is at the intersection of biology, digital, and materials. And within digital, artificial intelligence, and in particular these days deep learning, is the area of interest, is the area where maximum return, maximum bang for the buck is being produced. Still, as part of the industry, the way we look at it is that 80% of what we do with AI, with technology, at the intersection of biology, digital, and materials, will be driven by the market needs. So it's critical to understand the current needs very well, and also predict the emerging needs, and then look at what technologies will solve it. Again, the market needs will be driven to a large extent by trends. So today, if pandemic and social distancing are trends, they will drive areas such as mobility and the ability to operate zero-touch solutions, and various other aspects of the industrial requirements get impacted. So that's the nature of how AI will play a role, and it shouldn't be looked at in isolation. I do agree with Rajesh that there is a lot of hype on AI, and there are a lot of people doing disservice to AI by talking about AI as though it was human intelligence, and that it will replace human intelligence, and that's where the trouble starts. Human intelligence is pretty complex, and we have IQ, which is significantly ancestrally inherited. Of course, if you don't use it, you will lose it. Sensorially tuned emotional quotients. So if you are able to connect with the people around you, connect with emotions, you will have EQ and you will be using it. If you use your hands on whatever you use your hands, you will have your hand quotients tuned, and it doesn't just open up the neurons for that particular task. Actually, it opens up neurons for a variety of tasks which are responsible for practical experience being put to use. And then there is bacterial quotient. Bacterial quotient is the intelligence which we get from the environment, symbiotically received in our guts, on our skin, from the bacteria which reside there. So this is very complex, and we use all forms of intelligence at various points in time. AI, on the other hand, is math. It is mathematical. It could be codified rules. It could be data queried or machine learned. Most of the discussion around AI today is because there has been significant progress in what is machine learned AI, in particular, the advances in neural networks, and we'll talk about those. So these are tree-based or fuzzy logic, similarity queries, or deep learning. But there are issues in terms of our understanding of AI, because we think about AI in context of the term intelligence, and that's where we lose track because AI today cannot be generically intelligent. So if a system is developed to differentiate between cats and dogs, then that's what it will do. There have been attempts to create generically intelligent systems. GPT-3 is one, but it's nowhere close to being practically usable in any form. So there's a lot of hype caused by those kinds of systems making claims for which they're still not eligible for. So generically intelligent systems are not there yet, and there is no need for them from an industry standpoint. We are happy to use specific AI systems for specific tasks, and we have been using them for quite some time. So have AI applications, are they there? Of course they are, and I'll show you some of them, and hope to convince you that they're being used for quite some time. AI doesn't have episodic memory. If I have this discussion today, I don't automatically have this memory in an AI system. It is trained, and what it has been trained on is what it remembers. So even if it is being trained to learn continuously, what is called episodic memory, which is not connected to the function it's being trained for, will not be retained. Whereas we can retain the episodic memory, even though we do not today understand where it will be useful, and later bring it to use for areas where we did not imagine that this memory could be used. There is no emotion. We can program emotion, but as soon as you program something, obviously it is not emotion. So emotion is spontaneous, if we agree. There's no emotion in AI systems. So chatbots, if they are claimed to be having emotions, that might need to be looked at from a different lens. You can program emotions depending on certain inputs. But like I said, emotions are spontaneous, and they are different depending on different people. Even the people you're interacting with for the same situation, you might have different emotions. So those things are not there in AI today. And creativity, again, can be programmed. You can program to create a painting similar to a Picasso, but you cannot create a new Picasso with a new form of art. So that's where AI is. And again, for the folks on this conference, maybe this is too fundamental, but still I want to share my perspective that while we have been trying to mimic the biological neuron in artificial neural networks, it's with a limited understanding of the artificial neural networks. So what we have said is that, okay, the neuron collects information and it passes it through a cell body, where it passes it through a function and a non-linearity, which is a non-linearity. So aggregation may be an offset and a non-linearity. So that's what we mathematically have reproduced in a neuron. So neither the biological neuron nor the mathematical neuron have significant math going on, or it is not the seat of the power of the neural networks. So the seat of the power in both cases is the massive interconnectivity of the neurons. So with this interconnectivity, what you get, for example, in the mathematical equation shown there, at the simplest level, it is ax plus by plus c equal to 0, which is the equation for a line. So it draws lines in space. You can think about two-dimensional spaces. So if it's cats and dogs, one dimension is maybe the length of the animal, and the other dimension is the pitch of the voice. And you can draw lines separating cats and dogs. If it is a more complex problem, you'll have more variables. So you can think about 3 dimensions and surfaces. But if it is even more complex, you'll have multiple dimensions and surfaces in multi-dimensional space. So that's what we are talking about with an artificial neural network in the simplest sense, is that it can draw surfaces in multi-dimensional space. So it can separate out categories. It can also morph one surface to another. And there are a set of applications based on that as well. So what is the reason for all the excitement? And it's very valid. There has been significant progress in 3 areas. One is natural language processing, the other is voice recognition, and the third is image recognition. And as industry, we take what is there and we use it to the best of the abilities it provides. And that's what I'll be talking about. So what has changed? in the past, the computational power was not there to be doing some of the algorithms the way we are doing it now. So convolution neural network automatically extracts features. Previously, we were extracting the features manually. So if there is an image, we would take discrete cosine transforms and choose the first few numbers as a representation of the entire image. But if you have a crack and you want to recognize a crack and you're doing it using discrete cosine transforms, it's not going to work. So what convolution neural network does is, based on what your output is supposed to be, it will pick the features it wants by using a convolution technique. So it will have layers which are tuned to look at shadows, shapes, lines. Each one of these is a different layer, and it can use as many layers as it wants because it has no computational restriction. And then there is a max pooling layer, and then again you have the conventional neural network, deep neural network in this case. So it's nothing but similar to a multi-layer perceptron, but in this case you can go with any number of layers. Previously we used to stop at 3 layers because we said once we have surfaces in multidimensional spaces, any further layers do not offer me too much, and so we would, for mathematical simplicity, keep it to 3 layers. Today, for even the smallest additional classification or additional improvement in output, we will go for additional layers. So that's what has changed, and that's where the excitement is. So people will talk about AI in the fullest definition, which is okay, but really this is where the progress has been. And in particular, like I said, in the last 3 bullets of what I'm showing here, natural language processing. If you have used the ability to transcribe, for example, that is natural language processing, or if your system is able to detect a sentiment in Twitter, it's natural language processing. Voice recognition is extensively used, and image recognition is extensively used today. Anybody who uses Facebook will be surprised at the quality of the recognition, despite the angles and so on and so forth. And various other aspects of industrial use cases have been used for quite some time. And the issue was that AI was not providing a complete solution, and this is where, when we talk about industrial IoT or provide AI solutions for connected infrastructure in a power plant, the language being used was that we will connect your equipment, we will connect your sensors, and we'll provide all those reports, and that doesn't really cut it in the industry. What is the problem that you're solving? Are you going to reduce the boiler tube failures? And are you going to provide an end-to-end solution? Now, that's where the earlier discussion comes in handy, that it is not about AI by itself. AI has a role to play, a significant role to play, and can do it better than other approaches, maybe if you're using deep neural networks on a thermal image, for instance. However, there are other techniques which need to also complement AI for providing a complete solution. That's one aspect. The other aspect is that the industrial organizational structures have not been designed to take in AI in this form. There are IT departments who do not talk to data science department, who do not talk to the operations department. So in the industrial context, you go to the data science department and give them an AI solution, it's not going to cut it. So this needs to happen at a leadership level, and this needs to happen at a system level, and this needs to happen at an intersection of technologies. So there's a lot more coming up with the capabilities AI are going to provide in video, including recommendation engines, which are based on not only metadata of what you've used, but actual content, lighting and characters and voice and music of what you've watched. And of course, photorealistic smart chatbots are there. We need to take it with the pinch of salt, but today you can have a chatbot who is trained to be your CFO, because much of the knowledge of a CFO can be programmed into a chatbot to give you the appropriate answers. But really, Are you ready to do something like that? That's a question that we'll have to answer. So various other areas are going to be benefited by AI, including health and wellness. There was a question earlier on health. I do agree that the doctors and the radiologists are still in the loop. So if you're going to recognize a tumor using AI, the radiologist will have to still provide his final go ahead. But there are areas, most recently with COVID, with the volumes of data which needed to be looked at, to look at the difference of an X-ray which is caused by pneumonia versus COVID. Those are things very well suited for AI to go through volumes of data on a pandemic-like situation and extract those pieces of information which require further doctor attention. And of course, wellness, there are certain advantages to be working in wellness, and I'll talk about that as well, and various other areas. Again, need to think about it at a system level. AI is great. If you can bring it to the edge, it's even more fantastic. AI training will happen in the cloud, but inferencing, if you want two cars to avoid an accident, needs to occur at the edge. There is no sense of the data and the decisions going back to the cloud and then coming back to the cars. That's not going to work. But with AI for unstructured data, which is AI for video, AI for audio, and vibration data, and so on, and the fact that neural compute is at the edge, and the 5G has arrived. It'll take a couple more years for 5G to be what its promise is. Today, in even developed countries, 5G is not what it can be. It's just emerging out of 4G and maybe even 3G even. But what it will really benefit is the machine-to-machine connectivity and being able to take decisions without having to go back to some kind of a central scenario. Just wanted to show you a few cases of where AI can be and is being used. Beyond the traditional thought processes of characterization or classification or recognition. Here's an example. I can take a particular resolution, in this case 180p, and make it 1080p, because like I said, I can have layers, and at each layer train it to get better and better at interpolating between 2 pixels. So I've taken and increased the number of pixels by 36 times in this video. Sorry. So the advantage of doing something like this, and we have done this in our company, is to be able to transmit a lower resolution, lower quality video and get a higher resolution, higher quality video on your phone, which means that my transmission costs are reduced, my bandwidth costs are reduced, my experience is also increased. Again, face recognition was talked about by Rajesh, and there's an example of what we can do. Because there is a database of 3 million faces, and because it's multiracial, and because there is also a trained neural network already which can be used, and you can just use the outermost layer to create an index for a new image, you can pretty much start using this straight off the bat. So the previous example, we had to develop it in-house, we had to make it available at the edge, we had to program for performance, including low power, 30 frames per second at the edge. In this case, there are applications you can think of where you get one image of an individual and you can start recognizing that individual already, no training required, because there's a pre-trained network and it produces not a classification but an index, because the last layer is chopped off. So this index image was very well recognized. Again, to the earlier point, there were errors. There were 2 errors. Oh, no, sorry, there was 1 error in this entire team image where they were not trained for. It didn't recognize it, labeled as unknown. But one of the ladies got mislabeled as a gentleman in this picture. Everything else was labeled correctly. So this is the state of the art. Are there applications which can use this well? Yes. If there is an error because of a single index image, you can use multiple index image and get better quality of the classification. There are races for which this database is not sufficient, so you have to bolster the data for those races. So these are all practical things, and we can find applications where you can use this effectively. As an example, in surveillance cameras for attendance taking, and all done with the sense of data privacy and only after informing people. As an example, if you want to detect who is going into an area for which you need a training to be in that area, you better have an ability to make sure that the individual going in has that kind of a training. And these applications, if it is flagged that an individual is going in without training, the supervisor will come and take a look. And if once in 25 images there is an error, maybe he can just live with it, flag it, it will retrain, do better the next time. So you can't use it for an application like an aircraft engine, and if it is going to fail because of a misclassification, those are not the applications you want to use it at this point of time. You can use it for detecting people using ads pertinently, detecting text and using ads pertinently. You can use it for detecting and transcribing low resource languages for various purposes. And these are all applications in the field already, and we do it as well. And here's an application. This is into the future, but we've already done the and the patent has been awarded now. So what we're doing here is taking non-invasive measures and mapping it to what would typically be obtained only through blood samples or salivary samples. So C-reactive protein, serum proteins, and salivary cortisol or blood cortisol are obtainable through blood tests or saliva. In either case, it goes to a lab. So these are things which you can do during the clinical trial. Take the blood test, take the non-invasives, and create a neural network which will map the non-invasives into the blood tests and salivary tests. And we do not use the output of the neural network once trained to say this is your C-reactive protein number. It will not work in that manner. What will be suitable at this stage of development is that you use the C-reactive protein to detect acute inflammation or trends in acute inflammation, serum protein to detect trends in chronic inflammation, cortisol to detect trends in stress. And over a large volume of data, you'll be able to get to a good state in terms of thinking about inflammation and stress. And we have done clinical trials with limited data, and it shows promise. Is there work to be done? Significant amount. But is this something that we hope will get us to wellness? Absolutely, you bet. Again, from an AI at the edge standpoint, the difficulty is to be able to do AI on low compute, and the trick is to do the inferencing on low compute. Even then, you have to use the entire environment to the best of its ability, and this is an example in the industrial automation task. Use case, but you can do it for automotive and various other aspects. By doing it at the edge, you will be able to provide outcomes which will be able to solve some of the current problems with AI. So I'll end with this chart, and maybe still have time for a couple of questions. When you're looking at AI for your products and services, first of all, I should answer the question, should you? I think you should. Today, you should have AI, and in particular deep learning, in your thought process, just as you should have digital transformation in your thought process. So how do you go about doing it? You look at what data you already have or you can generate that you have unique access to. And that will form and inform your AI strategy. What manual decisions and intelligence that are required today in your businesses, that takes significant labor and time. If somebody is sifting through volumes of, let's say, satellite images to mark objects in those satellite images, which is a use case we have solved for a national security case, that is not the right way to do it. Number one, the errors will be more even. We can take the gold standard and reproduce it with a better classification rate than if you take all the possible people who are doing that over the time that they're doing that, because everybody doesn't do it as good as the gold standard individual. But we can come close, not as good maybe, but come close to the gold standard individual. Are there aspects of intelligence that can be captured by voice, sound, image, or video? These are areas where most progress has been made. You should be thinking about it. If you have CCTV cameras, for example, I don't think you should be having people watch it day and night. You can have AI techniques do that definitely for detecting intrusion, and possibly also looking at policy violations on environment, health, and safety. Can you detect people wearing masks or not wearing masks where they should be, or other PPE equipment? You absolutely can. In remote areas, you can't have people sitting and watching this, and today you don't have to. You can fuse together multiple sensors and provide system level information. If you have a need to do that, AI will do that well for you. And also you need to think of new ways. When I presented the wellness use case, it's a totally new case, leveraging AI, leveraging new sensors, leveraging the availability of compute on mobile phones. So if you're only doing it to recognize tumors in MRI and CT, which I have done as part of the roles I played at GE, for example, it's a good start. But that's not where we should end, because there are regulations there, and more than the technology, it's the regulations which will hinder. There are people set in doing it in a particular way, and more than technology, that's what will hinder the implementation of the capabilities of AI. There, the only place where you will be able to make quick progress is in a pandemic-like situation, and you have to deal with hundreds and thousands of images. Again, you need to think about whether there's an advantage of performing AI inferencing at the edge versus the cloud. Training, you will do it on the cloud for anything of significance, but inferencing, you can do it at the edge for most of the applications. Like I said, we have done it even for video at 30 frames per second on low compute. So that's what I had in terms of a presentation. Happy to take maybe one or two questions if there are.
Hi, Dr. Gopichand. We do have one question from the audience. Can you tell us about a failure story from your experience where AI was planned to be used, but it did not work out?
Yeah, absolutely. Like I said, Gangadhar, the AI in its various forms, including neural networks, have been used for a long time. I was funded for my master's by NASA to use AI along with developing the sensors, which were eddy current sensors, to inspect the space shuttle main engine tubing. So 1990 we're talking about. So since then, the applications have been many, successes have been few, failures have been many. Only now the successes are more or less, we know where we will succeed, right? One example of an area where we knew how to do it and it didn't still work out, even though the technology was there and provided, was in the area of gas pipeline inspection. 300,000 miles of gas pipeline, oil and gas pipeline in the US alone. And the way it is inspected is by putting in a pig, a pipeline inspection gauge, into the pipe, and it will travel 100 miles approximately by the product pushing it. So you put it in and the oil or gas will push it through 100 miles. It's collecting data. Depending on the pig, it could be magnetic flux leakage or it could be ultrasound. Primarily, these are the two techniques which are used. And then what was done is the data would be stored. It would go to a central location. It would be downloaded and it would be printed out and it would be spooled. Somebody would do this looking at the data. So we are talking now about 1996. So the digitalization of that meant that they were able to view it digitally, fantastic. But they were still doing it manually. There is no improvement if you're viewing it on a screen and using the space bar to spool through the data and still marking things manually. We used AI, we could recognize the defects where we needed to recognize. We would also recognize other features such as, for example, welds, such as offshoot of the pipeline, and so on and so forth. But it never got used because it didn't do it 100% of the time, because we didn't have 100% of the data to train it. I believe that it could have been used for the 80% that it was giving the outcomes, but the industry doesn't usually accept solutions which are not, when I say 100%, I'm not saying that it's right the 100%, but it covers the 100%, right? So that's an example of something which didn't happen then. Even now, I won't be surprised if I go into the operation center, somebody is sitting and hitting the space bar and spooling through the data. You're on mute, Gangadhar, sir.
Thank you very much, Dr. Gopichand, for your valuable time and sharing your experience with us. So it's great to understand and see what all we can see going forward using AI, especially in wellness, is something that really opened my eyes. Thank you.
Thank you, Gangadhar.
I'd like to invite our next speaker, Madhu Kandasamy. Madhusudan Kandasamy is a leading artificial intelligence software development group. Is leading the artificial intelligence software development group at Qualcomm India. He has more than 2 decades of industry experience across AI, distributed ML, DL framework, big data processing, and Unix Linux OS development. His current focus is on optimizing AI inference on edge devices for both power and performance at Qualcomm. Earlier at IBM, he had worked on developing distributed machine learning algorithms, frameworks like Snap.ml and DDL to reduce the training time of complex networks in multi-node CPU, GPU clusters. On the OS domain operations, he developed lock-free memory allocators, malloc subsystem for OS, many Unix Linux kernel features, and system call optimization. He also has 20+ patent grants and many research disclosures under his name. Welcome, Mr. Madhu Kandasamy. He would be talking to us on embedded AI.
Thank you, Gangadhar. Hi, good evening, everyone. Let me share my slides. Okay, I hope my voice is loud and clear and screen is up.
Yep, we can see it.
Okay. Hi, good evening, everyone. So today I will talk about embedded AI, the evolution of embedded AI, and what are the use cases propelling its adoption, and what kind of challenges these use cases are imposing on both software and hardware, and how the hardware and software innovation is kind of tackling those issues. So, like many industry experts would say, AI is kind of transforming every industry, similar to invention of an electricity. So when electricity was invented, it fundamentally transformed every industry. So similar way, AI is touching all the industry, right from banking to healthcare. There is not even a single industry which is untouched by AI. And when we kind of take embedded AI segment within those industries, there are 3 pillars which is kind of predominantly impacted or improved by AI. One of the main industry is mobile, followed by industrial IoT. So the industrial IoT segment is latest innovation in the computer vision makes a lot of factory automation really possible. Like if you look at all the car manufacturing industry, majority of the hardware pipeline is automated by the robotics. And if you move on to auto industry, not just self-drive cars, or in the mid-segment cars itself, we see a lot of AI-assisted features nowadays, starting from virtual assistant to take care of the jobs through voice command like open up Google Map or target to some specific location, create a map to that location, and even for the assisted parallel parking and stuff. These things becoming very common in the auto industry for both the safety as well as infotainment. And moving on to mobile. So mobile is one of the very ideal platform for AI-based use cases because it has a lot of inbuilt sensor and it has a high processing power. And on top of it, it has a very pervasive adoption across all the people because everybody has that mobile. So, and AI is enhancing a lot of capabilities in those mobile with the AI features like computer vision, voice recognition, speech processing, and natural language processing. So all these features kind of making the experience with mobile is very enriching. And the earlier days, the AI was already there in the mobile, but during those days, majority of the AI processing was offloaded to the cloud. And nowadays, with that, all the processing which you have been doing in the cloud is moving to the on device itself. One use case everybody could remember is this. A Google Assistant or a Siri, those assistants. So they used to do this NLP processing, voice recognition back in the cloud, and then you need both connection and also the cloud processing and the cloud processing API to call it, which will do the translation. Now those things is kind of moving to your on device so that you get a better experience with a low latency. And not only that, moving those use cases to the on device improves your security because your data do not move away from your device, and also improve the privacy. And you don't need to have a network connection every time to use the AI feature because it is processed locally here. So you have all-time, always availability is there. And the cost is also getting greatly reduced by moving those AI processing from your cloud to the edge. And if you look at the list of phone applications, so we have two segments of AI application in the phone. One is coming from this OEMs, which enriches a lot of AI-based processing on both camera and audio use cases. If you take the camera use cases, majority of the mobile phones now come up with a camera, so which specifically enriches the photos you take with that camera by removing the noise, improving the texture, and providing different effect on those images you take. And when you move to audio, the noise cancellation and echo suppression becomes a very common use case among them. And when you go to the regular applications, the application is kind of coming from this app developers and ASVs as well. And majority of the applications, mostly this video and audio processing application, has a very good number of AI use cases. If you take Snapchat or TikTok, a lot of AI-based filtering helps to give a better engaging use of those applications. And when you move to the video side, you have this super resolution, and it will also try to identify what is the action you are doing with this video. So it will kind of try to use the segmentation and summarization of this video. And with those additional sensors, there is new use cases coming, which will monitor your health, how much you walk and stuff like that. So because of those multiple sensors and compute, we see a tremendous increases in the AI-based use cases for your mobile phone as well. And on top of it, you have this gaming, which also which also needs some of AI-based processing as well. And if you specifically in case of mobile, all different IP blocks, which used to be a separate blocks, is kind of already moved into a single SoC. That's kind of the thing which happened in the last decade. So which makes this whole processing capability to consume a lesser power, and with works within the specific thermal budget and the very small form factor. So these are all the kind of a propelling factor which made a mobile is the most popular device for AI and use. So let's take some interesting use case in mobile and then see how AI is applied there and what kind of expectation it puts on both the software and hardware of those mobile. So in this specific use cases, we will see how AI can be used to do automatic translation of language in a live speech. So when, let's say in some use case, if you're talking in English and the other person need to kind of listen it in Chinese, we can do this kind of AI solution to automatically do the translation. So when you speak the audio is kind of going inside the mobile, then it goes to the sensing hub. Then in that sensor, it detects a particular keyword, and then it knows, okay, it can do some automatic translation for the destination. So then it goes to then a separate neural network, which will convert your audio. First, it will remove your echo, noise reduction, those things it will do. After that, it will do audio to text. So then all your audio will become regular text. Then it will get applied to another deep learning neural network, transformer-based network, where whatever you talk in English, it gets translated to a different language. In the specific case, we can talk about how the English can be translated to a Mandarin. So once this text is translated into a Mandarin text, then it will go to your next neural network. So that will convert this text back into audio, and then it can go for another network, which will make the audio feel like a regular human voice rather than the robotic voice. After that, it reaches your modem, and then your converted audio goes away from your mobile. So on the receiving side, the person really listens to a conversation which is spoken in Mandarin language. So then the same thing will happen on the reverse side as well. So this way, this combination of these multiple neural networks can give one enriching experience of how two guys, without having a common knowledge, a common language, and a translator, can seamlessly speak without much of an effort with the help of these multiple neural networks. And another use case, if you kind of look at this camera-based, this is one of the snapshot of a chameleon without any AI-based processing. So this is how the camera typically used to be. Now with the AI-based cameras, you see the photo is kind of a bit enriched, but what's going in background is the raw photo goes through multiple filters or multiple AI models, which kind of segments these picture into different segments and identify what kind of segments are those. What is a background? What is a foreground object? Whether it is a scenery, a green scenery, or it's like a different landscape. So based on it, it applies different color segments to each of those segments to make this picture really look better. And this needs a processing power for each of those neural networks. To move from the previous picture to this picture, you would need 4 neural networks with 5 TOPS of processing power is needed to have this kind of AI improved picture. And if you kind of take this further and move it to a video, then you need to apply this neural network in a loop for up to a 60 FPS to have a smooth transition. And then we also need to have additional neural network to take care of this video transition as well. So it kind of proportionally increases the TOPS, but at the end of the day, it gives you a really nice video you can get without any expert knowledge on using these cameras. And if you take this further, if you go to this XR domain, you see that you have to have these things done for both eyes. You have 2x of compute. And not only that, there is a lot other sensors you need to take care of into the XR, because you need to know which direction you are facing, what kind of movement you are moving, where is your hand, what kind of action you are doing with your hands. All these things need to be kind of understood in this XR so that it can provide a proper intelligent virtual view. Like, I don't know if some people might be aware of this HoloLens from Microsoft. So with that kind of use cases, you need to kind of really have a more compute power, and also need to have multiple sensors to understand things, to kind of have a holographic image projected in front of you, which you can interact with. So that is the kind of the trend we are seeing in XR, which is all based on AI with more compute power requirements. So what kind of challenges it poses on both hardware and software? So that's our next segment of discussion. So I think one thing which comes pretty obvious is it needs a lot of AI horsepower. Even in the previous couple of examples, we see it has to go through a lot of neural networks, so which needs more processing power. And any use case if you see, so fundamentally what it happens is it doesn't see it as a stream of bytes or bits. So in case of the photo, previously it used to be just a set of pixels with color codes, but now with AI, it clearly understands what that picture represents, what is the focus object, where it is taken. So all those things it really understands from that picture and what are the objects are there in the picture. So it makes understanding of this picture. When you talk, it's not just the audio bytes. It really understands what you are taking, what is the meaning of your talk, how it can translate. So it goes beyond a stream of bits and bytes in case of AI, which gives very intelligent experience and use cases to this user. And then if you take this, so this two use cases we have seen, that is kind of, it is on-demand use cases. You take a photo, then this AI gets triggered. And there are few use cases which needs always on. See, for example, if you wanted to have some application in your mobile, which has to detect if the child is crying. If the child is crying, you want to send an alert message to the parents or who were registered for it. So if you want this kind of application to be developed as a mobile app, then you need to always listen to the audio signals. And even this virtual assistant where you have to say, okay, Google, hey Siri. So there also it needs to always listen to this audio voice. So these kind of things, you will not give an opportunity to shut down any IP blocks. It has to listen always, and we need a lot of low power requirement in these kind of scenarios. So if we kind of sum it up, these use cases, majority of the use cases needs high performance and need to work on complex concurrent scenarios. And all the use cases invariably needs a low power. And to get the low power, you need to shut down some IP block or reduce the speed, which may not be possible because you need a peak performance. And on top of it, you need to keep those IP blocks always on, which is also another a big challenge in the mobile space with respect to the hardware. And then moving on to the software side, this AI segment is a very happening segment. There are a lot of new frameworks keep on coming on every other day, and each framework has one advantages over other. So there is not one compelling winner on it. So we need to kind of support multiple different frameworks for different kind of scenarios. So because then a lot of new neural network architecture is keep coming on. So how do we take all these different framework and neural network architecture and make it available on our edge software? That is becoming a big software level challenges. And not only that, these software also need to be optimized very well for your edge device, because edge, if you wanted to save power and get high performance, high power hardware alone will not be sufficient. It needs both a better hardware and a better software. So in the next segment, we will talk about how the innovations in the hardware and software kind of help you to overcome both the challenges in these two segments. So moving on to the hardware segments. Okay, so we all know we need high tops. So to achieve the high tops, we can always come up with. I'm struggling with my. Okay. So on the hardware side, to get the higher tops, we can. I mean, one way is you can get a more number of CPUs, but obviously that is not as scalable. Then people might be aware of GPUs, so that will try to do a lot of parallel processing, and it is kind of predominantly done for graphics, and then later it moved to the machine learning side on the training aspect of it. So from the embedded AI segment, we need some special processing engine to take care of efficient execution of these deep learning models. When you split between the AI between the embedded segment and the regular AI in the cloud segment, most of the embedded AI segments are built upon deep learning use cases, mostly on computer vision and other things. So once you come to this deep learning use cases, even the deep learning also, it is not both training and inference. Majority of them is only on inference is happening on the embedded use cases. So if you drill down into the inference on the deep learning, it's nothing but a forward pass on a set of weights and biases. So it just, when you do a forward pass, all it does is it takes the activation, multiply by the weights and adds a bias and applies some activation algorithms at the end. So that's the fundamental or common most common denominator across all those use cases. So it makes a lot of sense to come up with a new silicon or a processing engine which will accelerate that specifically for AI on top of the existing CPU and GPU. So that is what you see the trend in hardware. And if you take our Qualcomm example, we have a hexagon processing engine which will provide these kind of accelerators. So this accelerator has both tensor and vector and scalar accelerators. So this tensor accelerator will try to help you to get all your matrix operations much faster. And then the scalar is similar to your CPU, which will help you to kind of do all the arithmetic. And then vector will try to help you to do the SIMD kind of processing with the vector processing. So all these 3 units put together called a accelerator engine, which will help you to accelerate your AI-based deep learning forward processing much better in the embedded device. And then if you kind of move to the software side, not sure whether my slides up properly. Okay, so I think there's some part of the side that I will still go on. So on the software side, if you look at it, we have a varied set of open source software available, which will help you to do the training aspects of it. Now, when you try to do inference on top of it using using the embedded device, you need to have a separate custom on-device SDK. So if I take an example of Qualcomm, so we have a execution engine SDK called Snapdragon. So this will help you. This is one of the on-device SDK, which will help you to do those acceleration much faster. If you kind of look inside it, so you have training which will be done on a very number of different open source framework, and you get a model, and then you do a proper regular training, which will help you to get those model in a much accurate way. Once you receive that model, then you come to this on-device SDK. So this on-device SDK has 2 parts. One is pre-processing part, and one is the inference execution part. In this pre-processing part, we have a support for multiple different open source framework and convert it into a common internal format. And then you take this internal format. This internal format is a compressed model which you are trained on the server side. Then you kind of push this model into your SDK, and then you do inference on top of it. So these kind of on-device SDKs will help you to easily use all the open source, different kind of open source train network run much better on your edge devices. And there is another kind of software which will help you to directly access your hardware compute. So one of the software is called AI Engine Direct. So this is kind of a thin layer on top of each of those compute. So if you wanted to do some processing on, let's say, this AI processor, then you can build your software stack on top of this AI Engine Direct, which will provide the list of operations for you, using which you can build your neural network. So this like for example, your Snappy, you can build on top of it. If you have some TensorFlow, PyTorch, everything can be built on top of the direct engine. So it gives a very direct access to your engine in a much faster way. So then this is about your on-device SDK, which will help you to run your application be trained on multiple different open source network. Then other set of technology which will help you to improve your power and performance is called quantization. So what this quantization helps you is, if you take your existing model trained in the open source framework, so that will have a bigger bigger network with lots of weights and biases in floating point. So first you need to kind of compress this network into a smaller size. So you need to do some forward cross to identify what are all the dead neurons are there, what are the neurons you really don't need to use to achieve accuracy. You can remove them, you can remove those layers. So that kind of tuning you can do. So in the next step of optimization we can do for embedded devices, you can compress those floating points into a integer numbers. So if you take the same range, the floating point range, and then convert all the weights to a same bucket from X range to Y range with a proper correlation between each of those weights and biases, then you should be able to achieve a relatively better accuracy with much larger reduction in the model size. So that way you can save a lot of power, because integer operations is way cheaper than doing a floating point operations. So this AI model efficiency toolkit or this kind of quantization softwares will help you to convert your float based models into integer based context models, and these models is really small in size, which can be easily put onto your on device. So this way you can improve a lot of performance and improve a lot of power utilization metrics. So I think now we try to kind of summarize it. We have a major problem with high compute requirement on hardware, and then we have versatile open source softwares needed, and then we need to improve our performance. With the hardware, with the AI processor, we will get a lot of tops and power efficient operation of the hardware. And when you come to software sides, we have on-device SDKs similar to the one which I give an example from Qualcomm. These on-device SDKs will help you to write your accelerated implementation of those AI operations. And then we have this quantization technique will help you to optimize your models to improve your performance on your on-device computer. Yeah, I think this is what I was kind of planned to cover for this note. Maybe I can take some questions, if any.
Hi, Madhu. There is one question from the audience. What are the already implemented AI use cases on embedded systems which are available for public use right now?
There are multiple use cases available. I think you just need to Google and look for some open source projects. I think majority of them, if you go for TensorFlow, there is a separate directory called research models in the TensorFlow GitHub. And then you have this TF Lite GitHub available. There all Google implemented a lot of many AI algorithms, but you need to build your app on top of it. But the core AI algorithms, you have reference implementation available. And then if you kind of enroll yourself to the developer AI summits, when the people kind of present it, many of them will kind of give a reference to the POC implementation of their new neural network. So you can fetch onto it to implement your embedded AI-based applications.
Okay, thank you very much, Madhu, for your insights on embedded AI, and it was great to have you at the Iesa AI Summit. Thank you.
Thank you.
I'd like to introduce our next speaker, Dr. Geeta Manjunath. Dr. Geeta Manjunath is the founder and CEO of Niramai Health Analytics, and has led the company to develop a breakthrough AI solution for detecting early-stage breast cancer in a non-invasive, radiation-free manner. Geeta holds a PhD from IISc and a management education from Kellogg's Chicago. She comes with 25 years of experience in IT innovation. She has proposed and led multiple AI projects for Xerox Research, Hewlett-Packard India. Before starting Nirmai, Geeta was a lab director for data analytics research at Xerox India. Dr. Geeta has received many international and national recognitions for her innovations and entrepreneurial work, including CSI Gold Medal, BIRAC Winner Award 2018, and is also listed on the Forbes list of top 20 self-made women 2020. She was awarded the Accenture Wahini Innovator of the Year Award from Economics Times and Woman Entrepreneur of the Year 2020 by Biospectrum India. Geeta is also an inventor of 16 US patents and more pending for grant. She has also bagged the Makers India Award titled Women Make in India in March 2021. Dr. Geeta would be sharing the technical challenges in applying AI to medical imaging and opportunities to make impact, particularly for cancer care. She will also share her learnings from developing and commercializing an AI solution for breast cancer detection. Dr. Geeta Manjunath.
Thank you very much, Mr. Gangadhar. It's a pleasure to be part of this summit of discussing AI and high performance computing, particularly from a hardware perspective. It's a unique combination. As Gangadhar mentioned, yes, I will be talking about use of artificial intelligence in medical imaging, a huge part of healthcare application domain where you consider AI and machine learning as such. Because when we talk about use of AI in healthcare, there are particularly three ways you can use, right? So one is like any other application domain, there's a lot of customer facing activity. You know, how much time did you spend, waiting for your report, how much time were you waiting in front of the lab to get your test done, and so on and so forth in hospital or diagnostic center. So this is the routine operational excellence, which is similar to several other application domains that you will see. The second bunch of them are more in terms of data crunching, with text data crunching, which could be like what you would have heard about, like IBM Watson and all, where you will say, okay, I want to know, today patients are becoming almost as good as doctors to just sort of Google and go to the doctor and saying, why don't you give me these 3 medicines? Because this is the issue I have, right? So how is that? Obviously, we have this huge web of information that's available. Now, when you have so much of information available on the web, how do we crunch it together and sort of, give it in a capsule so that it is relevant, for the search that is done? So that again sounds very similar to the normal text analysis that is done with other, application domains. So that's the second bunch of application areas with health. Third one is basically where you're using AI or machine learning for actually making a clinical decision, or at least help the doctor make a clinical decision. And that's the clinical decision support, which is basically extremely challenging and also an upcoming field, right, where a lot of real-time information is needed, real-time analysis is needed. And that's mostly what is going to be the focus today. How do we use AI to make really critical decisions that can help doctors make the decision faster or directly, make the decision for the patient? And particularly in that is where we will focus on some medical imaging. I'm sure, each one of you would have seen at least one real medical image, be it yourself or one of your family members. The X-ray, the chest X-ray is the most common medical image that all of us have seen, which is basically the X-ray of the chest area or hand or whatever, right? So that's sort of the one big one. And then also there are several other type of medical images like the CT scans of the world, the ultrasound, the MRI and mammography and so on and so forth. Ultrasound can be for different parts, and so it starts looking different depending upon the probes and all that. So these are actually images that are interpreted by radiologists to say whether something is normal or abnormal. And radiologists definitely need artificial intelligence is the hypothesis. And we'll see an example of where we can actually make this work. one obvious thing is, especially coming in from India, we know that there's a huge shortage of doctors, definitely huge shortage of experts, definitely huge shortage of expert radiologists. And what I was reading is that one radiologist is serving about 1,800 patients in India, 1,800 patients in India every month, I think. So this is a huge load on a radiologist. And what is the radiologist doing? He or she is actually looking at an image like this and making a call as to whether somebody has cancer or not, somebody has broken their leg or not, and so on and so forth, or COVID or not, and so on, right? And this is a visual analysis which requires actual full focus on the image to actually make the right call. And when the doctor is making so many interpretations at a time in a per second, then obviously there could be fatigue and errors in diagnosis. So that we want to reduce. We definitely want to increase the diagnostic accuracy so that there is lower rate of misdiagnosis and improved patient outcome. At the end of the day, if we are able to make the radiologist interpret these more accurately, more faster, at least he or she will also have some time to relax, right? And most importantly, the patient also is going to be happy. Now, why are we discussing these? And this is maybe an obvious need, right? But this is seldom emphasized because we already always talk about 1:1,000 families that a doctor serves in a village. But this, I'm saying, even in an urban scenario, we have this issue, even for an expert specialized area like radiology. And when we're looking at medical images, we all now know, and I think there were quite a few talks earlier in the conference which tell you that deep learning or AI particularly is actually pretty good for visual pattern recognition. The patterns could be, of course, images, video, audio, and sensor data and so on, where there's a whole lot of data available. That's when AI does well. So it's a nice match of need versus demand and need and benefit that AI can bring. There's a few more challenges, that we want to call out when we talk about AI in general and compared to healthcare in general. Of course, some of you would have seen this like 4 V's of big. I think now there's 7 or 8 V's. We can go on adding V's there. When we talk about big data, we talk about volume, variety, veracity, velocity, and so on and so forth. What mostly happens is that when you start building a model, though, of course, the world has a lot of data. The world has a lot of X-ray images, a lot of mammography images, and so on and so forth, MRI, and so on. When you actually start building the data, you will start with very, very small data. So though there is huge volume of data available, the model building starts with very small amount of data. That is because it has to go through ethics clearances, and you need to get data from a particular hospital where you have permission to take, and so on and so forth. There is good variety, but we will focus mostly on medical images. So let's say it's just video and image data. And veracity is most important. What is veracity? Where that is missing or noisy data. Compared to several other domains in healthcare, we do have a huge scope for missing and noisy data. Think about an ICU monitor which is put next to the patient, right? Let's say for some reason the power went off, and then the monitor started sending 0 as the BP or heart rate. So is it because the power has gone? Is it noisy data, or actually is the person no more? So that's why it's 0. So it's really such a critical information that you have to figure out whether it's actually missing data or really the data is that way, which means it's a high priority information, right? So this is a huge issue in healthcare particularly. And velocity of data, usually we talk about data at rest versus data in motion. Velocity is data in motion, where data is coming in from sensor data, particularly health vitals, like for example, an ICU monitor and so on. So here, how closely you can monitor, how closely you can get the time series data, better will be the prediction. But typically, if you're monitoring, there is usually, you don't want the patient to be disturbed so much that, you go on, intervening with the with the patient's comfort to actually keep on taking data. So you have to balance between how much data you can actually pull out of the patient versus how much you definitely need. So there's so many of these, and the most important ones lifted on the left side, the top and the bottom, is where I want to spend 2 more minutes. One is the imbalanced data set. When we talk about machine learning and training for machine learning, we know that it's all about probability information, learning the, let's say, deep net or even simple probabilistic models to say whether the patient belongs to class A or class B, cancer, no cancer, fractured, no fracture. This is what we're talking about, 2-class classification. But typically what happens is, though the models require you to have a balanced data set, equal number of samples in class 1 and class 2, in healthcare particularly, the number of people who are ill is much smaller than the number of people who are well, which is good for the world, but it's actually very bad for machine learning because it results in such imbalanced data. Talking about cancer, right? 0.4% of people can have cancer, which means out of 1,000, you may have, let's say, less than 100 people, right? Sometimes even, suspicious is 4%, but actually you turn out to be 0.4 in final biopsy. So it's a huge imbalance of data. So why is that the problem? Let's say you are trying to compute the accuracy of data. You have 100 samples, and let's say 4 of them have cancer. Then it's very easy to develop a machine learning model which gives you 96% accuracy by saying no, 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 right? So it's really not about accuracy. It's also about how do we make things work when the training set is imbalanced, as well as the data you're coming from outside, getting from outside during production release, if you will. That is also very imbalanced. And how do we ensure that we don't miss any cancers, miss any positive cases, despite those being very, very small percentage? So that requires you a huge amount of fine-tuning of algorithms that we need to do. And the last one, which I want to, last one, uncertainty in ground truth. So radiology, right? We see show these images. What happens is that some doctors will say, yes, there is a problem, and some doctors will say, no, there is no problem. So there is an uncertainty in the ground truth because imaging is used when you cannot, or before you can do a pathology. Like its final ground truth for cancer, for example, is to take the tissue test, put it on a microscope and actually look for those cells. But you don't want to do it for everybody. And that's the reason why you have a proxy, which is the medical imaging. Now, here, the idea, just based on a medical image, you will not be able to confidently say whether somebody has cancer or no cancer. So there is always this multiple ground truth that is coming in. So you have to wait until you actually send them to a biopsy to say whether there's real ground truth or not. What if no radiologist has suspected cancer, but she or he went away with the cancer? Then we have a wrong ground truth already. So there's all of these sort of issues. And finally, feature dependencies, right? We always talk about IID, and some of you who may be working on the AI algorithms, that independent data points is what we are looking for, right? And in those cases, especially the body is so complex, you're measuring the BP, you're measuring heart rate, there is some connection. High BP will result in a high heart rate. So these kinds of implicit feature dependencies is very difficult to model many times. So all of this makes developing AI solutions for clinical decision support very, very challenging. And, these are some of the machines, which have very, very smart systems and also embedded computing, which do some kind of live analysis and then throw out only images which actually possibly matter to the radiologist. And that is what we want to kind of, analyze. Now, a particular use case of this is what I'm going to take up today, which is medical images, but what we call as thermal medical images, where we measure the temperature variations on the chest and that variation, because, you can have multiple types of sensing. MRI is magnetic resonance, ultrasound is, the ultrasound, basically sound waves and so on and so forth. X-rays is what we know what it is, and so on and so forth, right? So this whole electromagnetic spectrum can be used, in MR, also microwave is being used, and so on and so forth. And different wavelengths give you different type of signals about the body. Ideally, you want to scan the multispectral camera and then try to figure out, is there some messages or some signals you're getting in all. But then, infrared imaging is something that we have been working on for the last 6 years now. And we found extremely, interesting patterns here, which is what I'm going to talk about as a case study, particularly talking about a particular disease, which is taking away 600,000 deaths every year, particularly women who are losing their life to breast cancer, which is the largest cancer killer today. And the unfortunate thing is many of these people would have lived only if they were detected early. It results in really late detection today because women wait till there is a huge lump before they even come to a hospital. 1.7 million new cases are expected, every year, right? Even especially more so in Asia. And why is this happening? How can we change this, right? So the first approach that most people used and the world knows is mammography, which is using X-rays again for detecting breast cancer, where the breast is compressed between two plates and X-rays are plastering. And this is good. This is mostly used for women above 45 years of age, which are like women here. These are X-rays of two women. And the first one is a 60-year-old and the second one is a 40-year-old. Now you can see that in a 60-year-old, you can actually find this small white spot, which is the high density age area, like a small lesion, which can be suspicious of malignancy. Whereas in this particular case, you have the full whole breast appearing dense. And this is because younger women and women, some women have what's called as dense breast because of higher fibroglandular tissue and so on and so forth. So with this, what happens, how do you actually find this issue within a dense breast? So X-ray fails. And that's again, one place where other imaging methodologies can help and is being used. And more women are younger today when they are detected with breast cancer. So these were missed by mammography, not just in India, but globally as well. There's also affordability, accessibility question that developing world like India needs to answer. A 3,500 rupees test is a lot of money for women to spend every year to detect early. So can we have a more affordable methodology? And I always feel, it's very, it's strange that we use X-rays to detect cancer because as we know, X-rays mean radiation exposure, and more frequent use of the screening methodology itself can increase the risk to the disease which is trying to screen. So it's extremely, of course, it's a controversial topic, but there are studies which show, for example, mammography-induced cancers and so on and so forth, particularly when there is high risk in the women. So all this, made us look at the new method of detecting abnormalities in the body, which is thermal sensing. Thermal sensing is basically, you would have seen the thermal sensor, infrared cameras, infrared imaging devices in the COVID timeframe for fever detection and all that in airports and so on. It's a similar kind of a thermal sensor which is used on the lady's chest area. And what we have developed is an AI solution over these thermal images, which provides the following advantages. First and foremost, it can detect much before a hand can feel, that is much before a symptom appears, asymptomatic lesion detection, where the lesion can be as small as 4 millimeters instead of 25 millimeters, which a hand can detect. And clearly, it's a stage 0 detection. And we made it extremely non-contact, non-invasive, because this is a camera which can be controlled remotely, as in behind a screen, for example. So it's completely privacy aware, where nobody sees or touches the person during the test. And women really love it because it is extremely privacy aware, like a changing room experience. She has to disrobe, but nobody sees her. And most importantly, like I mentioned, radiation is not great. So this particular solution, basically, it's just measuring the temperature. It's absolutely no radiation. It works for women under 45 as well as above 45, and also on men, because it does not depend on density variations. It depends on the physiological variation, and I'll talk a little bit more about it. And it is extremely affordable, 1/20th the cost of a mammography machine. And so more and more diagnostic centers can provide this and make it more accessible. And it's also very portable. It's like a 1 liter water bottle. You can either give the test inside a hospital or take it out and do the screening outside the hospital. In fact, in COVID time, we have actually started home screening. The technology where we use AI or machine learning for this particular purpose is what we call as thermalytics, thermography or thermal analytics. So when there is a lesion, there is higher metabolism, higher cell division, irregular cell division, which results in an increase in temperature at the point, as well as surrounding the lesion, there is a kind of an abnormal thermal pattern, which is what our software tries to analyze. Analyzing these temperature variations, about 4 lakh temperature points, which are measured per person, we are able to identify whether a person is abnormal, where is the likely abnormality, what is the probability that it is actually cancer. This is a very unique solution made in India, where we have 10 granted US patents and patents in several other countries as well. Here, we are not looking for lumps, which you saw in those X-ray machines, X-ray images I showed. We are looking for abnormal tissue activity, because we are looking at abnormality in the cell division and so on and so forth, which is what is the actual signal of the cancer, right? Whether it is hard or not is kind of an incidental side effect, right? The fact that some cells are behaving abnormally is what we need to detect, and that is what it does. But the key thing here is that thermal cameras are around. We just have to take an off-the-shelf thermal camera, thermal sensor to take these images. And even thermography has been around. People have tried to use thermography to say whether somebody has cancer or not, or some other abnormality, because anything that is hot may be something, indicating abnormality. However, out of 100 people, 60 people will have a red spot. So, here it's basically a heat map, red or white is high temperature and so on. So you can't call out 60 people as cancerous. So that is where we need this analysis to say which hotspot is actually because of cancer and which one is spurious because of, let's say, hormonal aspects or tight clothing or something. So the core innovation that we were able to develop in our team is basically differentiation of malignant and benign condition, cancer or no cancer condition. You see 4 women here, right? The first one is a normal. The second one has cancer here. And you may assume that, okay, maybe asymmetry between the left and the right side is a way to figure out. But then there are several pieces or, women like this where you will have asymmetry, but she's not cancerous. She has a cyst or hormonal imbalance and so on. So like I said, so that is where you need, some sophisticated analysis. And there are 2 ways to do machine learning here, right? Database analysis and feature-based analysis. And for healthcare particularly, and those of you who are looking at it, you'll see that there's so much literature in medical science and medical literature that, it always helps to take advantage of that. Build a model which has both database decision, that is like a deep learning like model where you just dump the data and then try to do a feature learning and then use it for your machine learning, as well as try to incorporate the knowledge of medical science in handcrafted features, so that you're able to do 2 things. One, you're able to utilize the domain information to make better predictions. Secondly, most importantly, you can actually explain the answer to the doctor, right? And you can't say, okay, this person has cancer. Why? I don't know, my machine learning model is telling. That's not an acceptable answer. So you need to say, okay, her vascularity is high. Here is, you see some, veins feeding this to this particular lesion, whereas in this other breast it is not. So these kinds of explanations are needed for the doctor to believe. So we had to model it with the more semantic kind of features like asymmetry, thermal distribution of like focal increase in temperature and so on, we call it. And also hotspot boundary, whether there are abnormalities in terms of irregularity called speculations, which is a medical term that the radiologists understand very well, and so on and so forth. So this was one nugget I would like to sort of share. And in terms of classification itself, I talked about, issues with ground truthing. So obviously every machine learning classifier would have a training and a prediction cycle. And what we did was, to figure out what features are needed. Like I mentioned, some of them, right? It has to be semantic features. And more particularly going into this, so one more point here is that also what is the label? For the label, what we did was to actually do thermal imaging of one person and not ask a radiologist whether it is positive or not, because there are no good radiologists who can say yes or no with the thermal imaging today. So what we did was to basically make the person go through thermal imaging, and the same person went through mammography, ultrasound, and biopsy. And we took the biopsy results to actually, train the, train the models. And there are several such features that were used as well. So it's not just about saying whether, malignant or benign. We also have several machine learning models throughout the case. For example, when you give an imaging task to a technician, we want to reduce the skill of imaging so that we can have health workers do this, let's say in rural camp. When they do that, they make a lot of mistakes. So now, can we have an algorithm to say whether the image quality is good or bad? Has she taken the right views that are needed? And so on and so forth. All of this has resulted in multiple machine learning models, right? So, just to sort of give you an idea of where we are, okay. It is actually an install. I mean, it's commercially available. 60 plus hospitals are using, multiple 5,000 plus outreach camps have been conducted. And we actually generate these reports completely automatically using machine learning and AI. And finally, excellent results compared to even mammography, which is a standard of care today, with 100% sensitivity and 93% specificity in screening population, and several publications and regulatory clearances, awards, and so on and so forth. And so this is a learning on the ground of how AI can be used to save many lives. And as a technologist, I feel very thrilled to actually see AI making decisions in rural camps, saying whether somebody needs to be brought to a hospital or not within 15 minutes of the whole end-to-end test. And with this experience, I'm very happy to answer any questions you may have to me.
Hey, Dr. Geeta. Thank you very much for your insights, and I hope you're able to reach out to more people, and especially getting in early detection of breast cancer and helping them, identify earlier. It's a huge thing nowadays that we're seeing more and more women are getting cancer early and young. And thank you for enlightening us as a technologist and also giving us your perspective on healthcare and what you guys are doing. Thank you. Next, we have a panel discussion on academia's role in making India an AI hub. I'd like to introduce our host, Ms. Sridevi Devireddy. She's a credible thought leader in the innovation entrepreneurship ecosystem of India, a Shaniving Research and Innovation Fellow from Oxford University, alumni of IIM Kozhikode, Osmania, and Kakatiya University, India. She's also the founding CEO of SR Innovation Exchange, SRIX, a technology business incubator under the aegis of DST, Department of Science and Technology, Government of India at Warangal. She has steered SRIX to international level in less than 2 years. She has received many awards, National Entrepreneurship Award in Ecosystem Builder category 2019, and she's also been named the Pride of Telangana, which she received an award for in 2019. Ms. Sridevi.
Thank you, Ganga, for the kind words. As per a recent global study by PwC India, the highest increase in use of AI during the pandemic has been witnessed in India. With the increasing adoption of AI in business, there's a need to ponder the scene as far as research, talent, and ecosystem is concerned. Today, we have an amazing panel of academicians, policymakers, and researchers with us to discuss the same. Let me introduce you to our eminent panel, Ms. Professor Sudeshna Sarkar, Head of AI Center of Excellence, IIT Kharagpur, who is also the project director of AI for ICPS Technology Innovation Hub on Artificial Intelligence and Machine Learning for Interdisciplinary Cyber Physical Systems. Professor Sarkar works in machine learning applications and in neural language processing. Our next panelist, welcome Professor Sarkar. Our next panelist, Dr. Buddha Chandrasekhar, Chief Coordinating Officer at AICTE. He's a technologist, senior IT systems architect, and entrepreneur. He architected 180 plus technology-based systems. That's quite a number, sir. He's leading NEET, National Educational Alliance for Technology, Internship Enterprise Portal, Artificial Intelligence Language Translation Project, and Indian Knowledge Systems Project for the Government of India. Coming to our other accomplished speakers, Dr. Ajay Garg. He is Senior Director at Ministry of Electronics and IT Government of India. Dr. Ajay Garg heads the International Cooperation Division, which has a mandate for promoting international trade and cooperation, driving IT and ITES sector, apart from managing the responsibilities of e-commerce and innovation and IPR. He is the brain behind the Mighty Startup Hub, a dynamic, singular, and collaborative platform for tech startup community towards meaningful synergies in the Indian startup ecosystem. Our last eminent panelist is Dr. Atul Negi, professor at School of Computer and Information Technology, University of Hyderabad. He teaches AI, problem solving, machine learning, and deep learning. He has been a research project investigator on numerous research projects funded by DIT, ISRO, related to AI and language technology. Good evening, all. Thank you for taking out so much time to be with us today. So firstly, I would request Dr. Sarkar to give us the opening remarks based on her experience.
I think the theme of the panel is academia's role in making India the AI hub. So as Dr. Sridevi has already mentioned, that AI is a technology, is a disruptive technology, which is accelerating breakthroughs in various domains of not only science and technology, but also society and academia. So if India has to, get into the forefront of AI, or near the forefront of AI, academia has a very important role to play, because what will drive the AI capital of a nation is its power to innovate and do deep research. So academia can contribute to AI, AI progress of the nation in different ways. First of all, in all domains, typically universities drive the frontiers of research. And I will elaborate on this further. Secondly, academia has a very important role in creating a talent base in order to drive the AI economy and to make, have a lot of talented people. We require a large number of people, and academia will play a unique, very important role in creating these talent. Thirdly, academia, in order to succeed in this, must also challenge itself and promote the translation of science and technology achievements into commercial products by universities. And then there are various, apart from industry problems, AI has a very important role in solving social problems and important problems relating to sustainability and different important challenges facing mankind. And academia has a very important role there. Finally, academia has a very important role in promoting responsible use. But I also believe that in order to drive the AI innovation, the entire ecosystem has to work together, which means academia, industry, researchers, startup, government, all of them must work synergistically so that we can achieve the true potential in AI. So to elaborate on a few of these points, so it is very important to have to drive fundamental research in AI, as well as fundamental applied research, because it is not just the general AI algorithms, but also how they're applied to different important disciplines, whether it be manufacturing, whether it be combating climate change, providing water resources in agriculture or education, smart mobility. So these important use cases must be worked on by the academia, who can really drive the progress. But in this respect, as I think industry has a very important role to play. So AI is a very specific, in today's world, a large number of AI talent is concentrated into a few major industrial powers who possess a large amount of the data of certain important problems driving the economy, as well as who have the compute power and platform. So it is very important for to have a system where there is enough talent in academia who can nurture and create more talent and make AI talent and AI AI technologies available for use for the society and different industry. And AI capabilities are not just required for AI research, but AI is driving research in various domains of science, whether it is in astronomy or physics or sociology or economics, or the various technological frontiers such as manufacturing, cyber physical systems. AI technology has an important role to play. And the use of AI and the data is revolutionizing research in various domains. The second very important role of academia is to create a talent base. So the main force behind the AI innovation is to have deep talent and also a large amount of skilled manpower who are able to deploy AI and develop different products and innovate. And for this, it is important that AI education, AI knowledge, or of these emerging domains is available to various students, professionals, etc., across the spectrum for use in their own domains. As well, it is very important for the innovation capital of a country to raise that, to create high-end AI talent. And it's also important to talent reskilling of existing workforce. It is also very important to make sure of the employability and different aspects of the talent base. Now, as we all know, India has a unique position that it has a young demography. There are a lot of young people who are interested in technology. India has the largest IT manpower. So India is uniquely positioned because the workforce has the interest and the skills, especially the young people, to make contributions in this domain. So what is very important is to have an educational framework which will enable our students to work with an innovative mindset and a sort of education which does not limit their imagination but helps them to be able to innovate. And also, in order to make them ready to work with the industry, it is also very important to have academia and industry collaborate to develop use cases, to teach, to bring in the application aspect, to enrich the different courses and offerings and projects, which will make the students and the faculty aware of working on different cutting-edge use cases of AI.
Thank you, ma'am. Now, I'll come back to you. Now, I would request Dr. Ajay Garg to say a few words on the theme, academia's role in making India the AI hub.
Thank you, Srideviji. It's a pleasure to be part of this very important summit and a hardware industry organization driving an AI summit. It means the importance is drive that we not only are controlling the soft skills, we are actually driving towards controlling the hard skills also. So it's very important and very glad to be part of this ISA conference. And bringing the academia into together is a lot more important. Now, let me say where if we want to be the AI superpower of the future, what are the few dots we need to capture upon? We need to capture upon the use of AI. We have to bring India into the frontiers of AI research. We should be the AI capital for human talent. And we should be driving the AI policy for the globe. These are the four things, if we do and do well, we actually are in the forefront of the AI ecosystem for the past. Now, so you have given me 5 minutes. I'll take 1 minute each on each of these. This can take ages for. So if you talk about AI use cases, now, as Professor Sarkar already said, that the AI research and AI algorithms have been long developed. Now, India, because of its large data resource, because of the prowess which the public digital platforms are bringing data as a, we need to create use cases, innovative use cases, where AI as a digital tool solves problems for all sectors of technology and becomes a socio-economic tool for upliftment. Now, who will develop these use cases? These use cases have to be developed by talented students from the academia, translating into entrepreneurs of the future. So driving an entrepreneurial ecosystem around the identifying problems and driving entrepreneurship around this is a very important role that academia plays. And the 51 tight centers which MIT is supporting, I think will drive towards that. Now, as far as fundamental research is concerned, there are many problems that needs to be solved, which looks theoretically impossible. Like studying the amount of elements on the sun looks impossible. Bringing solutions which can dynamically translate from one language to other. Miss Reddy talking in Telugu and me talking in English or Hindi, and all the audience might listen in any language that they are interested in. This is the future we might be looking at. It's far away, but AI has the power to solve it. Who will solve it? It is the research in the academia which will actually run these moonshot projects and drive them. I know the failures might be big, but because the academia has the capacity to take failures and not the industry or even the government is not attuned to taking failures. So they have the best shot to solve problems of the future through dynamic research. As far as the talent is concerned, I understand they are doing great things, but the problem in India is that most of them are developing solutions which have been told to them. The products around AI or product development ecosystem is the missing link where the talent needs to be developed, and the academia has an important role. India has always been driven by policy which comes from the top. And that has been the problem why we have not been able to create attuned policies which actually suits our local needs. Academia, because of its links to the roots, that is students, and the bigger community, can actually drive a policy making where the policy is highly technical in nature rather than legal or pure economics. So it has to be, academia has to also play a very important role in policy making. So these are the 4 pillars, I think, if we actually solve them right and have an active participation of academia, we have a great future in the AI domain. Thank you.
Thank you so much, sir. I'll come back to you with my questions on your statements. Now, I would request Dr. Buddha Chandrasekhar of AICTE to share his views.
Good evening, all. Thank you for inviting me for Iesa AI Summit. As we see, artificial intelligence is bringing a dramatic shift in the world of technology. And as the fastest growing economy with the world's second largest population, India has a big stake in the AI revolution. Industries estimated that 56 million AI professionals by 2025. So what it really means is we as a Ministry of Education, we need to prepare, upskill and skill our students and faculty for it. And since COVID, there is as you all know, there's a tremendous change in education, teaching and methodologies. And slowly, from last few years, everyone is pushing towards digital education, but due to COVID pandemic, the students was pushed towards working on a remote method and utilizing this digital infrastructure. And the institutes also no option than relying on technology than ever before. I think that's where the artificial intelligence started playing a major role, because now we even slowly started utilizing artificial intelligence based facial recognition and for attendance, etc. And the skilling of students and faculty in artificial intelligence is very, very important for our future generations. So one of the company which got selected in NEET called GUVI, it's a IIT Madras incubated startup. So we had a collaboration with them, and we are planning to upskill 10 lakh Indians in for 1 day free workshop on artificial intelligence on this 24th of April. And we are aiming to set up a world record. The thought process here is we want to give that taste, to our students and faculty. So we have decided from at the age of 9 to 80 years, everyone can come and they can try out on learning artificial intelligence. At least they can learn what it means, and how they can do and how they can use fourth generation languages, so that without coding also how they can create smaller systems using artificial intelligence, and they will taste what is Python. And this is what we are trying from skilling and upskilling side. But within the ministry itself, now we are no more only a policy making ministry, we are a technologically driven ministry. So we are utilizing artificial intelligence within our projects itself. Example, we created one project where we translate the documents from English to 8 vernacular languages. We have used deep learning, TensorFlow, and advanced artificial intelligence technologies in that project. And we have an internship project where we utilize the deep learning and created lots of meaningful decisions and data out of it. And another project called NEET project. So we are extensively using artificial intelligence for our internal projects itself, so that we can showcase that to the students as well as the universities and institutes. So that's but that's one of the part, because I strongly believe we need to upgrade our infrastructure also, so that we can do a better research, because the research side, I think we are really lagging on the research side. So we need to invest a lot on the research, and we need to take things forward. In order to do that, we started recently something called Yukti. So basically in Yukti, we help students, faculty, as well as institutes to come up with the startups, mainly on the technological side, like artificial intelligence, etc. And basically they can take up any domain, education, health, financial services, or any other field, they're interested in. And we are trying to help them, and we are trying to give them an entrepreneurial touch, because the idea needs to be translated from a thought process to a reality. That's where, we are helping them. And that entire Yukti platform was developed using an artificial intelligence on the background. So we are, we are not only trying to upskill and skill the students and faculty, we ourselves are upgraded ourselves, and we are utilizing artificial intelligence because we understand, that's a future. And we are slowly trying to take the same thing towards every institute in the country. And another thing, what I see is the hardware. I mean, the infrastructure side, I think we still needs to work a lot, because I see IITs and NITs, they have a better research opportunities, and they are working on a research side. But on the other side, if you take any other institutes where I see they are lagging, I think we need to concentrate on that and try to take it forward. Maybe if you have any further questions, I will try to answer those questions at the time of Q&A session. Thank you very much.
Thank you, Dr. Buddha. Now I would request Dr. Atul Negi to share his thoughts on the topic.
Thank you. Very warm welcome and good evening to everyone in this panel. I'm really tremendously grateful for this opportunity. Speaking at the end, I suppose, having heard from everyone, so I can just maybe address some of the views. One very big concern I have, which is coming from the University of Hyderabad, which is a highly ranked NIRF university, and also it is a part of the university system. We must have a bit more of diversity when we make policies, and we must not just think of that there is some number of I's and followed by a T. Is that the only kind of institutes which we have in our country which can help in deliver with AI? I mean, that's a serious question to ask, okay, because the equality of opportunity and such things will help us in developing a larger and broad base of students and faculty who are empowered to be able to deliver on the question which is there, okay. And I'm of course grateful to the AICTE and the MEITI fundings which my university has received, and I myself have benefited from the MEITI projects on language technology, and also I've been a co-developer of the Telugu OCR and Telugu language products which we have. So we have been working on AI, and the University of Hyderabad has an M.Tech in AI from the days of the late 80s. Okay, so please process that. Okay, and I have been myself been teaching this M.Tech in AI from almost 3 decades. Okay, and through those 3 decades, it's been a very like a roller coaster ride. We been through one summer of AI, and then some winters, and now there is again a hot summer with the blaze of the deep learning. So and of course now it's really very interesting, because for students and for faculty and all, what we have been struggling for a long time, struggling with pattern recognition, the abstractions of pattern recognition. Now everybody wants to get into it. That's very interesting. It's excellent feeling for me, having been in this field. Okay. Well, what is it that we need to do now to broad base our talents? Now, see, talent. Let us be frank and say that talent is everywhere, and there are a number of companies which actually go to the colleges. Of course, it takes them more time, but they go to the AICTE colleges, and then they hunt out the nuggets, gold nuggets, which are found out there. Okay, I think those companies which bring out those nuggets are really doing the great service to our country and to the field as such. So similarly, I think we must understand and appreciate that these nuggets would be everywhere, and we should try to give them a chance. Okay, so basically, I would suggest with a metaphor that we must have a AI playground. Okay, and the eminent industries and the government agencies, if they provide the playground. Okay, what do I mean by playground? It means like, see, we need for AI, AI of course now being highly data centric. So the terabytes of data is there, but we need processing, and we need that the compute powers that is available with the GPUs. And as those of you who are trying to get a GPU device for themselves, that the prices of the personal level of the GPUs is going through the roof because of the miners. Okay, so can we come up with more innovative approaches by which GPU time is sort of scheduled, and the pool of GPU and that kind of things should be made available at maybe at a national level or at an institute level, and such kind of things should be there. Okay, that is I feel going to go to a big extent to provide this kind of AI playground for our students and our faculty and all. Okay, someone might say, okay, Google Colab is there, but throughout the pandemic with my students, we have struggled through Google Colab because that just disconnects after some amount of time. And when you want to actually get to something which is really going to be at the edge, it doesn't cut it. Okay, so that is what has been a revelation for this pandemic time. Now, what I would like to say is that where universities are at a very good place is that at universities we have a diversity. So there is at my university, there is a unit which is called as comparative linguistics. All right, now comparative linguistics is a unique thing which is going to help towards the translation projects which Dr. Chandrasekhar has mentioned. And in fact, we have a team here who has been working again from the late 90s with Professor Sangal first, and then there is now again a MEITI project which is on the translation. Okay, so these kind of things are also there. And another important thing is that to surpass the language barriers which we have in our country, the problem is very acute in terms of knowledge of English. So then these translation tools will really broaden and flatten the base and get our students into that thing. Okay, so another viewpoint which I have is that what is happening is that there is always a push for our publication, and the publication people who control our destiny are sitting all in the West. Okay, can we not think of and have more merit for India-based projects and the problems which we actually face, and give more credit to those problems? All right, so it shouldn't be that there is a panel which is totally looking for, oh, did you publish in the transactions or not? Okay, but that is possible only if you have those data sets which are fashionable for the publishing in the transactions. And then someone will come across, will say that, oh, okay, you haven't addressed this, so I don't think so you're significant. Okay, I think this kind of approach must be totally reversed, and we must look at India-centric problems and approaches. So what are our domains? Say, for example, can we customize and bring up agriculture domain data, and we can sort of focus on that, how agricultural domain data, which is there at various stages of agriculture. So maybe say like you have a AI-based combine harvester, all right, which is say for in our country, because we have a boom and bust cycle of crops. Say like for example, tomatoes. Okay, tomatoes is a highly perishable crop, and do we have AI to be able to address those kind of things? And I think at academia, if you are giving students these opportunities and the data sets and the ability to the capacity to play around. So of course, the fantastic things which is being done by the Atal FDP, where I given a number of talks, is doing a great bit for these kind of things. Okay, that's really tremendous. Another thing which because I strongly believe in this, that technical societies like IEEE are also doing their bit. They sponsor humanitarian projects. Okay, I have been the chair for the IEEE Hyderabad section, so I know a bit about that. And they also are quite egalitarian, and they have a very good bit of diversity, and they do have a connect with the international agencies by which our Indian solutions can also be scaled up to the international level. Okay, so I think these are some of the aspects which are food for thought. And as it's a panel, maybe I can stop speaking here and give the round back to Madam Sridevi for us to continue this discussion.
Thank you so much, sir. Now I would request Ajay ji, as one of our panelists was also emphasizing, Dr. Sudeshna was emphasizing, what model of partnership do you think government, academia, and industry should have to take AI forward, going forward? What model do you think will work in India? Maybe some of the model worked in the West. I'm not sure that will work here, but I would like to prick your brain on this.
So thank you.
Dr. Sudeshna, Ajay ji, Ajay Garg ji, after that, the same question I'll ask you as well. You can add something else as well, if it's okay with you.
Yes.
So if you take, for example, where the academia, government, and industry. So let's understand that for a path-breaking research domain, which AI happens to be, a relationship between an academia and industry is paramount for taking this success. Now, our traditional models by which the academic research flows into industry has failed to deliver the desired results. There has been little translation, whereas the academia wants quality, the industry wants speed. And so both of them, there is a missing link in this. So the government's role should be limited to creating a policy framework to interconnect them. Now, what is the policy framework to interconnect them? I thoroughly believe that an academia industry partnership in traditional technology transfer domains has failed tremendously, and it has to be the academia who has to be the entrepreneur themselves to take this research to the market. The Technology Incubation and Development of Entrepreneurs Scheme of the Government of India, or MIGHTY as you call, has been truly built on this very aspect, that a faculty coming out with a path-breaking research has to be an entrepreneur for that path-breaking research to take it. And has been a lot of success stories around this. And I'm happy that this is one model that works. The second important thing is where the industry-academia relationship is bridged by the government is an example called the Mighty Startup Hub or the Atal Innovation Missions and Startup India program, where you bring the whole ecosystem together, the large tech, the young tech, and the academia and the mentors. If you bring them all together, academia needs state-of-art research facilities in today's date. They need the testing and accreditation systems, which academia has, the industry is devoid of it, or have to pay a very heavy sum for it. And academia is not able to use it at the 100% capacity. So if the Mighty Startup Hub, the whole purpose is to connect these together. So there the government plays a facilitator role. There the government plays that it creates an environment where it connects. But the moment it starts controlling the policy domain of an academia industry relationship, then it messes up. And I hope that the government doesn't do that. Thank you.
Dr. Sudeshna, a follow-on question on this. Can you help us understand a commercialization that has happened in IIT Kharagpur, wherein you were in charge? Any example can you give us where the industry, academia, and if possible, the government also had a role in it?
Thank you. I do not have a specific use case because I have not been involved, but technology handovers have been there. So it has been, as Dr. Garg has mentioned, so it is possible that the technology which is delivered in the academia that can be transferred to industry through a startup or through some payment. So that model has been there. However, the other type of model which is quite rampant in other countries like USA, where even large tech, they routinely work with academia. So that model, I think, is not very prominent in India. And we have to seek what is it that prevents them from coming together. What are the policies of academic institutes? What are the differences in approaches? So as Dr. Garg rightly mentioned, industry looks for agility and speed, whereas academia has to work within its time frame, and often they don't match. So there has to be better understanding of each other's strong and weak points, and based on that, one has to take advantage of the system. There are other problems with IP policy and other things where industry funded research, while there have been instances where MeitY or other government institutes, they have certain projects which bring academia and industry together, but industry on their own working on their core technology is something which is less in India. And this is where there is a lot of scope, because often there are certain use cases where the academicians themselves can develop the use cases and bring out the technology, whereas there are certain sectors where those use cases are not available to academia. So the exact use cases, the exact nature of the work, the complexities, that type of data and use cases, if they are made available to academia, there will be further scope of innovation, whether by the faculty, the students, or the researchers. So I feel that more has to be done in that front, because technology transfer, while it is happening, the numbers are not very large. So these are my thoughts.
Dr. Buddha, you are planning to say something?
Recently, we as a AACT, we collaborated and we spoke with, we had MOUs with a couple of government organizations as well as private organizations, and we connected the institutes with the industries, and the students started working as an interns for the government as well as private entities. Example, for 1 lakh internship opportunities on oil and gas, and we connected national highway authorities with our students. And now recently, 2 days back, we connected Jal Jeevan scheme. So where we are going to preserve the water. It's one of the favorite scheme of Honorable Prime Minister. So he wants to provide the drinking water facility to each and every household. So now we had a tie-up with the Urban Development Ministry, and we are connecting all our institutes who is interested, the faculty as well as students who is interested to be part of it. We are connecting them. So now see, the paradigm shift is already started, but maybe I completely agree it is in a bit maybe smaller scale. And now we are doing this with the Indian Railways. So we have created an amazing web application, which is mobile as well as web application, where the student can work for Indian Railways in all across, the zones they have in a pan-India basis. So that's another module which we have created, and we are trying to, get the academic one side and the industries on the other side, and together, working together, in one place. I think we are working on that. And if you have any such models, because the new education policy is agile in nature. We are open now. We are no more Babugiris. We are not Babus. Now we are completely open for new ideas. And we are taking things forward, ourselves. And even recently we had an interaction with a London-based company who is working on completely remodeling the aircrafts. And we have connected them with our college students, and now they are learning, and now they become an interns for that company, and they are learning how to remodify the aircrafts. I think the world is changing, and from the Ministry of Education side, we are also taking some initiatives to do that. But having said that, these initiatives, I think we need to do much in a larger scale. I think then only we can, we will succeed because, we have 35 crore students. I think, we need to do this in a larger scale. That's what, thought I would like to share.
Yeah. Dr. Atul, I would like to ask you about the research you're doing or the research you're part of in AI. Can you share some thoughts, some of your use cases?
Yeah, thank you. So amongst the interesting use cases which we had was that personally myself, I was working on machine learning, and I had a student who was intensely interested into operating systems. So while I was interested into machine learning and my student was interested in operating systems, then the two of us, when we worked together, we came up with a AI-based scheduler for Linux. And this is not now, this is in around 2004 or 2005 time framework, where people weren't really so keen on AI, and there was a lot of skepticism that would it work or things like that. But I have consistently been working on applying AI and putting them into systems. Okay, so more recently, reinforcement learning based schedulers for Hadoop is the thing in which one of my students, PhD students, had worked. Okay, so I would say that if you want to pin down my theme is that putting AI into computer systems. Okay, so and I also have some kind of a survey paper which is on that. Out of my own 60 plus publications, and there you can see that we put hidden Markov models into the state determination of whether a system is compromised or not. Okay, so that was also one of the works, and that masquerade detection and such things. Okay, that is again relevant to the computer systems, and a lot of my work is related to the face recognition and different imaging components like principal components. And I feel there is a lot which we can use from those things, which are now they are the building blocks by which present day AI applications would be built up. And of course, yes, we can continue to do the work which academia is very strong on, that we need to nurture and build up the talent and train them with their full strength. And I'm sure the strength of institutions of University of Hyderabad and Professor Sudeshna's IIT Kharagpur, our strength is we do stand world over for the quality of our training. Okay, so while there are other aspects of that, whether or how our research is going to get productized. All right, so then once you come to this, then as Dr. Garg has pointed out that there are three entities on into this activity. One is, let us call it as whichever entity, whether it is DST, whether it is MAITI, or whether it is AICTE, it is, let us say, bracketed as government. Second entity which is there, which is the those people who are actually working in the domain, say some faculty and their students who are into that small specific part of that technical aspect. Okay, and third entity is the industry. Okay, now let me explain a very practical problem. When I coach a student who is doing an internship in an industry, I have coached the student, but as the company with whom he is working or she is working is the industry. So all the IPR is then attributed to the industry. What is there for me then? What is there for the government then? All right. So we need to have some model by which these kind of things should be addressed, so that now there should be a kind of a honest and equity based sharing of these kinds of intellectual inputs. Okay, so very honestly, that these kind of honestly equality in the sharing of the IPR and such kind of things will give a lot of encouragement for the fertile imagination of the faculty who guide such projects and things like that. So that will really develop. Okay. One last thing which I have is that, of course, it may interest Dr. Chandrasekhar intensely, is that AI and learning analytics. At our University of Hyderabad, in my school specifically, within 15 days of the pandemic closing our institutions, etc., we shifted over to Moodle training, and there, all our student data and other such kind of things, written assignments and everything is getting into that. Huge amount of data is accumulated there. Okay, is there a way in which we can formulate projects and see that how customized learning and the pinpointing of the loopholes which certain students have in their learning can be brought out, and through that the quality of training which they may get would be improved. Okay, I think so that will also add to all our problems or issues. I mean, it will help to solve some of the problems and issues which we are having here, to build up a strong talent base for AI, and then India becoming an AI hub. Okay, okay, maybe right now that's all from my side.
Yeah, we just have 5 minutes to go. In this 5 minutes, I would like to ask one question with Dr. Buddha and one question with Sudeshna ji. Dr. Buddha, you were telling about AI program which AICT is facilitating, the mass scale program. Can you throw some light on that?
Yeah, I mean, the thought process, as Atulji said, I think, now we need to work aggressively and collectively. I think, we need both, which I see sometimes we are aggressive, but we are not collective. Sometimes we are collective, but we are not aggressive. I think we need to do both, work together. And I really appreciate Atulji. Please share the data sets. We are happy because I as you know, I run the NEET, is another initiative. So we are already doing it. Now we created a timeline for students, like how Facebook is doing. See, what is interest, why people are interested in Facebook? Because, you just go up and down, you will see, it is like, the timeline, right? So they are seeing their future, they're seeing their current, they're seeing their past, and who all are associated, when they're associated, at what time, for what, for why, on what location. I think we are also creating a similar kind of artificial intelligence system on the background to understand the learning capabilities of a student. Because every student, we have identified, every student is unique in nature. So we need to create a personalized and customized artificial intelligent learning management system for the student. So that's where we are working, and we are creating data sets, and we are trying to learn. I mean, as you know, it takes years, to collect the data and feed that, and, and make our engine learn all this and start implementing this. So we are working on all this, sir, and I'm interested to have a collaboration. And at the same time, we are working very fast. And not only on the customization and personalization, even we are going on the language also. So we are giving a touch of a local language, because I strongly feel your mother tongue is the language where you can learn anything in the world, in a much faster session. Because I'm from Andhra, if you teach me in Telugu, I can understand it in a super fast way than any other language. Even though I may speak in all other language 4 or 5, but that's the way things work, right? So we are trying to create this tool completely on a localized way, so that it has that local flavor to it. So even we have created one portal called internship portal, and there a lot of people said it's looking beautiful, but one word it really attracts. It says, our portal is as beautiful as pani puri. So everyone forgot the technology. They said, oh my God, I think pani puri is the one. I think we need to correlate. So we started creating this application in a user-friendly way, in a much faster way, and it learns from the student, and it adopts, and it tries to customize itself or herself, so that it helps the student. And we are trying to create interactive material. because I strongly believe that seeing is believing. Now I see you, so it has my imprint, in my mind, right? Now I know who is Atulji and who is Shudanshidi Sridevi. So that imprint is very important. So now we are slowly trying to move everything towards an interactive based learning. So what I mean by interactive based learning is, let's say a video when we are running, so it automatically pops up a question and it will ask a relevant question. And if you answer it, then it's fine. If you're not answering it to a right way, then it will give you additional information in an interactive way so that it can create an interlinkage in your brain. So basically wiring, like a similarly how our brain has a wiring system. So we are also creating a similar kind of a pattern so that our student can become a super student. And then they can, once they know what to do and how to do, once they get empowerment of the right and left brain, I think, no one can stop them. I mean, that's where we are working on a couple of tools. And
Thank you, Dr. Buddha.
out of the tools, yeah.
In the paucity of time, I would like to, Dr. Sudeshna, I have just one question based on your vast experience in education. I would like to understand your thoughts on how can we make India AI capital for human talent? What do you think we should do at a war foot?
I think there are very good policies of the government as laid down by National Education Policy, but not so much direction on implementation. I see that few universities and institutions, they have started programs specific to AI, but others maybe we will follow. The main disadvantage that we have today is the paucity of quality faculty for AI. This is not just in India, all over the world, because the truly top-notch faculty is migrated, many of them, to a top few companies. So India, this is very much there. But the advantage is that we have our young students who are very enthusiastic about AI. And today, thanks to the digital platform and the huge amount of materials, it is much easier to scale up learning. So I think there are a few things. One is we must have good capacity in higher education in AI, including top-notch PhDs, etc. And I think there, apart from good quality faculty, we require collaborations with international and national, between international and national partners, as well as with industry. So this is number one. Number two is to create a large number of people at the undergraduate and postgraduate level who can join different companies, industry, government, and work on AI applications. Thirdly, I think that people, students, whatever discipline they are from, whether they are from economics or humanities or physics or chemistry, I think in every domain, research is increasingly, there is a lot of research which is happening through the use of AI, by automating the publication search, by by mining through the data. A lot of research is happening. So it is very important to have the capabilities of these emerging technologies available for all. So there must be this three-pronged strategy. One is AI for everyone, so make everyone aware and be able to use the basic tenets of AI. Secondly, develop a good quality manpower who are able to work in industry and in AI, developing AI products. Third is, that is very important, create those people who can make higher leaps in AI, who can create their own companies. And I think the first two we should be able to do. The third is where we have to give a lot of focus. So this is my opinion.
Thank you, Dr. Sudeshna. Ajay-ji, the last question is for you, and we will summarize after that. After listening to all of us, all the empowered panelists, how can academia help in policy aspect of AI? How can all of us be part of a policy which can make India AI capital for human talent, which can make India drive policy for the globe, which is your vision. So how can academia help you in this? Your take.
Understand where India is different from rest of the world. India is different from the rest of the world is that we believe in an ecosystem which is inclusive. We think that the power of technology should impact the last man on the road. And that's where a very important policy domain, if you're connected with the grassroots, and unluckily or for whatever reason, many people sitting in Delhi might not be connected with the grassroots. So either they take their input from the legislative process or from the academic process. So both have to provide their inputs for a right set of policy making. At the same time, let's understand if AI has the power to change the way the problems are solved, and if AI has the power to solve any and every problem, it can be as destructive as the nuclear technologies were there in the early 20th century. And that's where a right balance between the use of AI has to be formulated. If in the 90s and 20s, a policy would have been created or the ethical use of nuclear technologies would have been created, I believe Hiroshima and Nagasaki would not have ever happened. And the ethical use of AI has to be driven by the sensitive faculties and academia to create a holistic policy framework to create ethical use of AI and to stop the detrimental use of AI, which it has the capability to do. And that's, I think is a key element and a key sensitive issue which the academia has to drive because of its intellectual prowess. Thank you.
Thank you, sir. Thank you so much. It was an amazing panel. A lot of key points, key takeaways we all have today. Industry, academia, and government have to work hand in hand instead of working in silos to create better impact of AI on everyday life is one key takeaway. And as Sir was telling, AI capital, we should become an AI capital for human talent. Given our demographic dividend advantage, I don't think the day is far when we will be doing that. And policy, hopefully we'll come up with good policies which will be applicable to the rest of the world as well. And a lot of good initiatives are happening by government as well as academia. Let's hope for the best. And thank you so much. Thank you so much for all the time, and your mementos will reach you home. Thank you.
Thank you.
Ganga, now over to you, Mr. Gangadhar.
Thank you, Ms. Sridevi. Just to sum it up, I think now we would just like to go to the closing of the conference. I would like to invite Mr. Venkata Simhadri, CEO and MD of Moschip, and also the chair of Iesa Hyderabad chapter, as well as Mr. Ajay Naini, who is the VP of Xilinx, and also the co-chair of Iesa Hyderabad chapter.
Good evening, everyone. Can you hear me? Can you hear me, Ajay? Yes, I can. Wonderful. So this is a great, great, great event. It's a great result of a lot of planning, so much hard work. It took 6 months of planning and a lot of hard work went behind it. But the last 2 days just flew by like a minute. We really wanted this event to be different. We wanted it to be more technology focused, especially on semiconductors. Without the advances that were made in semiconductor technology in the last 10-15 years, AI wouldn't have been a reality. However, the software and algorithms, they are all making the end user applications a reality. So that even touched upon the system engineering and applications as well. What I believe, we had more than 2,000 delegates, great speakers from across the world, the keynote speeches from the industry visionaries. They were really the highlight, especially Dado, the serial entrepreneur and the investors from Silicon Valley. His journey from a poor farming community in Philippines to Silicon Valley. What an amazing and inspirational story. I'm sure the speech inspired many, many young engineers across the world. Similarly, the Valley Ryan's keynote speech. He highlighted the importance of data collection, analysis, and the security. You know, how important the security about the data. Great, great inputs from him. We were really so lucky to have him with us. And also the support we got from the Telangana government. Shri Jayesh Ranjan Garu, he highlighted the initiatives taken by the Telangana government and the vision they had in declaring 2020 as the year of artificial intelligence. He did mention that the government took the initiative to introduce AI in every class, in every department. It's a fantastic idea with great vision. And coming back to our panel discussions, edge computing versus cloud computing. Very educative discussion with great inputs from industry experts. We have to focus both on edge and cloud computing, and it also needs tight integration between them. Industrial automation is another great topic we discussed. It's an excellent area for AI to increase both efficiency and productivity. And the panel discussion on India's role in AI software. This is where I feel India should really take a leapfrog. We shouldn't just become a service-focused industry. We should we should take the lead in creating AI applications and AI companies and products. The panel discussions from academia role, that's again the last panel discussions we had. It is the time for academia to step up. They just don't need to, the academia shouldn't just focus on talent creation. The academia should become actually R&D centers as well as incubation centers for the startups. And also the AI for smart cities. It was a very interesting panel discussion as well. The inputs from GMR group, the kind of things they're doing, very futuristic and very inspiring. So in the end, it was a great event. 2-day event, as I said, flew by like a minute. We had delegates from all over the world. I hope you all have something to take away from this great event that's put together by the IESA team. And I hand this over to my colleague Ajay Naini. He has some inputs for the delegates as well. Ajay.
Thank you, Venkata. As Venkata said, every great conference have to conclude and everyone should be able to take something away. We hope today's artificial intelligence conference will contribute to the vision of Atmanirbhar India, AI for AI. The 2-day event was made possible by many people. First and foremost are the 2,000 plus delegates who attended the conference. Thank you all. We had a great mix of speakers, both international and from India, both from the industry and academia. On behalf of IESA, I thank all the speakers for taking time to address the conference. Every conference needs funding, and we sincerely thank our platinum sponsors, Blaze and Xilinx, our gold sponsors, Moschip and Qualcomm, and the government of Telangana for their sponsorship and support. We had a team of more than 30 volunteers working for the last 6 months to make this event possible. I would like to congratulate and thank each of the organizers for taking time from their day job for this conference. I would like to recognize and thank the conference chair, Srinivas Bairi, for leading from the front. Kudos to the IESA and the Hyderabad chapter for conducting this event successfully. At this time, I would like to invite all the team to join on the video, please.
Thank you, guys.
Wonderful, guys. Thank you. So we plan to bring the next AI conference even on a bigger scale and hopefully physically this time.
Can we ask our Bangalore team also join us? Thank you, Surya. Thank you for all the support. Here is our Bangalore team as well. Thank you so much.
All right, thank you, everyone. So we plan to bring our next AI conference even on a bigger scale, hopefully as a physical one, with the pandemic ending. Until then, anything you want to add, Venkata, before I conclude?
Nothing else.
Okay, so then until then, take care and stay safe, everyone.
Thank you all. Thank you so much.